everyone and welcome to this full course on cloud computing. Cloud computing is a game changer for businesses offering scalable, secure and cost-efficient IT solutions. This technology enables organizations to store, process and manage data seamlessly while ensuring flexibility and innovation. Whether you're a beginner or an experienced professional, this course covers everything from cloud fundamentals and AWS services to security and networking. With cloud computing, you don't just manage infrastructure, you drive agility, optimize performance, and shape the future of technology. With that said, let's outline today's agenda for this cloud computing full course. We will begin with an introduction to cloud computing, exploring its benefits, architecture, and role in modern IT infrastructure. Next, we will dive into AWS, covering its core services and certifications to help you advance your cloud career. We will then discuss cloud storage on AWS, focusing on AWS S3 and its use cases. Moving forward, we will explore AWS Networking Fundamentals, including AWS CloudFront for content delivery and AWS IAM for identity and access management. We will then cover cloud security best practices to protect cloud environments, followed by AWS CloudFormation for infrastructure automation and Amazon CloudWatch for monitoring and observability. We will also introduce AWS Lambda for serverless computing and AWS Elastic Beanstalk for easy application deployment. We will also explore Amazon Redshift for data warehousing, AWS Kinesis for real-time data streaming, and AWS API Gateway for managing APIs efficiently. Next, we will discuss Amazon SaaS for email services and AWS CodePipeline for CI/CD automation. Finally, we will outline an AWS learning roadmap, providing a step-by-step guide and conclude with AWS interview question and answers to help you prepare for a successful career in cloud computing. But before we begin, make sure to subscribe to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Edureka's Cloud Architect Masters program provides comprehensive training in cloud computing, covering AWS, Azure and Google Cloud. With hands-on labs and real-world projects, it's prepare you for the key roles like Cloud Architect and Solutions Architect. The program includes in-depth learning on cloud security, networking, DevOps, and multi-cloud strategies to enhance your expertise. Also, Edureka's AWS certification training in collaboration with PwC Academy equips you with the essential AWS skills covering EC2, S3, IAM, CloudFormation, and Lambda. With expert-led sessions and hands-on labs, it prepares you for AWS Solutions Architect Associate certification, aligning with industry standards and job market demand. So check out the course link in the description box below. Now, let's get started with our first topic, what is cloud computing?
What is cloud computing? Everything nowadays is moved to the cloud, running on the cloud, accessed from the cloud, or maybe stored in the cloud. So what exactly is the cloud? Simply put, cloud computing, often referred to as the cloud, is a service that allows people to use online services that are generally available through any device with an internet connection. This means that the user does not need to be at a certain location in order to access certain data. From computing and analytics to secure and safe data storage and networking resources, everything can be delivered within no time thanks to the cloud. The goal of cloud computing is to deliver these services over the internet in order to offer faster innovation, flexible resources, and economies of scale. Have you ever realized that you probably have been using different cloud-based applications every day? Whenever you share an important file over OneDrive with your colleague through the web or use a mobile app, download a picture, binge watch a Netflix show, or play an online video game, it all happens on the go. The best part, it saves you a lot of money and time. You don't have to buy any machinery or install any kind of software. Everything will be handled by the cloud platform which is running these applications, whether it's Google, Microsoft, or Amazon. Many such tech giants have already switched from traditional computer hardware to more advanced cloud architecture. Not just that, these companies are also the most popular cloud service providers in the market today. As more and more companies undergo strategic digital transformations designed to utilize the power of the cloud, they need more IT professionals and leaders with the expertise to extract the best business results out of their investments.
So a bit of a primer in terms of what a cloud environment is and what is cloud computing. So essentially, cloud computing is availability of IT resources on a demand basis, on a pay-as-you-go basis with respect to cost, and the services should be available over the internet. So this is the most generic definition of a cloud computing model, wherein cloud computing in general, be it a private cloud, be it AWS, Azure, or any kind of a cloud environment, wherein the services are available on demand basis, available over the network with pay-as-you-go pricing model. So this is a definition at a very high level, wherein you'll get IT resources of your choice. So the IT resources could include network, it would include servers, databases, management tools, DNS services, any IT service that you can think of. So at a broader level, this is the definition of cloud computing and what a cloud is. So essentially, it is the responsibility of the cloud provider to provide all these services to you, wherein you as a customer really sign up with the cloud provider and those services would be made available to you on a need basis. So for example, let's say you are a Flipkart or a Amazon or a eBay. So on a specific day, if the traffic was to increase exponentially. So in a traditional environment, handling these kind of situations is pretty complex, wherein you are limited by a number of IT resources that you have. It could be compute resources, storage requirements, or scaling up your database services. But within cloud environment, it is just matter of minutes doing some configurations wherein you can scale up and scale down based on need basis. So there are certain attributes that any cloud model should support. The first one is on-demand self-service, wherein, as I mentioned, the services should be available on a demand basis. So if I need 10 servers, the servers should be made available to me. So this was a typical challenge in traditional environments, wherein you are limited by IT resources that you might have. Then the services should be available over the network. So predominantly the word internet is used, but in generic terms, it could be any network. So regardless of my location, let's say I'm sitting in US right now and I want to provision a resource in Europe region. So regardless of the location where I am, I can provision resources in any geographical location of my choice. Then it should support the concept of rapid elasticity, which actually refers to, as I mentioned, you want to scale up or scale down. So a simplest example would be you need more servers on a given day. So let's say you want to expand from 100 to 200 servers. You anticipate spike in traffic. So it's just a matter of configuration. There are very variety of services should be available rather to help you scale up. And when you don't no longer need it, you can actually scale back down. So you only pay for the duration wherein you need extra resources. So that way, it's a savior in terms of the amount of money that you would have spent on the scaling up and scaling down process. Then it should be a measured and a billable service. So that's one of the fundamental aspects. So how do you bill a end user or a customer? So the service should be measurable and likewise billable. Last option is resource pooling. It should support the concept of multi-tenancy, wherein resource can be shared across multiple users or customers. Why there was a need for cloud environments. So right now I'm keeping the definitions that are applicable to be it a public cloud or be it a private cloud or a hybrid cloud. I'll be explaining these terms very shortly. So the need was very simple, wherein companies, rather than focusing on infrastructure requirements, they could actually focus on developing the applications or technology stacks that they wanted to build and serve to their end customers. Then faster service provisioning, and that's one of the very important features we'll see through the program, that how easy it is in a cloud platform to provision services and start consuming them. So net result is that you get more efficient, more productive, and able to market your products at a much faster rate. Then you have cost effectiveness. So again, with cloud models, specifically with respect to public cloud offerings, you don't have to spend any money as a upfront cost to build that particular service. So let me take a very simple example. Let's say you want to provision a virtual server in your environment. So you'll need an underlying network for sure. You'll need power systems, backup systems, multiple internet connections coming in. then you'll need the physical host, then you'll need to purchase licenses for the hypervisor level, and then on top of it, you will be provisioning your virtual servers, and then you need to have some kind of a storage environment. So that calls in for a lot of cost. Whereas in the cloud model, you can escape all of this. So you only pay for the duration where you have consumed the resource. So the cost is variable based on the resource that you want to provision. But in most of the cases, you pay by an hourly basis. So for example, you want to set up a test environment for 2 days, just go ahead and provision the environment in the cloud, trash it after 2 days, you only end up paying for those 2 days. So pricing is one of the aspects. Other aspects could be performance, security, fault tolerance. So all these aspects have to be weighed in. And last option is dynamic scaling. This refers to the elasticity property that we just discussed, that the service should be able to scale up or scale down. Since most of the services are managed by the cloud provider, so you can best be assured of that the services would be highly available and fault tolerant. So a couple of other advantages. So I've already spoken about cost. So this is point number 2, trade capital expenses, which refers to no upfront cost involved. Just you can go ahead and pay as you go model. Next advantage is go global in minutes. So with a player like AWS, which has a presence across the globe, so you could set up your technology stacks in any region of your choice, in any geographical location of your choice. Or if your business is expanding and you need to have multiple deployment regions, you can use AWS as a single player. So many organizations have their technology stacks deployed in, let's say, London, US. They have different stacks. They have tie-ups with the different service providers. So in this case, if you were to select AWS, using AWS platform, you could have your deployments in multiple regions. Then you benefit from massive economies of scale. So the cost at which AWS can procure a service versus the cost that you as an individual customer would have to pay for varies significantly. And Amazon believes in charging the customers less wherever they pay less. So this simply means that, let's say, if the cost of procurement of a service for Amazon is less in a specific geographical location, they would be charging the customers accordingly. If the cost is low, they would be charging you low. If the cost is high, they'll be charging you high. So that means your pricing would vary from one geographical location to another geographical location. So the variance is not significant, but if you're talking at scale, yes, these things would definitely come into play. And lastly, no guessing about capacities. So this is, I think, one of core features wherein in traditional environments, once if you have scoped out for various IT resources, if you were to scale up, again, you would have challenges. Whereas in the cloud environment, you can scale up based on your demand needs, and then you can scale back. So this in totality sums up what are the various benefits associated with the cloud computing. So these are applicable across all the players that are rendering cloud services, be it AWS, Azure, Google. The benefit that you get with AWS is, number one is the set of services that they have to offer. So they offer in excess of 100 services to the customers. They have a very wide footprint across the globe. So if you're a global organization, or for that matter, even a localized organization, you can sign up for services on AWS. Over the last several years, various cloud computing models have evolved. The first one being infrastructure as a service. So in this model, essentially what you leverage is IT resources from the cloud provider. You manage them. You are responsible for your application, their maintenance, and so on. So essentially from the cloud provider, you are picking up IT resources such as network, servers, storage. You'll need to manage every aspect of it. I think we have a great slide ahead that gives you a good comparison with respect to each cloud computing platform. I just spoke about infrastructure. So network storage, servers, and virtualization, typically these are controlled by the vendor. And you as a customer, you are responsible from operating system level and above. Coming to platform as a service, the provider would give you the platform. The platform could be Java, .NET, Node.js, any environment that companies work on. And in this case, the vendor is responsible to manage till the runtime environment. And you as a customer are responsible for developing your applications and data. So good example would be Google Sites. If you want to develop a site, you really don't know what kind of infrastructure, underlying infrastructure and the underlying platform that Google is running. And then you have software as a service, wherein you are the end user of that service. So good examples of this would be, let's say, applications like Gmail, Office 365, wherein as a customer, you only care about the features and services extended by these applications. You don't care about the underlying infrastructure or what are the underlying platforms these are hosted on. So you're getting that as a service, as an end product. And lastly, you have on-prem. So on-prem is something that you control everything in totality. So this is in quite contrast to all the other three models. So on-prem, which is the traditional model, wherein if you want to have a very tight control over your environment, there are some security concerns that might not be addressed by cloud environments. So in those cases, you can build your own environments. So I've spoken about platform as a service. Then you have software as a service. We have already spoken about. So the variety of deployment models, you have public cloud platforms. So players like Google, Microsoft, Azure, even IBM has one software. So these are the public cloud platforms that are available for the end users. Then you have private cloud platforms. So this is where this refers to the private cloud model that we just saw. So you as a customer are responsible for it. Then you have hybrid. So hybrid generally refers to if you're consuming services across two platforms. So two environments rather. So one environment could be in AWS. The second environment could be a private data center that you own. So these are generally referred to as hybrid environments. And then community model, wherein several organizations come up who have a similar set of needs, they set up their own environment. So they are actually sharing the cost of that particular environment, and the services are being used by multiple organizations. Okay, so moving on, let's start with the introduction to AWS. So AWS, as we have said, is a public cloud platform extending IT resources such as compute, database storage, network, content delivery services. And it offers more than 100 services actually. And while going through each of these services, we'll also see the cost aspect of it, wherein for every resource that you use, you are charged on an hourly basis. So there was a market survey for public cloud adoption for the year. There was a comparison between 2017 and 2018. So AWS, as it stands today, controls 64% of the cloud market, and rest of the players, barring Azure, no one is even close. So I'll come back to this slide. So essentially, this is talking about various services on AWS and equivalent services that are available. So these are the most common used services, such as EC2 is your virtual servers. So in AWS, they're termed as EC2. Azure refers them to as virtual machines. Google refers to them as compute engine. So different players, different terminologies that they follow. So set of core services, they are being represented by different names in different environments. So there are various benefits. We have already spoken at a higher level what the benefits of cloud platform are. So all are applicable to AWS as well. Cost effective. We have seen it's a pretty dominant player in the cloud arena. Scalable and provides high performance. Any service that you use, if it's a compute resource, you're using network resources, you're using database resources, any application services such as email services or notification services, monitoring services, these are highly scalable and can deliver the performance. Very easy to use. As we'll see when you provision the resources, it's pretty easy to set up these services and integrate it within your applications. The services are reliable since these services are managed by AWS. So AWS takes the responsibility of managing and maintaining these services. Then with respect to security, so security again here, there are a couple of things that would fall under AWS responsibility and a couple of things that would be responsible that the customer would be responsible for. So we cannot take it for granted that AWS is responsible for total security of your technology stack. So while talking about each service, we'll go through this aspect for sure, the security aspect, because that is one of the most concerning factors while making a decision on moving to cloud. Refer to the illustration on the screen. So you have AWS global infrastructure. So this refers to Amazon's footprint across the globe. So this is essentially divided into three parts. You have regions, availability zones, and edge locations. So on top of this infrastructure, they have classified certain set of services as foundation services, such as compute, storage, database, and networks. So the idea here is that any technology stack cannot be completed without these four foundation services. So you'll need compute resources, you'll need the servers, you'll need storage for sure, you'll need a network in which you want to operate within AWS, and then any application would need a database in the backend. So these services are referred to as foundation services, and the idea here is that any application will have to use all these four foundation services. And then on top of it, again, it is customer's choice that whether they want to use any other service over and above the services that are mentioned here. So the first term that I'll be talking about in context to AWS is the term regions. So regions, essentially, they are geographical locations in which AWS has the presence. So I'll just log into the portal. Shortly, I'll demonstrate on how do you sign up for the free tier account as well. So when you sign up for the account, essentially you supply an email address and you set up a password. So that's what I'm using to sign up, or rather logging to my account. So on the top right hand corner of your browser, you would see the region in which you have logged in. So any resource that I provision would be logged in the Oregon region in this case. So as of today, Amazon is operating out of 18 regions across the globe. So regions, they are synonymous to geographical locations in which the AWS operates. So it's a separate geographical region. I'll come to availability zones in a bit. So first, let's talk about on what should be the criteria in choosing a right region. So the first aspect is service availability. So let's say you want to use foundation services are available across all the regions. So let's say you are looking out to set up a warehousing solution, and for any newly provisioned region, warehousing solution might not be available for the initial period. So in that context, as a solution architect, you need to figure out that whether the service is available in the target region of your choice. The second aspect that you would be looking at is security and compliance requirements. So let's say you're working in healthcare organization in US. So law of land states that the data needs to be sitting in US. So naturally, from a security perspective and compliance perspective, your choice would be somewhere in US. Then the third aspect is cost, which refers to, as we said, that pricing of a service, they're not similar across all the regions. So if you are talking at scale, this could also be one of the deciding factors. And then you have user location and latency. So this refers to, let's say my target audience is in, let's say, Asia. So what region should I select so that users are closest to my application? So my obvious choice would be, let's say, Singapore in this case. So combination of all these factors would help you decide which region to choose in which you want to provision your environments. So based on various factors that we spoke about with respect to selecting a region, the factors that we discussed was service availability, service and compliance requirements, cost, proximity to the end user or latency. So based on these factors, so in this case, you see an analysis has been made with respect to a specific virtual server, and the region, the North Virginia region, is the cheapest, wherein you pay about $460, and the maximum is Sao Paulo, which is $719. So this is only with respect to cost. The second term that we should be familiar with is availability zones. So availability zones are essentially the data center environments that we refer to in day-to-day basis. So essentially, availability zones are data center environments that AWS has. So let's say this is a specific region R, and by design, whenever AWS comes up with a new region, by design at the bare minimum level, they'll have two availability zones. So essentially, these are two data center environments that AWS comes up with, and the services that they offer, these are extended by these availability zones. So both the availability zones, so in this case, we're talking only about two. So there are regions in which they would have as many as 6 availability zones within a same region. Also, these availability zones are connected with very high speed networks, low latency networks. So the idea here is that from a solution architect perspective, that you should have a distributed workload across two availability zones. So in the event of availability zone going down, your application would still be available from the second availability zone. So I recall a scenario a couple of years back. There was an electrical storm in North Virginia region causing an outage in one of the availability zones. So since our workloads were distributed across two availability zones, our application was not impacted. So by design, at the bare minimum, every region would have two availability zones. So this is to ensure highest level of availability for your technology stacks. And from a solution architect perspective, you need to make sure that your workloads are distributed across multiple availability zones. So for example, in the North Virginia region, if you were to take a look at number of availability zones that we have 6 availability zones. So it is up to the customer on how many availability zones that you may want to use. So this is to ensure the highest level of availability for your applications. So if you were to take a look at some another region, let's say Mumbai. So in the Mumbai region, you'll see 2 availability zones. So number of availability zones by design is 2. So they can add more availability zones, and that depends on the volume of business that they generate from that specific region. So availability zones, they are data center environments from where AWS services are rendered, and you need to design your applications in a distributed fashion across multiple availability zones to ensure highest level of availability and fault tolerance. So we'll see that how do we distribute our workloads across multiple availability zones. So by design, we have already said it will have bare minimum 2 availability zones. So you need to have distributed workloads, be it any tier of your application, web tier, application tier, database tier. So you need to have distributed workloads across by leveraging multiple availability zones. So this is a great slide that you see in terms of achieving high availability for your technology stacks. So on the left hand side, if you're a customer who is on AWS and you have selected any region for deployment of your application, so you're leveraging multiple availability zones out here. So in this case, you could achieve high availability by leveraging a single availability zone by provisioning multiple resources within the same availability zone. A good design, no single point of failure. But what happens if AZ1 was to go down? So if this was to go down, even if I have multiple resources in this availability zone, if the AZ goes down, everything is down. So a better idea is to leverage multiple zones wherein you are spreading your workloads across two availability zones. So even if one goes down, you're still good. So now if you were to move on a higher availability scale, you could choose two deployment regions. So again, you could leverage the same approach as we saw in the first region, wherein again, you are leveraging multiple AZs. This is generally used for building up of DR environments, part of BCP, business continuity planning. You could leverage multiple regions. In addition, let's say what happens if something happens to AWS for some reason, all the regions are impacted. So in that case, you could leverage two cloud platforms. So as you see in the screen, you have AWS and Azure. So you could have one deployment in AWS and the second deployment in Azure. But keep in mind on the scale, if you refer, the more you move on the higher availability side, there'll be a price impact as well. So again, you'll have to check out with your organizations what are your SLAs committed to your internal and external customers. So let's say if you're a banking organization, can you actually afford to have a downtime or some kind of a data loss? The answer is no. So you'll be looking at this scenario in totality. Else, let's say your application, your SLAs are that, okay, if there's an outage of, let's say 10 minutes, that is okay with the customers. So accordingly, will have to design and place your workloads accordingly. So this is an important concept. So now we know what regions are, what availability zones are, and in building up highly available environments. So for example, we'll talk about having deployments in two regions. So you'll need to have some kind of a data replication in place across these two regions. So AWS provides you default connectivity methods wherein resources from one region can communicate over second region. So I'll talk about those connectivity methods in the network section when we talk about it. But with respect to configuration of replication, it is customer's responsibility on how you want to configure replication of your data from one region to the another. So that comes under customer's responsibility, whereas providing a medium for connectivity across these two regions would be AWS responsibility. So again, why replications between the regions? Increase fault tolerance, increase redundancy to reduce latency. Covered that. We've spoken about availability zones. So this is a generic definition of availability, which refers to a system or a component to be operational and accessible anytime. So even if there was an outage, how do you recover from that? Either without any downtime or if any downtime is applicable, how do you recover as quickly as possible? So there are various methods to measure availability. You have terms like MTTR, which is mean time to repair. So anybody coming in from systems background would be able to relate. So these are generic terms that are used to measure availability. So MTTR refers to mean time to repair. So this is the time that you need to fix your service. MTBF is mean time between failures, which means let's say you had a failure day before and a failure today. So what is the mean time between the failure? It is 2 days. Then you can calculate the availability based on the formula given out here. So AWS offers you highest level of availability. So in my experience, one outage that I spoke about that happened a couple of years ago, and that was with respect to one availability zone not being available. So that was due to act of God. These are the things that you can't help out. So even if it was a private environment, your own hosted environment, you would have been impacted. And there was another one brief outage on S3 couple of months back. So even that was taken care of quickly. So you can measure the availability, MTTR, MTBF based on the values that are available. To increase fault tolerance, increase higher levels of availability by design, 2 availability zones per region. And these availability zones are connected by very high speed, low latency networks. So with respect to why high availability is essential, so acts of God such as earthquake, flooding, you could have hardware outages, power outages, issues related to software, network outages, and lastly, with respect to data. So from your perspective, you'll need to figure out that where all you need to build redundancies. So as part of AWS global infrastructure, we have spoken about regions, availability zones. The third term that we need to be familiar with is edge locations. Edge locations, they are different than availability zones. So essentially, these are caching locations that are spread across the globe. And as I said, they are caching locations. So if you have a user base spread across the globe and users are trying to access your application, so in a normal case scenario, what would happen is, so let's say this is my deployment region. So let's say this is US. Within US, you have again multiple regions. So let's keep it simple at this point of time. So you have users coming in from Singapore, Australia, and let's say Europe. So you have a distributed user base. All these users might not get the same experience in terms of latency. They might see buffering issues while downloading the content. So couple of approaches to mitigate that is number one, have multiple deployment regions. But again, that can be very expensive. Or use a service like CloudFront. So CloudFront is a content distribution service which actually uses edge locations. So these are edge locations spread across the globe. So please note from examination perspective, edge locations are not availability zones. They're completely different than availability zones. So now if a user from Singapore was trying to access, the user would be directed to the edge location in the Singapore region. Likewise for Australia, he goes to the Australia edge location, and likewise for Europe. Edge locations, they are connected on very high speed networks across regions. So the response that you would see would be far, far better as compared to when the user was trying to access the application directly. So imagine companies like Netflix, Amazon Prime, who are in the business of content distribution. Can they afford to have multiple deployment regions? No. So they'll have a central site and they'll be front-ended by a service like CloudFront, which in the background would use edge locations. So edge locations, essentially, they are caching locations. So the users would be served the content from the edge location directly. So since this edge location is in Singapore, the user would be served the content from the Singapore edge location. So the only exception if the request is new or fresh. So in that case, the edge location will have to actually send the request to the original, and once it gets the response, it would cache the content. So benefits of edge location. So you can cache your data from your applications to AWS edge locations. You maintain a single environment and typically used in content delivery network scenarios. And we only pay for the data transfer that actually happens. We missed out on this slide, which defined latency. So latency is the time required to transfer data from client to server. So round trip time that we are talking about, which is when the request is sent and when the response is received. So in a traditional scenario, it would be higher. Whereas if you are leveraging solution like CloudFront distribution, which leverages edge locations, the response time would be much, much faster. Next, we'll talk about on how do we set up AWS account on the portal. So AWS gives you 12-month free tier account, wherein most of the services that we'll be using for the program, they are covered under the free tier. So that means you don't actually have to pay a dime to use those services. So all what we need to do is we'll go to the portal, make sure you select the account as personal. There are mandatory fields like first name, second name, email address, password, and then you'll also need to supply your credit card details. So that is only for validation purposes. So you're not charged on that credit card. Even to an extent, if you have consumed a service that is not eligible under free tier, it would generate an invoice and notify you. That's about it. So they use credit card only for first time validation. So if you're signing it from India, you are charged, let's say about 2 rupees, else from outside, couple of cents just to validate that you are a legitimate user. So what all services that we are entitled to? You have Elastic Compute, which is virtual servers. So how many hours that single user is entitled to? So you are entitled for 750 hours of virtual servers on these platforms, Linux, Red Hat, and 750 of Windows. So 750 hours is the total time limit that you can use only for a specific instance type, which is T2 micro instance. So this is the instance type refers to the hardware specification, number of CPUs or memory thrown into that particular thing. Likewise for load balancers, again 750 hours. The caveat is 15 gigs of data processing. Then storage, again, what is the amount of storage that you can use? So you can use 30 gigs. And likewise for any other service that it is very clearly marked on the portal which service is eligible under free tier and which is not. So make sure if you're practicing something on AWS, provision the resources and make sure you terminate them once you are done with them. So go to the portal, you can use this link. So go to create a free account. So type in your email address, password, and if you want to give any alias name to your account, else it assigns 12-digit account number. Continue, then specify it's a personal account and specify first name, last name, and the region place where you are signing up. So accordingly, you will be billed. Then provide your credit card information and you are good to go. I'm referring to the document right now. This is the second page. You'll need to select personal out here. Select country wherever you are, region where you are signing it from. That's about it. If you actually look at the URL, if you see it got redirected to one of AWS storage services, which is called S3. So this PDF is actually hosted on S3 storage service. So for any service that you choose, so let's say I want to provision virtual server. So I'll explain these steps. So a specific instance type is only eligible and it would be very clearly marked that whether it is available for the free tier or not. Likewise, any other service that we pick up, a database service or any application service or a monitoring service, very clearly indicated whether they are applicable or not. So I'll be explicitly mentioning that some of the services that we'll do, they are not eligible under the free tier account. So I'll be explicitly mentioning that to you. Also, let's say if you are exceeding your limits or you want to keep a tab on your expenses on your AWS account, AWS gives you the flexibility of creating billing alarms. So billing alarms is a way of getting notified that, so let's say you had a budget of, let's say $100. So you're about to exceed that. So you can set up a billing alert.
Let me ask you a quick question. Have you ever thought about how companies like Netflix, Airbnb, or Spotify manage their data, run their application, and scale so efficiently? The secret lies in the power of the cloud. And for many top companies, AWS is a backbone of their success. With 63% of IT professionals finding it tough to recruit cloud talent, AWS certifications are your gateway to a high-demand career. Salaries for AWS roles in India are around 10 lakh rupees. And in US, they reach up to $120,000. Cloud jobs are set to grow by 28% in the next 5 years. According to Gartner, by 2025, 51% of IT spending will shift to the public cloud. So if you're looking to future-proof your career, AWS certification could be the ultimate step forward. In this video, I'm giving you deep knowledge on 12 AWS certifications across 4 different categories, covering the essentials like exam format, question count, and the ideal candidates for each certification. We'll also highlight newly added certifications, including the AI practitioner for foundational AI skills and machine learning specialty. So, let's understand what exactly is AWS certification now. AWS certification is a program designed to validate your skills and expertise in using Amazon Web Services, or AWS, the leading cloud computing platform powering businesses and applications worldwide. AWS offers a wide range of cloud services, from storage and computing power to machine learning and artificial intelligence. And AWS certification shows that you have the knowledge to leverage these tools effectively. Now we'll understand why is AWS certification important. So, why should you care about AWS certification? Well, it's industry recognized and highly valued by employers. Getting certified proves to potential employers that you have the skills needed to design, implement, and manage cloud-based solutions using AWS. And trust me, that can set you apart from other candidates. Whether you're looking to switch careers or advance your current role, AWS certification can open doors to new job opportunities, career advancements, and even higher salaries. Next, let's explore the various AWS certification levels and what they entail. AWS offers a total of 12 certifications across 4 levels: Foundational, Associate, Professional, and Specialty. Each level caters to different expertise, from beginner to advanced cloud professionals. Here is a quick breakdown of each category. First, we have the foundational level. This is a knowledge-based certification for those who want a foundational understanding of AWS Cloud. The best part, no prior experience is needed for this level. There are 2 certifications here, the AWS Certified Cloud Practitioner and the AWS Certified AI Practitioner. These are perfect for beginners looking to get started with AWS. Next is the associate level. These are role-based certifications that showcase your knowledge and skills on AWS, helping you build credibility as an AWS cloud professional, while no AWS experience is needed. Some prior cloud or strong on-premises IT experience is recommended. This level includes 5 certifications: AWS Certified SysOps Administrator Associate, AWS Certified Developer Associate, AWS Certified Solutions Architect Associate, AWS Certified Data Engineer Associate, and AWS Certified Machine Learning Engineer Associate. Moving on to the professional level. These certifications validate advanced skills needed to design secure, optimized, and modern applications on AWS, as well as to automate processes. For this level, AWS recommends at least 2 years of prior cloud experience. Here, we have AWS Certified Solutions Architect Professional and AWS Certified DevOps Engineer Professional. These exams are for advanced users who can handle complex AWS environments. Finally, there is a specialty level. This level lets you dive deeper and become a trusted advisor in specific strategic levels. For these certifications, check the exam guides on AWS sites for the recommended experience. Specialty certifications include AWS Certified Advanced Networking Specialty, AWS Certified Machine Learning Specialty, and AWS Certified Security Specialty. Each of these focuses on a particular field within AWS, giving you an edge in specialized roles. Whether you're just starting or looking to specialize, there is an AWS certification that's right for you. So first, let's see the foundational level certification. Let's dive deep into the details of the AWS Certified Cloud Practitioner certification. Starting with the category. This certification falls under the foundational level. It's aimed at individuals who want to get a higher level understanding of AWS Cloud, even if they are new to IT or cloud computing. Then we have the exam duration. You'll have 90 minutes to complete the exam. Exam format is that the exam consists of 65 questions. You'll see a mix of multiple choice and multiple response questions. The cost of the exam is $100 USD. Remember, pricing may vary slightly with foreign exchange rates. So check AWS exam pricing for up-to-date details. Then, where to take the test? You can take the exam at the Pearson VUE Testing Center or through an online proctored exam. The certification is accessible in multiple languages, including English, Japanese, Korean, etc. Now we'll cover what the AWS Certified Cloud Practitioner exam tests on you. You'll need to know these points as well. First, explain the value of the AWS Cloud and how it benefits organizations. Understand the AWS Share Responsibility model to know what responsibilities lie with AWS and what remains with the customer. Understand security best practices for keeping data and also applications secure. Understand AWS cloud costs and billing practices to effectively manage and forecast cloud expenses. Describe core AWS services like compute, network, database, and storage. Lastly, identify AWS services for common use cases to solve different business problems. To prepare for the AWS Certified Cloud Practitioner exam, here are the key concepts you should have the basic understanding of. First, AWS cloud concepts for a broad understanding of the cloud. Security and compliance in AWS, including best practices to safeguard data. Core AWS services that are most commonly used. And last is economics of AWS cloud to understand costs and also value. Now let's see the job tasks that are out of scope. For this exam, you are not expected to perform technical tasks like coding, designing cloud architectures, troubleshooting, implementing, or load and perform testing. And that's the overview of AWS Certified Cloud Practitioner certification. It's an ideal starting point for anyone looking to build foundational cloud skills and understand AWS at a higher level. Now let's see the AWS Certified AI Practitioner. Let's take a structured look at AWS Certified AI Practitioner certification, especially if you're aiming to validate your skills in artificial intelligence and machine learning on AWS. The category is the certification fails under the foundational level. It's meant for individuals who work with AI and ML technologies on AWS, even if they're not directly building solutions. The exam duration is 90 minutes. The exam format is you'll encounter 65 questions, covering multiple choice and multiple response types. The cost for the certification is $100 USD. As always, check AWS official pricing page for any variations based on exchange rates. And then, intent candidates. This certification is perfect for those who may not necessarily build AI ML solutions but are familiar with these technologies on AWS. Testing options are, you have flexibility here. You can take the exam at the Pearson VUE Testing Center or through an online proctored exam. Next, languages offered. The exam is available in English, Japanese, Korean, and so on. This certification validates your understanding of in-demand concepts in artificial intelligence, machine learning, and generative AI. This can sharpen your competitive edge and position as well for your career growth and better earning opportunities. Now let's get into what this exam covers. Candidates are expected to demonstrate the ability to understand AI, ML, and generative AI concepts, methods, and strategies, particularly how they apply on AWS. Ask relevant questions within their organization to determine the best uses of AI ML technologies. Determine the correct type of AI ML technologies for specific use cases. Lastly, use AI ML and generative AI technologies responsibly to ensure ethical and effective deployment. Next, let's see the recommended AWS knowledge. Although you do not need extensive AWS experience, familiarity with a few key areas can be helpful. Those are core AWS services like Amazon EC2, S3, AWS Lambda, and SageMaker. An understanding of AWS's shared responsibility model, especially around security and compliance. AWS identity and access management for resource access control. Lastly, knowledge of AWS's global infrastructure and service pricing models. Now let's move on to job tasks that are out of the scope. For this exam, You won't be expected to perform technical tasks such as developing AI/ML model, conducting data engineering, hyperparameter tuning, and implementing security protocols for AI systems. This certification focuses on more practical AI/ML knowledge rather than hands-on development. Now let's look at the exam content. The exam includes a mix of question types to assess your knowledge, such as multiple choice and multiple response questions, where you'll pick one or more correct answers, ordering questions, where you'll arrange responses in the correct sequence, matching questions, where you'll match items based on prompts. Lastly, case studies, where you'll analyze a scenario with multiple questions to assess your applied knowledge. And that's a structured look at the AWS Certified AI Practitioner certification, perfect for professionals seeking to deepen their understanding of AI and ML concepts on AWS and to start their AI journey on a solid foundation. Now let's dive into the AWS Certified Solutions Architect Associate certification. This is one of the most popular AWS certifications and an ideal choice if you're looking to deepen your cloud architecture skills. The category of the certification is at associate level, perfect for those with foundational AWS knowledge or IT experience, whether in the cloud or on-premises. The exam duration is you will have 130 minutes to complete the exam. The exam format includes 65 questions, mostly multiple choice or multiple response. The cost is $150. Be sure to check AWS's official pricing page for any regional cost variations. The testing options are, you have the option to take this exam at the Pearson VUE Testing Center or through an online proctored exam. The languages that they offer is, this exam is available in English, French, German, Italian, and so on. This certification is designed for those who want to architect cost-optimized, high-performing cloud solutions on AWS. Let's cover the core skills the exam assesses. Candidates should be able to design solutions with AWS services to meet current and projected business needs. Develop architectures that are secure, resilient, high-performing, and cost-optimized. Lastly, review existing solutions and identify areas for improvement. And next, target candidate description. The ideal candidate should have at least 1 year of hands-on experience designing cloud solutions using AWS services. Now understand the exam content. There are two main question types on the exam. Multiple choice, where you'll select the one correct answer. Multiple responses, where 2 or more answers may be correct out of 5 or more options. One more important thing is, unanswered questions are scored as incorrect, but there are no penalty for guessing. Remember, the exam includes 50 scored questions and 15 unscored questions. AWS gathers data from these unscored questions to evaluate them for future use, and they won't affect your overall score. Next, about the exam results. The exam is scored on the scale from 100 to 1000, with a minimum passing score of 720. This compensatory scoring model means you do not need to pass each section individually, only the overall exam. Your results will include a classification of your performance in each section, giving you insight into your strengths and areas to improve. Some sections carry more weight, meaning they have more questions and can impact your score more heavily. Moving ahead, let's explore AWS Certified Developer Associate certification. This is a key certification if you are looking to enhance your skills in AWS cloud development. The category is, the certification is at associate level, ideal for developers who are ready to showcase their cloud development skills and understand AWS environments. The exam duration is 130 minutes long. The exam format is, it consists of 65 questions including multiple choice and multiple response formats. The cost of this exam is $150. Check AWS's pricing page for additional regional cost details. The testing options are, you can take this exam at a Pearson VUE Testing Center or through an online proctored option. The languages offered are, this exam is available in English, Japanese, Korean, and so on. The AWS Certified Developer Associate certification validates your skills in developing, optimizing, packaging, and deploying AWS applications. It's great for anyone starting out in AWS or working in IT or cloud development roles. This exam is designed to assess the skills like, we'll break down what skills the AWS Certified Developer Associate exam is designed to assess, including developing and optimizing applications on AWS, deploying applications using CI/CD workflows, securing applications code and managing data protection, identifying and resolving application issues. The target candidate description is ideally candidates that have 1+ years of hands-on experience developing application using AWS services. Now let's see the recommended AWS knowledge. You should know how to develop and secure applications using AWS Service APIs, the AWS CLI, and the SDKs. Use a CI/CD pipeline to deploy applications on AWS as well. Now let's see out-of-scope tasks. This exam doesn't cover some tasks like designing architectures. Let's understand exam content. The questions are a mix of multiple choice and multiple response types, where you need to choose one or more correct answers. There are 50 scored questions that affect your final score and 15 unscored questions to evaluate your future use. Moving forward, let's dive into the AWS Certified SysOps Administrator Associate certification. This certification is perfect for those in a cloud operations role and looking to prove their skills in monitoring and maintaining AWS workloads. The category is, this certification is at associate level, ideal for system administrators or those focused on AWS cloud operations. The exam duration is 130 minutes long. The exam format includes 65 questions with multiple choice and multiple response types. The cost for the exam is $150. For additional pricing details, check the AWS website. The testing options are, you can take the exam at the Pearson VUE Testing Center or online through a proctored exam. The languages that they offer is, the exam is available in English, Japanese, Korean, and simplified Chinese. The AWS Certified SysOps Administrator Associate certification validates your expertise in monitoring AWS workloads, implementing security controls, and applying networking concepts. It's ideal if you are in an IT role involving AWS cloud administration. Now we'll walk through the core areas this exam covers, including supporting and maintaining AWS workloads based on AWS well-architectured framework, operating workloads using the AWS Management Console and CLI, implementing security controls for compliance, monitoring, logging, and troubleshooting AWS systems, applying networking concepts like DNS and TCP/IP. Lastly, performing business continuity and disaster recovery procedures. The target candidate description is, ideally, candidates have 1 year of hands-on experience managing AWS workloads, with skills in networking, security, and troubleshooting. The recommended AWS knowledge and experience are, candidates should have at least 1 year of experience with AWS technology, proficiency with the AWS Management Console and CLI, and an understanding of the AWS well-architectured framework. Now, about the exam content. The questions are a mix of multiple choice and multiple response, with 50 scored questions that impact your score and 15 unscored questions that AWS uses for future testing. Now, the another certification, so-called AWS Certified Data Engineer Associate exam. If you are looking to prove your skills in managing data on AWS, this certification is for you. The exam is an associate level certification, so it's perfect for those with some experience in data engineering, but not quite for experts. You have 130 minutes to complete the exam, which is about 2 hours and 10 minutes. There are 65 questions in total. Some will be multiple choice and some will be multiple response. The cost is $150. Now let's see where you can take it. You can take the exam either at a Pearson VUE test center or online with a proctor watching you from home. The exam is available in English, Japanese, Korean, and simplified Chinese. Basically, this certification is all about working with data on AWS. The exam checks your skills in tasks like ingesting and transforming data, getting data ready for use, creating data pipelines, that is orchestrating how data moves and changes, designing data models, making sure data is organized in the right way. Lastly, maintaining data quality, keeping your data clean, secure, and properly governed. The exam also tests your ability to monitor and optimize data pipelines, ensuring things run smoothly and cost-effectively. Who should take the exam? The exam is meant for people with about 2 to 3 years of experience in data engineering and at least 1 to 2 years of hands-on AWS experience. What you should already know. You should know how to set up and maintain ETL pipeline, that is extract, transform, load for data. Use basic programming concepts to build these pipelines. Understand how to use Git for version control and data lakes for storing data. Lastly, have a general understanding of networking, storage, and computing. In AWS, you should know how to use AWS services to build and manage data pipelines. This includes things like encryption, data protection, and logging. You should also be able to write SQL queries on AWS services to analyze data. Moving ahead, understand about the certification exam. This exam will have two types of questions. Multiple choice, in which one correct answer is given. Multiple responses, where you'll need to pick more than one correct answer. Next we have is AWS Certified Machine Learning Engineer Associate. Alright, let's break down what you need to know for AWS Certified Machine Learning Engineer Associate exam. The duration and questions are, you'll have 130 minutes to complete 65 questions. The cost of the exam fee is $150 USD. Where to take the exam? You can choose to take the exam either at a Pearson VUE test center or online with the proctor. The exam is offered in English, Japanese, Korean, and simplified Chinese. This certification is aimed at individuals with at least 1 year of experience using Amazon SageMaker and other machine learning tools on AWS. If you're a backend software developer, DevOps engineer, data engineer, MLOps engineer, or data scientist, this is for you. Now, the target candidate should have a year of experience using SageMaker and also be familiar with related AWS services. Here's what you should already know before taking the exam. A basic understanding of common ML algorithms and when to use them. Knowledge of data engineering, like how to ingest and transform data for ML pipelines. Experience with CI/CD pipelines and infrastructure as a code. Lastly, familiarity with software engineering best practices for creating clean, reusable code. Now on the AWS side, make sure you also know how to use SageMaker for building and deploying models. Work with AWS data services for preparing data for ML models. Deploy applications and infrastructure on AWS. Use monitoring tools for logging and troubleshooting ML systems. Set up automated CI/CD pipelines using AWS services. Lastly, understand AWS security best practices for identity management, encryption, and data protection. Now let's dive into the AWS Certified Solutions Architect Professional exam. Here's what you need to know. This is for professionals with at least 2 years of hands-on experience designing and deploying cloud architecture on AWS. Before you dive into the exam, you should be comfortable with the tools like AWS CLI, AWS APIs, AWS CloudFormation, and the AWS Management Console. Plus, knowing a scripting language and having experience with both Windows and Linux environments is a plus. You should also have the skills to provide best practice guidance on architecture across multiple applications and enterprise projects. Map business goals to architectural needs. Make architectural recommendations for implementing and deploying applications on AWS. Design hybrid architectures using AWS technologies like VPN and AWS Direct Connection. Lastly, set up continuous integration and deployment processes on AWS. We look at the format, question types, and also everything you need to know. You'll have 180 minutes to answer 75 questions, which will be in either multiple choice or multiple response format. The exam costs $300 USD. You can take the exam at a Pearson VUE test center or choose it on online proctored exam. To earn the certification, you need to pass SAP C02 exam. And don't worry, there is an exam guide to help you prep. Now let's dive into the AWS Certified Security Specialty exam. Who should take this exam? This exam is for professionals working on security roles. If you're securing AWS products or services, the certification is for you. I know you will be having the doubt of experience level, right? The ideal candidate should have 3 to 5 years of experience in designing security solutions, with at least 2 years of hands-on experience securing AWS workloads. Before you take this exam, you should have a knowledge of the AWS Share Responsibility model, security controls on AWS environments, logging and monitoring strategies, vulnerability management and security automation, integrating AWS security services with third-party tools, disaster recovery controls like backup strategies. Lastly, cryptography, key management, and identity access management. Now let's talk about the AWS Certified DevOps Engineer Professional exam and how it can level up your career in cloud engineering. Who should take this exam? This exam is designed for individuals at least having 2 years of experience working with AWS environments. It's for professionals who want to demonstrate their expertise in provisioning, operating, and managing distributed systems on AWS. Before you take the exam, you should be familiar with Programming, that is, experience in at least one high-level programming language. Infrastructure automation, building highly automated infrastructures. Next is operating systems, administering different operating systems. DevOps methodologies, understanding modern development and operation processes. Next comes continuous delivery systems, implementing and managing continuous delivery systems on AWS. Security and governance, automating security controls, compliance validation, and governance processes. Last is the monitoring and logging, defining and deploying monitoring, metrics, and also logging systems on AWS. Now let's understand about the exam. You'll have 180 minutes to answer 75 questions in multiple choice and multiple response formats. The exam costs $300. And about location, you can take the exam either at a Pearson VUE test center or online with a proctor. Next, here's the key knowledge you need before taking the exam. 2+ years of experience, provisioning, operating and managing AWS environments. Experience with software development lifecycle and programming or scripting. Automating infrastructure and understanding modern development processes. Lastly, securing AWS infrastructure is also recommended knowledge. The exam consists of 2 types of questions. Multiple choice, where 1 correct answer and 3 distractors. Multiple responses, 2 or more correct answers from a list of 5 or more options. Now let's dive into the AWS Certified Security Specialty Exam and see how the certification can set you apart in cloud security. The exam category is a specialty level certification, perfect for those who want to showcase expertise in AWS security solutions. I know you will have a doubt of how exam is like. You'll have 170 minutes to complete 65 questions in both multiple choice and multiple response formats. The exam costs $300. Where can you take this exam? You have 2 options for taking the exam. An in-person test at Pearson VUE testing centers or an online proctored exam. This exam is offered in 6 languages like English, Japanese, Korean and so on. Now let's see what is the certification about. The AWS Certified Security Specialty validates your skills in creating and implementing secure AWS solutions. It tests your knowledge of data classification and AWS data protection mechanisms, data encryption methods and how to implement them on AWS. Lastly, secure internet protocols and AWS mechanisms for securing data transfers. Who should take this exam? If you're in a security role, this certification is a great way to validate your skills. The exam is designed for candidates who have a solid understanding of data classifications, encryption, and secure internet protocols. 2 or more years of production deployment experience in AWS security services. Lastly, the ability to make the trade-off decisions regarding costs, security, and deployment complexity. What knowledge should you have? Candidates should have the following experience and understanding of AWS Shared Responsibility Model and its practical application. Security controls for AWS environments. Logging and monitoring strategies, vulnerability management and security automation, how to integrate AWS security services with third-party tools, cryptography, key management, and identity access management. Lastly, threat detection and incident response strategies. The exam consists of 2 types of questions. That is multiple choice, where 1 correct answer with 3 distractors. Next, multiple response, 2 or more correct answers from a list of 5 or more options. And remember, unanswered questions are scored as incorrect, so there is no penalty for guessing. Ready to become AWS certified? This certification is a great way to validate your security expertise and gain confidence in your ability to secure AWS solutions. Now, we are diving into the AWS Certified Machine Learning Specialty Certification, designed for anyone serious about ML development in the AWS cloud. What does this credential do? It's designed to help organizations identify and grow talent for critical cloud initiatives. If you are into building, training, tuning, and deploying machine learning models on AWS, this certification can be a game changer. Who is this exam for? This certification is perfect for developers and data scientists with over 2 years of hands-on experience in machine learning or deep learning on AWS. You should also be comfortable with the intuition behind ML algorithms, basic hyperparameter optimization, familiarity with ML and deep learning frameworks. Lastly, best practices in model training, deployment, and operations. How do you earn the certification? To earn the certification, you will need to pass the AWS Certified Machine Learning Specialty Exam. The test includes 65 questions, with a mix of multiple choice and multiple response formats. What about the logistics? You'll have 180 minutes to finish the exam. It costs $300 and is available at both Pearson VUE testing centers and as an online proctored exam. The exam is offered in 4 languages: English, Japanese, Korean, and simplified Chinese. Now let's see, what knowledge will you be tested on? The exam validates a candidate's ability to select the right ML approach for a business problem, choose the right AWS services to implement ML solutions. Lastly, design and implement scalable, cost-effective, secure ML solutions on AWS. Let's see the ideal candidates. Those who have 2+ years of experience in developing, architecting, and managing ML workloads on AWS are the best fit. Additionally, target candidates should understand basic ML algorithm intuition, hyperparameter tuning, frameworks for ML and deep learning. Lastly, best practices for training, deployment, and operations. Next, let's see how are the questions structured. The exam has 2 types of questions: multiple choice, where 1 correct answer with 3 distractors, and then multiple response, 2 or more correct answers out of list of 5 or more. As same for every certification, there is no penalty for guessing. So if you're unsure, go ahead and make an educated guess. Moving forward, let's explore the last certification, that is AWS Certified Advanced Networking Specialty Certification, ideal for those ready to make their networking skills to next level with AWS. Now let's see what is the certification about. This credential is designed to validate expertise in designing and managing network architecture across AWS services, helping companies identify professionals with the right skills for complex cloud networking tasks. We will also see who should consider taking this exam. This certification is aimed at individuals with 5 years of hands-on experience in networking, specifically in architecting and implementing network solutions. Recommended experience includes in-depth knowledge of AWS technologies and security best practices, familiarity with advanced networking architecture like IP VPN, MPLS, and VPLS, experience with automation tools for designing, implementing, and optimizing network architectures, including routing and multi-region setups. Lastly, knowledge of CIDR, subnetting, AWS WAF, IDS, IPS, DDoS protection, and EDOS mitigation. Now let's see how do you earn the certification. To achieve this, you'll need to pass the AWS Certified Advanced Networking Specialty exam. It consists of 65 questions in both multiple choice and multiple response formats. What's the exam logistics? You'll have 170 minutes to complete the exam, which costs $300. You can take it at a Pearson VUE testing center or through online proctoring. The exam is available in English, Japanese, Korean, and simplified Chinese. Let's see the skills that will be assessed. The certification will validate your ability to design and implement hybrid and cloud-based networking solutions using AWS, operate and maintain network architectures for AWS and hybrid environments, use AWS tools for deploying and automating networking tasks. Lastly, secure AWS networks using native AWS networking tools and services. Now let's see what kind of candidate is the best fit for the certification. Ideally, candidates should have at least 5 years of networking experience and 2+ years in cloud and hybrid networking. Key knowledge areas include AWS networking details and how they integrate with other AWS services, security best practices for AWS. Lastly, understand of AWS compute and storage options. How are the questions structured? You'll encounter multiple choice questions with 1 correct answer and 3 distractors, multiple response questions with 2 or more correct answers among 5 or more options. So, if you're serious about building secure, reliable network architectures on AWS, the AWS Certified Advanced Networking Specialty Certification can be an invaluable credential for your career. So, that wraps up our overview of all the AWS certifications. So, if you've got your certification, you'll have access to great career opportunities. Now let's go to the career opportunities. You could work as a cloud architect, solution architect, DevOps engineer, data engineer, or security specialist. The pay will depend on your experience and where you're based. But these roles offer excellent career growth and good salaries. Let me tell you some exam preparation tips. Once certified, you'll have an amazing career opportunities. But before you go, here are some quick exam preparation tips. First, use AWS free training. Hands-on labs and practice exams are the must. Apply AWS tools. Practice using AWS in real-world scenarios. Next, take practice exams. Familiarize yourself with the exam format. Then, focus on core concepts. Pay attention to key topics like security and costs. Lastly, AWS forums. Get tips from the community. With these tips, you'll be ready to pass the exam and boost your career.
So what exactly is cloud storage? Now, first and foremost, let me tell you what prompted me to actually go ahead and take this session. Well, recently I had been interviewing and where I asked people what did they know about cloud computing, and they told me that cloud computing is a place, or it is a place online where you actually store data. I mean, to some extent, I agree. Yes, cloud computing helps you store data, but that is not the definition on the longer run. So that is why I thought that we should actually go ahead and have this session so that we can discuss some of the myths that surround cloud computing and cloud storage in particular. So guys, let's start with the basic definition first. Storage, well, it is something that is made available in the form of service, which is connected over a network. So guys, this is a very basic definition, and to throw some more light, I would like to actually go ahead and give in certain examples as well to specify what does this definition mean. But to some point, this definition is correct. It says that it is nothing but a storage which is available as a service which is connected over a network. Now again, you might wonder, as in, this is what people told me in the interview, right? I mean, it is a place where you store data. So yes, cloud storage to some extent, yes, this is what it is. But when you talk about cloud storage, it is a lot more than this basic definition. Let's try to understand what all does cloud storage exactly has to offer to you people. Well, first and foremost, as I've already mentioned, it is storage. It can let you store emails, media. Now when I say media, you can store in different kind of media, whether it's your images, whether it's your videos, or maybe other kind of files. It also lets you hold services as well. Yes, we are living in the world of internet right now, and there are various services, websites that are online, and this data can be stored by using cloud platform. And finally, I'm sorry guys, finally it is nothing but the backup. Now when I say backup, guys, we're talking about large enterprises that let you back up the data, and they're using cloud platform to do that. But again, it still holds the same point, right? I mean, when I say emails, media, services, backup for large organizations, I mean, it is still a simple storage. No. Now let me tell you what it does. When I say backup for large organizations, we are referring to a lot of pointers here. Data coming in from different sources, the way it is processed, the way it is integrated and stored into a particular storage, how it is handled, and what all can you do with it. Now when you talk about a cloud storage, it actually takes care of all these things. That means it's not a redundant or a dead storage where you just take your data and put in your data. You can think of it as smart data storage. So to understand that, let's talk about cloud computing a little. So what cloud computing does is it lets you have this data on their platform, and it is a platform where it has n number of services that lets you compute or process this data to suit your business needs. Now it can be using machine learning, big data, finding out certain patterns using Power BI tools, or not Power BI tools, BI tools, and also do a lot of other things like maybe use a cloud platform where the data can be used for marketing purposes, maybe building IoT bots and stuff like that. So this is what a cloud computing platform does. It basically lets you use different sources and use this particular data to do multiple or different kinds of things. So when I say a cloud storage, it basically ensures there is a mechanism that in first place it stores data and lets you perform some of the actions that you can actually perform on this data. So as we move further, I would be discussing quite a few pointers that support this claim or this definition of mine. So let's just move further and try to understand a little more pointers or some other pointers that talk about cloud storage. But to keep it simple, It is a storage that lets you do a lot of things with your data. Primary reason being storing the data, and the other reasons being processing it or managing it also. So let's move further and take a look at the next pointer. So what are the myths that surround a cloud storage? Well, when you talk about the myths, this is what some people had to say, that cloud computing is suitable only for large scale organizations. No, this is not true. Let me give you an example. Recently what happened was, one of my friends, he actually happened to format his mobile phone and he lost all the images and all the data that was there on that phone. So the problem was he never backed that data up on any drive, neither on Google Drive or anywhere. So he lost the data. So he came to us and he told us that this is what happened. So we told him that probably he should have backed it up maybe on Google Drive. So next time he did that. And again, he being used to losing his data, he lost his data again. So he again comes up and he's like, I've lost the data. So we reminded him that he had his data stored on the Google Drive. So when you talk about Google Drive, it is nothing but an online storage where you actually make a copy of your data. So he made a copy of his data and he could actually get that data back. So when I say cloud storage, it gives you a simple application or a simple service where you can actually go ahead and just put in your data, just like Google Drive, where you can put in your data as well. So it is not limited to large scale organizations only. If even you are a single individual where you just need to store your data, you can use cloud storage. Now there are various cloud service providers that actually meet or cater different cloud computing needs. So based on that, the cloud storages might get complicated and might give you more functionality. But even if your need is as basic as storing data, don't worry, cloud computing or cloud storage is for you as well. Now, if you talk about small scale businesses, yes, these days the amount of data that is generated is huge. And that is why what happens is, even for small scale organizations, you need a place where you can store your data and somebody can manage that data for you so you can focus on your business goals. So this is where cloud storage comes into picture for even small scale businesses as well. So if you ask me, yes, large scale organizations are suitable for cloud computing, or only large scale organizations are suitable for cloud storage. This is a myth. Complexity with cloud, guys. Now, what does this term symbolize? People normally assume that having their private infrastructures makes it easier for them to actually go ahead and put in your data. That is not true. The fact that people are used to certain methods or methodologies, they feel comfortable with it. Whether cloud is complex or not, I would say it is not. Why? Because if you get used to certain services, you would realize that storing or moving your data to cloud is actually a lot more easier than your normal infrastructures or your previous or traditional infrastructures is what I would say. So whether cloud is complex, I would say no. As we move into the demo part, probably we would be talking about this pointer, or once I give the demo, probably you would have a clearer picture how easy it is to actually move your data to cloud. Not eco-friendly. Now, this might sound out of the blue. I mean, you might wonder, this is not a sociology session, so where did this point come in from? I mean, not eco-friendly. Yes, what people assume is the fact that the large amount of data is being stored on these platforms. So we have huge amounts or huge numbers of data centers which are big in size and they consume a lot of electricity. So there is power wastage, electricity wastage. Well, that is a myth again. First and foremost, the fact that we are getting a centralized storage somewhere, that means most of the data would be stored there. So yes, you're automatically saving out on your power consumption when you talk about it from a global or an eco perspective. The other thing is, I would not want to point out a particular cloud service provider, but when you talk about GCP, that is Google Cloud Platform, they normally provide their cloud services at a very affordable price. Now, why is that? The reason for that is they've actually put in a lot of effort into the research part, where they've researched a lot on how they can actually minimize the cost. And how did they do it? They basically ensured that the amount of power that is consumed by their resources, they've tried and optimized that amount to a minimum amount so that they are charged less, and in a way you are charged less. So if they're optimizing that particular process, obviously you're consuming less amount of electricity. So whether it's eco-friendly, definitely it is eco-friendly. Zero downtime. Again, there's no such thing as zero downtime. Now, the fact that I'm talking about cloud storage does not mean that I tell you that it has zero downtime and you're completely secure. No, there is a possibility that there might be a downtime. The fact that cloud ensures that this downtime is very less, now that is a plus point. What cloud also does is it ensures that there is disaster recovery, and there is always a backup of your data or your resources. So even if something goes down for a very little time, I mean normally it happens for a very less time if it does happen, and it happens very rarely, but even if it happens, care is taken that nothing harms your resources or your data. So zero downtime, no, that is not true, but definitely downtime is taken care of when you talk about cloud storages. There is no need of cloud storage. Okay, this is one of the biggest myths. Whether people agree or not, if you go back like 10 years from now, probably people did not know a lot about cloud computing, but with time, people are actually moving to cloud. And if you take a look at recent statistics, they would agree as well. I mean, people would be wanting to switch to cloud in near future. And the reason for that is there are quite a few services, quite a few facilities that cloud gives you. And that is why people are moving to cloud. And if you do move to cloud, you'll be using cloud storage inevitably. So yes, that is going to happen. And if you think that there is no need for cloud storage, definitely in near future, I would assure you that even you would be moving to cloud. So guys, these are some of the major myths. There are some other myths as well. As we move further, don't worry, we would be discussing that as well in some other pointers. So let's just go ahead and talk about some of the benefits of using a cloud storage for data storage, or basically using cloud for data storage. So what are the benefits of this thing? Now, I've purposely kept this pointer for the later half, and I first discussed the myth because these pointers would definitely help you understand some of those myths better. Now, your cloud platform is customer friendly. What do I mean by this? Well, first and foremost, when you talk about cloud storage, what you're able to do is you're able to scale up your storage, scale down your storage, keep it secure, monitor it, and you can ensure that there is constant backup taken of your data. So when you talk about it from a security perspective, it is secure as well. Plus, what cloud service providers do is they've had so many services that are there in the market. You talk about any popular cloud service provider, they have a lot of services that are made available. What do these services do is they ensure that your functioning on cloud platform is very smooth. And same is for cloud storage as well. You can utilize various services which ensure that your functioning or your working on cloud becomes easy. Again, which I've been reiterating for a while now that I would be talking about these in future slides. Don't worry, as we get into the demo part, you would understand how user friendly these cloud platforms are. Security. Now, again, this is an important point. When you talk about cloud platforms, cloud storages, are they secure or not? Definitely, they are very secure. And there was a time when people believed that these platforms were not secure to a greater extent. And that doubt was understandable. I mean, if there is something that is new in the market, you tend to doubt that. But if you talk about cloud platforms, these platforms are actually more secure than your on-premise or your traditional architectures which people are used to using. The reason for this is if you talk about cloud service providers, let's talk about AWS, that is Amazon Web Services in this case. What it does is it gives you a shared security model. Now, what do I mean by this? You have service level agreements where you and your customer, or maybe the customer and the AWS providers, they basically come to a term where they decide as in what kind of security or what kind of principles are to be implemented on the architecture. And you can take control as in you can decide what accesses do you want to give to the vendor and what are the accesses you want to keep to yourself. So when you do combine this approach, it ensures that security is at the optimum and you get to take control of your security as well. So yes, if you talk about cloud storage being secure or not, yes, it is very secure. To name some, we have S3 in AWS. It is highly durable and it is highly reliable. So when you talk about disaster recovery and durability, it is almost up to there. And as I've already mentioned, not everything is 100% when I talked about the downtime the downtime part. So yes, not everything is 100%, but when you talk about security and durability, when you talk about S3 in particular, it is 99.6 or 7 times 9, that is 99.9999999 times durable. So that does make your system very secure. Another benefit, guys, it is pocket friendly. Now, if you talk about cloud service providers, whether it's storage, whether it's compute service, database services, all these services, you can actually go ahead and use these services for rental basis. It's just like paying for your electricity. I mean, if you're using a particular service, you'd be paying for that service for the duration you use that service, and you'd be paying only for the resources that you've used. So it is pay as you go kind of a model where you pay only for the resources you use and only for the time duration you use. So whether it's pocket friendly or not, yes, it is pocket friendly. And as you move further, I mean, if you're using more storage, the cost again, it cuts down to a greater extent. So it is already cheaper, and if you decide to scale up, it would be more cheaper, or it would be cheaper is what I should say. So yeah, these are some of the benefits. Now, if you talk about cloud computing and storage, again, there are other benefits like, as I've already mentioned, durability, scalability, and various other benefits, but these are some core ones. I would not want to get into the details because I wish to keep everyone on the same page for people who have been attending this session for the first time, and for people who probably know a bit about cloud computing. Again, guys, if some of the terms that I'm talking about in this session, you feel that these terms are fairly new for you and I'm probably going at a faster pace, I would suggest that you actually do go ahead and check into the other sessions that we have on our YouTube channel, because we've talked about a lot of stuff there. I mean, other cloud services, what cloud computing is, what cloud service providers are, what are different service models, and quite a few other videos and sessions, to be honest. So I would suggest that you go through those sessions as well. And I'm sure that by now, many of you might have been wondering as in whether this session would be recorded and a copy of it would be available to you people or not. Not worry. Most of our sessions, they go on YouTube. So probably a copy of it would be there on YouTube. And if not, you can actually share your email IDs as well. If it does not go on YouTube, somebody would share a copy of the session with you people. So guys, if I'm happening to go a little faster than what you're expecting, do not worry, you'd be having a copy of this as well. But for now, just try to keep up with the pace that I am going with, and I'm sure that by the end of this session, we all would be good. So guys, what are some of the cloud storage practices that you should take care of? Now, these are the practices that should concern somebody who is planning to move to cloud. Again, if you are a newbie and you're just here to practice, we are not talking about you in particular. But these pointers are important for you as an individual as well. But I'm talking about it from more business perspective or more industrial perspective. So if your organization is planning to move to cloud, definitely these are some of the practices or pointers that you should take care of. So first and foremost, scrutinize SLA. So as I've already mentioned, you have SLAs where your service providers or your vendors basically come to a term where you actually go ahead and decide on particular rules, as in, okay, these are the terms and these are the services as a vendor I would be providing you people, and you as a customer, you agree to certain terms, as in, okay, this is what you would be giving us and this is what we would be paying you. So there are certain pointers that you should consider while you're actually signing your SLAs. One thing that you need to understand is, when they say that you would be, this is the base charge, try to understand how the charges would be when you decide to scale up and stuff like that. Other thing that you need to consider is, I've talked about downtime, right? So normally you have SLAs where people talk about the stuff that there won't be an outage which is more than 10 minutes. So yes, I mean, this sounds fairly good, right? So in an hour's time, this is a hypothetical example. Do not consider that there would be a downtime of 10 minutes. This is for your understanding. Let's assume that there's a downtime of maybe 10 minutes in an hour's time, which is too high for now, but let's assume that. So what a service provider would claim is, if there is a downtime once, probably this is what the charge would be. But if it goes down after that, probably you get some more concession discount and those kind of things. So if there is an SLA where you say that it is 10 minutes, and what if there were two downtimes of 99 minutes in an hour? And that is fairly close, right? So you've been robbed of your right. So that is what I'm trying to say. I mean, if you do actually go ahead and have particular SLAs, make sure that you consider in right points that suit in your business as well. Follow your business needs. again guys, storage, as we move further, we would be discussing what are the different kinds of storages. So when you talk about cloud service providers, they provide you n number of storages, or n types of storages is what I should say. So depending upon the business you're dealing with, the kind of data that is generated, you should be able to choose a proper storage for your requirements. I mean, whether you're dealing with the real-time data, whether it's stationary data, archival data, based on that, you should be able to actually go ahead and set up your cloud storage. Also, you need to understand, as in, okay, this is the data I would be putting in, and these are the integrations I would be needing because I'm using these kind of tools. So are those compatible with my cloud platform? So probably you need to consider these pointers as well. And if you follow these rules, probably your business would end up saving a lot of money. Now, there have been use cases where businesses have actually gone ahead and saved lakhs of dollars, thousands of dollars. So yes, considering these pointers, understanding your business also becomes important. You need to ensure that the security which you are actually managing or monitoring is defined properly. I've already mentioned that if you talk about cloud service providers, they let you have an SLA where you both come to a similar agreement. So understand the security, what are the accesses that you have, what are the accesses you want to give, what kind of data are you dealing with, and based on that, probably you can come to terms when you're actually moving to cloud. Plan your storage future. What we are trying to say here is plan the future of your storage. Again, do you need to scale up in near future? What are the peak times that you can expect, and stuff like that. So when you initially actually set your storage up, probably you would be in a much better position to scale up. I'm not refraining from the fact that cloud providers are already scalable, but just to be secure, you can do that. When you talk about cloud providers, mostly they give you an option of scaling right away or instantly, but still having an understanding of how much storage you need, where you're gonna move in like 2 years, 3 years time, probably having an understanding of all those things would definitely hold you in a much better position. Be aware of hidden costs. Again guys, I've talked about the first SLA, right? So it is similar to that. Understand what you're paying for, how much are you paying for. It is a pay-as-you-go model, but having an understanding of which services would cost you how much would help you in forming proper SLAs or having proper policies for your storage. So these are some of the do's and don'ts of cloud storage, guys. Again, if you need more insights on different services as well, we have a video or a session on YouTube which is called as AWS Best Practices. You can take a look at that as well, where we talk about different services and how can you actually perform certain tasks which would ensure that you are in the best possible position. So guys, we've talked about quite a few things. We've understood what cloud storage is. We've understood what are the benefits, what are some of the myths, and what are some of the practices that you should take care of. Now let's take a look at some of the different cloud service providers that provide you with these services. And once we are done with it, then probably we would move into the demo part. So guys, there are quite a few cloud service providers which also provide you with storage services. We have Google Cloud Platform, which is one of the leading ones. DigitalOcean, probably it's everywhere, whether you search for internet, ads, companies, it's there. Terramark, again, this is a popular cloud service provider. IBM is there in storage or in cloud for a very long time, guys. Now, if you go way back, I happened to attend a session where I believe it was AWS and some reInvent session where I did not remember the name of the speaker, but that person made a very valid point. He said that in 1980s he remembered, or he happened to visit a facility. I believe it was IBM's. I'm not sure whose. I think it was IBM's. So he said that they had this huge machine which was for storage. I mean, it looked very cool in 1980s, a huge machine, and it was very costly. It was like somewhere around thousands of dollars, and the storage space was 4 MB. Yes, for 4 MB, the cost was thousands of dollars. So you can understand how far storage has come, how far cloud has come. And yes, IBM, it has been there. I mean, it has been there since then. So if you talk about IBM, if you talk about Google Cloud Platform, these are principal cloud service providers. Then you have Microsoft Azure. Now, if you talk about current market, I mean, if you go by the stats alone, Microsoft Azure and AWS. These are the leading cloud service providers. AWS is way ahead of all the other cloud service providers. I'm so sorry. But if you talk about Microsoft Azure, it is actually catching up with Amazon Web Services, and recent stats show that Microsoft Azure is doing fairly well. So yes, these are some of the popular cloud service providers, and more or less all of them have good storage services as well. But as I've already mentioned, Amazon Web Services is one of the best in the market. And in today's session, we would be understanding some of the popular cloud services that Amazon Web Services has to offer to you. And when I say popular services, I would be focusing on storage services specifically. So guys, let me switch into the console and we can discuss some of these services there and directly move into the demo part. So yes guys, I hope this screen is visible to you people. This is how the AWS management console looks like. So again, for people who are completely new to cloud platform, let me tell you that what Amazon Web Services or most of the other cloud service providers do is they give you a free tier account. What they're trying to say here is you use our services for free for a short duration of period, and if you like, then go ahead and buy our services. So these services are actually made available to you for free for one complete year. Yes, there are certain limits or bounds on these services. So if you exceed those limits, you would be charged. But if you stay in the bounds or limits, you won't be charged. And if you talk about exploring these services, these limits or free tier services are more than enough. So again, guys, if you are completely new, you should come here. That is Amazon Web Services Management Console. Create a free tier account. It is a very simple process. Put in certain details, where you work, why do you want to use these services, your basic details, and then probably you would have to enter your debit card or credit card details. Don't worry, they won't charge you, but this is for the verification purpose. And again, if you're worried about whether you would be charged or an amount would be minus from your credit amount or your credit card, that does not happen, guys. AWS gives you notifications saying that okay, you've been using these services and probably you might be overusing some of your services. Also, you can set in alarms where if you reach a particular limit, after that you can actually go ahead and ensure that there is an alarm so that you do not exceed the free tier limit. So yes, once you do have an account, you can avail all these services that are here, guys. So let's just go ahead and take a look at the console a little and just jump into the storage services right away. So when you click on this icon here, storage, guys, or services rather, you get access to all these services. As I've already mentioned, AWS provides you quite a few services. There's somewhere around 100 services, guys, and they cover different domains. You can see the domain names at the top: compute, robotics, analytics, business applications, storage. You have management and governance, security, identity management, and all those services, guys. So there are n number of services, whether it's migration, whether it's media services. You have services for almost everything. So guys, we would be focusing on the storage services. Before we go there, this is one thing. Probably you can select a region where you want to operate from. That is, you want to create your resources in this particular region. You can always have this option of using it. So what is a region, guys? Your data is based in a data center, right? I mean, your data is copied somewhere. So if you are using those resources, probably your data would be fetched from that particular location. So you can choose a region probably which is close to you if you like, or if your business is located somewhere else, probably you can choose that region as well. So you need to go through the list of regions that are available and accordingly make a decision. Now, this being a simple demo, guys, I would be sticking to Ohio basically. So let's just go ahead and jump into the cloud services part, and let's talk about storage in particular. So guys, if you take a look at the storage services that are here, you can see that these are the storage services that AWS has to offer to you. We have S3, we have EFS, you have FSX, you have S3 Glacier, Storage Gateway, and AWS Backup. Let me just try and throw some light on some of these services, and probably we would just go ahead and get into the demo of one or two of these services at least. So guys, when you talk about S3, it is simple storage service. So that is SSS. Now this storage is basically object bucket kind of a storage. I mean, your container where you put in your data, where you store your data, is called as bucket, and your data or your files are basically stored in the form of objects. Let's just go ahead and quickly create a small bucket. This would be a very small introduction to this service. Let's just go ahead and do that. So when you click on this icon, guys, that is S3, it redirects you to the S3 console, guys, where you can actually go ahead and create a bucket. I've mentioned the pointer that there are certain services that make your job very easy with cloud service providers. And when you talk about storage services, it is no different. I mean, there are services which ensure that your job is fairly easy. So let's just go ahead and see how easy it is to work with S3. If you wish to create a bucket, guys, if you wish to create a container, it is very easy. Just go ahead and click on create bucket and give it some name. Say sample for today, maybe. Guys, I'm very bad at naming conventions, but please forgive me for that. Again, the names here should be unique. I mean, if the name is taken somewhere else, probably you cannot rename. I mean, you cannot use that name again. So yes, ensure that your name is unique, and probably, guys, you should try and name your buckets in such a way that those are more relatable. Say, for example, if you have a bucket for maybe creating a particular application, so maybe bucket for that application or something like that, so that you have a hierarchy, and in that way you can assign IAM users or access to those buckets in a particular order, because you would not want all your users to have access to that bucket, right? So naming convention becomes very important. So just go ahead and say next. Keep all the versions, guys. Versioning becomes very important. Again, let's not get into the details, but let me give you a small idea what happens here. Versions, that means each time my buckets get updated, probably I would want a version or a copy of it, and I would want the latest one. So when I version it, it maintains those copies, and if I need to go back, I can actually go back to a particular level or a benchmark which I set the previous time. In this case, let's stick to basic one, and I do not want any logging details either, so just next. Again, guys, there are certain public accesses which have been given, so permissions and access, we would talk about that, do not worry. For now, just say next, and I would say create a bucket. And guys, the bucket is already ready. I mean, my container is already ready, so I can just go ahead and probably open this bucket and put in a file if I want, and that too is very easy, guys. I say upload, and if I'm connected to my local system, I just say add files. Let's pick this random file which uses this name, and I say upload. And there you go, guys, the file is already there. I mean, we've created a bucket, a container, we've put in our files. It's as simple as that. Permissions, as I've already mentioned. Now let me talk about this point. I skipped this point, right? So let's discuss this a little. So guys, security is something that you can handle. So you would decide, or you need to decide, what are the users that need to access a particular bucket. Suppose your organization has different people working on different teams. I mean, you have somebody who is a developer, there's somebody who's working on maybe the administrative part, or maybe on the designing part. So for particular bucket, you have particular data, so you can decide who gets to access what. So setting in policies becomes important. You can create your own policies as well. Initially we saw that certain public accesses were restricted to this bucket. I said let's skip that for now. So when I say that public access is restricted, that means not any public policy can come in and dictate terms here saying that use this policy. Why? Because there is a restriction. This is a private bucket and not anyone can use it. So guys, when you talk about S3 in particular, you can create buckets, you can have backups, you can have your EBS backups also moved here. You can move your data from here to Glacier. We would be talking about Glacier, do not worry. You can have your Elastic Beanstalk applications, your PaaS applications, and the data can be stored in your S3 buckets. You can have your CI/CD pipelines, and the data can be moved again to the S3 bucket. Now this is highly durable and highly reliable source of storing data, and it gives you fast retrieval of data as well. Let's go ahead and try to understand some other services as well, guys. So when I come back here and I see EFS, Elastic File Storage or System rather. So here basically in this storage, you can store files. Yes, we are talking about data that is in the form of files. And if you wish to connect it better with the network, you can go for EFS as well. Guys, then you have something called as S3 Glacier. Yes, we talked about S3, right, where data is durable and it can be accessed very quickly. S3 on the other hand lets you store archival data. Let me tell you what archival data is first. So guys, when you talk about archival data, basically what happens with archival data is you're dealing with a data that you do not need to use every day. Let me give you an analogy. I'm not sure whether you would be able to relate to that. So guys, your birth certificate. Now I belong to India, and we've been taking up a lot, but we still have a lot of data that is in the form of papers. Even if you go to hospitals, at times you request for a birth certificate, it might take days for you to get that birth certificate. Why? Because there is some person who will be going through all those documents and giving you that document. This is just an example, do not relate it like very seriously, but yeah, so it might take a couple of days, right? So, and the birth certificate thing, I mean, I might not need birth certificate every day. It might be once in a decade that I might go to a hospital and probably request that particular birth certificate, right? So this is a kind of data probably which I do not need regularly or in real time. So I can compromise a little on the fact that if the person is giving me that data in 2 days time, it's okay, because that does not cost me anything. I can wait for 2 days maybe, but that's not the case. At times you need the data to be retrieved very quickly. So if that is the case, you should store it where? In S3. But if you're fine with this delay, probably you would want to store it in Glacier. Why? Glacier normally takes a longer while to retrieve your data. But the advantage of Glacier is it is profitable because it is very affordable compared to S3. S3 is already affordable. You can check in for the prices, but if you have archival data which you won't be using every day, you can store it here. And the fact that it takes a longer while, it won't cost you. It won't cost you in that perspective of accessing your data in real time, right? So if the data is something that is not needed regularly, you can move to S3 Glacier, right? So what happens is S3, you can actually move in all your data, and then if you realize that there is certain data which you do not need every day, just move it from S3 to S3 Glacier, where the data is stored in archival form, and it does not cost you a lot. So again guys, I won't be getting into the demo of S3 Glacier. We have a session on S3 Glacier, or Amazon Web Services Glacier rather, and to do that what you need is you need probably a third-party tool which makes it easier for you to retrieve the data. So I won't be getting into the stuff where I download that tool and show you how it works. It's very simple. Just like we created buckets here, you create vaults there, and you probably move in your data and you can retrieve that data. But again, it takes a longer while to retrieve that data. So it is similar to S3, but little different. So yeah, that is S3 Glacier. We've understood what EFS is and what S3 is. Then again guys, you have some other services as well here. If I scroll down, you have your storage gateway, you have your AWS backup as well. So what are these things and what do these things do? Well, storage gateway and AWS backup, basically backup, as it says, you can have backup of your data and you can like save it from going down and stuff like that. When you talk about storage gateway, these are services that let you move your data from on-premise atmosphere or your infrastructure rather to cloud. So if you already have data that is on your existing on-premise or infrastructure rather, you can actually move that data to cloud as well. So there are services to help you do that, and those services are your storage gateway services. So guys, we've discussed some of these services. There is something else which is called as Elastic Block Storage. Now Elastic Block Storage, what it does is it lets you create volumes, snapshots and copies of the volume that is attached to your instances. Let's go ahead and take a look at how this works. I mean, there are a lot of pointers to talk about it. So as I move further, I would be discussing those pointers while I also show you how to do it. So guys, when I say EBS or Elastic Block Storage, what it does is it lets me attach some kind of volume to my instance. Now instances, let me tell you what instances are first. Now when you talk about cloud services, they give you compute services where you can spawn instances or spawn temporary servers or servers where you want to host your data. Now each time I won't be going ahead and buying a new machine, right? Instead, what cloud does is it, and what happens? Yes guys, okay guys, I'm not sure whether there was a lag while you were going through this session. What happened is, let me tell you what happened. My connection, the streaming connection to my software which I'm using to stream this session did go down a minute back, and it shows now that it is connected. So I would like to know whether I'm audible to you people or not. If yes, then we can continue with this session, guys. Okay, I'm guessing we are fine. So I'm just gonna go ahead and continue with the session. I was talking about instances. Let me talk a little more about it. So when I talk about these servers that are ready to use, basically these servers are something that you can use and you can have some memory attached to it. So what we're gonna do is we're gonna go ahead and launch one instance and understand how memory or how storage works with it. So to do that, we're gonna go ahead and just launch that particular service. It is called as EC2, which is a compute service, guys. So here I can actually go ahead and create servers or launch instances in simple words. So let's just go ahead and launch a particular instance. Now I have the freedom of launching both Linux based, Windows based, Ubuntu based kind of instances. So you have the freedom of choosing what kind of instance do you want. This being a simple demo, guys, I'm gonna stick with the Windows instance. I'm not gonna show you how to deal with that instance because I've done that in previous sessions. You can take a look at some of those sessions as well, guys. Let's just go ahead and launch this particular session or this particular instance rather. Now guys, this is a Windows instance, and okay, not this. Let me launch some basic one. This is also free tier, guys, but yeah, I would want this. Make sure that your instance is EBS backed. So guys, your backing up works in two ways. You can back it up on S3, you can back it up on EBS, that is Elastic Block Storage. Now, Elastic Block Storage is important. Why? It lets you create images and volumes. What are those? We'll talk about that once we create this instance. So ensure that for now it is EBS. So if I click on, okay, this is the thing. If I click on this icon, it would give me details what kind of instance I'm launching. When I say T2 micro, it is a small instance which has one CPU and 1 GB of memory for now. And I can just go ahead and say next. Okay. Some of the other details, whether you want a VPC or not, let's not discuss that. And then you get into the storage part, guys. This is the device to which I'm attaching my root volume. So this is the path rather. So I need to focus on this. It is SDA1, guys. That is /dev/SDA1. You need to remember this when you create new volumes. And the types of volumes that you can attach to your instance are these. You have general purpose SSD, provisioned IOPS, and magnetic. Magnetic is something that is getting outdated, probably might be replaced. So these are the few ones. You also have some other kind of volumes that you can attach, but the point that you need to remember is when you talk about having a primary volume, in that case you have only these options because these are bootable, guys. So there are certain other volumes that you can attach. If I attach a secondary volume, you see the options are more. I have HSD for throughput optimization, and then I have cold HSD as well. But this is a basic thing. We're not gonna get into the details of that. We would skip that. So guys, all I'm trying to say is this is the device, this is the size, and probably this is the type of instance or volume, sorry, is that would be attached to my instance. So let's just go ahead and say next, add tags. For now, let's not add anything. And then let me say configure the settings. So guys, when I launch an instance, it says that security is not optimum, but it's okay. I mean, you can assign the ports you want to when you use it for a higher security purpose. And then this is important, guys. For your each instance, you need a key pair, which is a secret way of logging in, or a secure way of logging in, not secret, a secure way. So this is a second place authentication. Once you're logged into your account, you would be needing a key pair if you wish to use this instance. So make sure you create one and you store that one as well. If you have one which you can use, probably you can do that. Else you can just create one. Say new key. I say download. Guys, once you download it, keep it safe somewhere. It is stored in the form of .pem file. So do that. And then I say launch an instance. So guys, once this happens, if I just go back to the EC2 dashboard, probably I can see that there is an instance which is running. For now it is 0. Why? Because guys, my instance is still getting launched. It takes a couple of minutes or 1.5 or 1 minute probably to launch an instance. The reason for this is probably a lot of things happen in the ground. I mean, certain network is associated. If you talk about an instance, it needs to communicate with other instances, right? So in that case, probably you need to have a network that lets all these instances connect. So a network is set here basically, and probably all the storage volume is attached, and a lot of things happen. That is why there are certain status checks that your instance needs to go through, and hence it takes a minute or so to launch this instance. So if you take a look at this, the status checks, it says that it is initializing. So if you refresh it, probably it happens at times. So let's just try our luck, see whether it's, no, it's still initializing, but guys, we can see the volume that would be attached to it. So let me just come here and rather go here. If I click on volumes, guys, there is a volume that is attached to it. So there is a 30 GB volume. So there is a volume that probably has a size of 30 GB. So it is here already and it is in use. So it would be attached to my instance once it is up and running. So the point I'm trying to make here is what Elastic Block Storage does is it lets you manage all these things. Now there are two ways to manage these things. Either you create a copy of this volume, disable this volume, and then attach the next one, or probably you can directly scale your existing volume or make changes to it right away. So what Elastic Block Storage does is it lets you manage the storages. So again, let me tell you how it works. So when I create an instance, probably it is created in a particular region, right? So in that particular region, say for example, now I'm based in India, so I have a data center in Mumbai. So my instance would be created at that data center, and probably the storage for it would also be there. So there is no latency when I try to use that storage. So this is what EBS does. It lets you manage that particular storage. So how it works is I can create a copy of it. So what this copy does is it serves two purposes. So next time, if I wish to make changes to that storage, I can do that. If this particular storage or volume goes down, I have a backup copy. Again, I can create snapshots as well. Now what snapshots do is basically they let me replicate my instance and the volume that is attached with it. So instead of creating an instance again and again with, if I've defined certain properties for my instance, I do not have to worry about defining those properties again and again. I can just create a snapshot, or I can rather create an EMI out of it, which I can store and use it next time if I want to spawn a similar instance. So this is where EBS helps in. It lets you have backups of all these storages. It lets you create copies of it. So even if something goes down, you can work on the copy that you have. So guys, by now our instance would be created. Let's just go ahead and take a look at it. It says it is running, guys, and we've already taken a look at the volume. Let's just create a copy of this volume. To do that, I'm going to go to the actions. My instance is selected already. I can just go to modify and make changes to this volume right away, which is an easier way, but I'm going to show you how it can be done the other way as well, how it used to work previously. So I can just say that create a snapshot, details, sample, and I say create. So guys, a snapshot is created. If I come here, I can take a look at the snapshot. Again, it is pending. Might take half a minute for the snapshot to get created. So I can just come here and replace or refresh rather. These things at times take a little while. So guys, we would be creating a copy of it. Probably we would be detaching the volume that we've created and it is attached to our instance, and we would replace that with the copy that we are creating now. So once this thing is done and created, we can do that. For some reason, it's taking a longer while today. Let's hope that it gets done quicker. Okay, it's still processing. Let's bear with me, or just bear with me meanwhile this happens. Again guys, if I was too fast and if I missed out on certain things, I would like to tell you that you can go through our other sessions on YouTube and probably you'd be in a much better state to understand what has happened here. Again, there was an outage where, not outage, my software did not work properly, the streaming software, and probably there was a lag of a minute or two. So I'm hoping that you all did not miss out on anything that was happening. Meanwhile, just hope that this snapshot gets created quickly. It is still pending, and this is irritating at times when it takes a longer while. It's completed, guys. Our snapshot is ready. I can just go ahead and say create a volume out of it, which I wish to attach. So guys, there are certain details that we need to do. So for that, let's just go back first. Let's go back to the instance that we have, and let's see where the instance is created, guys. So as you can see, if you come here, it would give you the details of the place where the instance is created. So it is US East 2C. So when you create a volume, it is necessary that you create it in the same region, guys, because as I've already mentioned, the benefits of having it in same region is that you can attach it to your existing instance and it saves you from various latencies. So yep, let's go back to the snapshots part and say create a volume of it. I say create, and then I probably, let's say I want more storage, guys. Let's say 90. Okay, this is general purpose. It is two-way, so let's go to 2C. If I'm not wrong, it was 2C. Let's just go ahead and create it in 2C and say create a volume. Close. So guys, our instances or our volume is created successfully. Again, guys, now you can take a look at it from this perspective. I have my snapshot here, right? So this snapshot says 30 GB. That does not mean that the snapshot which I took, its size is 30 GB. It says that it was created from an instance whose size is 30 GB. So there's a difference between these two things, guys. Understand that as well. So I have a volume which is based in availability zone 2C. I have an instance which is here, and it again is an availability zone 2C. So we can attach to it. Let's just again go back to the volumes part. So guys, I have two volumes. I created this one and this is attached to my instance. Let me just try and remove this first. Detach volume. Okay, it's giving me an error. Try to understand why this error is there. Guys, my instance is already running, so I cannot directly remove this volume from here. For that, I would have to select this instance, go to instance state and say stop. So it stops working for now. And once it does, I can attach the volume. So for now, what you can see is there are these volumes here. It is in use, right? So once the instance stops, it would be available and won't be in use. So I can replace it with this instance. So it is stopping. It hasn't stopped yet. So guys, do not worry. We would be done with the session very soon. And once we are done, probably you all would be free to leave. I believe that this session has taken longer than my normal sessions. But yeah, there was a lot of stuff to talk about. We talked about the complete storage services that AWS has to offer to you people. Hence, this session was so long. So let's just quickly go ahead and finish the stuff. Okay, it has stopped. So guys, I can now go ahead and remove the volume or detach this volume and go ahead and attach the other one. So if I say detach, it would detach. Yeah, see, both are available now. Let's try to attach this volume and say attach volume. Search. This is the instance, guys, which we've created, and you need to give in the device details, which was slash what were the details. Let's just go back and take a look at the details that we're supposed to enter in here. So guys, you need to give in the path that we talked about, which is the drive that we've discussed, right? So that is the path that you need to enter, and then you actually go ahead and say SDA1 / and probably you'd be more than good to go. So this is the other thing, I do not remember the other part. So you need to go ahead and put in these details here. If you put in these part details, guys, you can just go ahead and attach your volume right away, and this volume would get attached to your instance. So this is how it works, and you can actually go back and do other things as well. So if I just come here, I have this instance. So what you have to do is you have to actually go ahead and click on this thing. For now it's not working, but if you just come back here or to the volume part, so if you just go to the volumes part, which we were at in the previous slide, you can actually go ahead and attach the volumes. Now here you go. If I just go to instances, probably go back and I say EC2 again. Yeah, if I come back to volumes, guys, you can attach the volumes that are there, you can delete those, and you can do a number of changes that you wish to do. So just go ahead and attach these volumes, and you'd be more than good to actually go ahead and launch your instances or manage the storages that are there. Again, the only thing that I missed out on is the path. I told you to note the path, the device name, right? You just have to go ahead and enter in the device name here, and if you enter in the device name while creating your volume or attaching your volume, your instance would get attached to that, or your volume would get attached to that instance right away. So yes, guys, this pretty much sums up today's session. We've talked about quite a few things here, guys. We've talked about S3 services. We've talked about EBS in particular. We've understood like how to detach a volume, how to attach one. I just did not show you how to attach the volume, but you can do that. The reason I'm not showing you that is I probably lost out on the device name here, which normally comes in here. So before you deactivate your device, make sure that you have this name, and when you do launch or attach your volume to that particular thing, all you have to do is you just go to the volumes part, and probably when you say attach to a particular instance, put in that device name there, and your instance would be attached, or your volume would be attached to your instance, and you can just go ahead and say launch or just start this so-called instance again, and you'd be good to go, guys. So let us just try to understand what the storage exactly is. So guys, when you talk about S3, now it is a simple storage service which is simple or easier to use in real sense. It lets you store and retrieve data which can be in any amount, which can be of any type, and you can move it from anywhere using the web or internet. So it is called as storage service of the internet. What are the features of this particular service? It is highly durable, guys. Now, why do I call it durable? It provides you durability of 99.999999, some 11.9. Now, when you talk about that amount of durability, it is understandable how durable this service is. What makes it this durable? It uses a method of checksum where it constantly uses checksums to analyze whether your data was corrupted at a particular point. And if yes, that is rectified right away. And that is why this service is so durable. Then it is highly flexible as well. As I've already mentioned, S3 is a very simple service, and the fact that you can store any kind of data, you can store it in any region or any available region is what I would mean by the sentence. It makes it highly flexible to store the data in this particular service, and the fact that you can use so many APIs, you can kind of secure this data in so many ways, and it is so affordable. It meets different kinds of needs, thus making it so flexible. Available. Is it available? Yes, definitely it is very much available. As we move into the demo part, I would be showing you which regions basically let you create these kind of storages and how can you move and store data in different regions as well. So if you talk about availability, yes, it is available in different regions, and the fact that it is so affordable, making it available becomes all the more easy. Cost efficient, yes. Now to start with, we normally do not get anything for free in life, but if you talk about S3 storage, AWS has a free tier which lets you use AWS services for free for one complete year. But this happens in certain limits. Now, when you talk about S3, you can store 5 GB of data for free, at least to get started or get used to the service. I believe that is more than enough. And what it also does is it lets you have somewhere around 20,000 get requests and somewhere around 2,000 put requests as well. So these are something that let you store and retrieve data. Apart from that, you can move in 15 GB of data every month outside of your S3 service as well. So if you're getting this much for free, it is definitely very much affordable. Also, it charges you on pay-as-you-go model. Now, what do I mean by this? Well, when I say pay-as-you-go model, what we do here is we pay only for the time duration that we use this service for, and only for the capacity that we use this service for. So that is why as you move along, if you need more services, you would be charged more. If you do not need more amount of the service, you won't be charged to that greater extent. So is it cost efficient? Definitely it is. Scalable? Yes. That is the best thing about AWS services. Most of them are scalable. I mean, you can store huge amount of data, you can process huge amount of data, you can acquire huge amount of data. If it is scalability that is your concern, you do not have to worry about it here, because even this service readily scales to the increasing data that you need to store. And the fact that it is pay-as-you-go model, you do not have to worry about the cost factor as well. Is it secure? Definitely it is. Now you can encrypt your data. You have various bucket policies as well that let you decide who gets to access your data, who gets to write data, who gets to read data. And when I said you can encrypt your data, you can actually go ahead and encrypt your data both on client side and on your server side as well. So is it secure? I believe that answers the question on its own. So guys, these were some of the features of Amazon S3. So guys, now let us try to understand how does S3 storage actually work. Now it works with the concept of objects and buckets. Now bucket, you can think of it as a container, whereas an object is a file that you store in your container. These can be thought of as AWS S3 resources. Now when I say an object, basically object is your data file. I've already mentioned that you can store any kind of data, whether it's your image, whether it's your files, docs, whatever it is. These are nothing but your data. And this data comes with metadata. When I say an object, it is combination of your data plus some metadata or information about that data. What kind of information? Basically, you have the key, that is the name of the file that you use, and version ID is something that tells you which version are you using. As we discuss versioning, probably I would talk about version ID a little more. But meanwhile, I believe this is more than enough. Your objects are nothing but your files with the required metadata. And the buckets, as I've already mentioned, these are nothing but containers that hold your data. So how does it work, guys? Well, what happens is basically you go ahead and create buckets in regions and you store your data in those regions. How do you decide what buckets to use, what regions to use, where to create the bucket and all those things? Well, it depends on quite a few factors. When I say I have to create a bucket, I need to decide what region would be more accessible to my customers or to my users, and how much cost does that region charge me, because depending upon the region, your cost might vary. So that is one factor that you need to consider. And latency as well. I mean, if you put your data in an S3 bucket that is far away from you, fetching it might cause high amount of latency as well. So once you consider these factors, you can create a bucket and you just store your objects. When I said version ID, key, actually your system automatically generates these features for you. So for you, it is very simple. Create a bucket, pick up your object, put it in it, or just go ahead and retrieve the data from the bucket whenever you want to. So I believe this gives you some picture about what S3 is. Now, let me quickly switch into the demo part and let me give you a quick idea or quick demo as to how S3 works so that it is not too much theory for you people. So guys, what I've done is I've actually gone ahead and I've switched into my Amazon Management Console. Now, as I've already mentioned, AWS gives you a free tier for which you can use AWS services for free for 1 complete year. Mine is not a free tier account, but yeah, if you are a starter, you can create a fresh account. You just have to go ahead and give in certain details. All you do is you just go to your web browser, search for AWS free tier and sign in with the required details. They would ask you for your credit card or your debit card details. Enter any one of those for the verification purpose. And you can actually go ahead and set up alarms as well, which would tell you as in, okay, this is the limit to which you have used the services. And that way you won't be charged for access of data usage or service usage. Having said that, guys, this is about creating an account. I believe it is fairly simple. You can create an account. Once you create an account, guys, this is the console that would be available to you. What you have to do is you have to go ahead and search for Amazon S3. If you search S3 here, it would kind of redirect you to that service page. So guys, as you can see, this is the company's account probably. Somebody uses it in the company and they have their buckets that are already created. Let's not get there. Let us just go ahead and create our own bucket and just go ahead and put in some data into it. It is fairly simple, guys. I've already mentioned it is very simple to use kind of service. All I have to do is click on create bucket and enter in name for some bucket. Guys, now this name is unique. It is globally unique. Once you enter a name for the bucket, you cannot use the same name for some other bucket. So make sure you put in valid name. And the fact that I use the term global, something reminded me to be explained of. So guys, as you can see, if I go back here, I want you to notice this part. So guys, when you are into the management console or you open any service, by default, the region is North Virginia. Okay, so if I create a resource, it would go to this region. But when I select the service that is S3, you can see that this region automatically goes to global. That means it is a global service. It does not mean that you cannot create bucket instances global is what they're trying to say. So let us just go ahead and create the bucket. Let us call it today's demo. You cannot use caps, guys. You cannot use some symbols. So you have to follow the naming convention as well. Today's demo. Sorry, I'm very bad at naming conventions, guys. I hope it is okay. Let it be in US East. You can choose other regions as well, guys, but for now, let it be whatever it is. So I'm gonna stick to North Virginia. There are 76 buckets that are being used. Let us just say next. Bucket name already exists. So this was already taken, guys. See, so you cannot use it. Let's call it, say, Ramos bucket 13113. Okay, do you want to keep all the versions of the object? We will talk about what versions are. Okay, guys. Meanwhile, you just bear with me. I'm just going to go ahead and create a bucket. Create a bucket. And there you go, guys. I'm sure Ramos bucket should be here somewhere. Here it is. If I open it, I can just go ahead and create folders inside it, or I can directly upload data. So I say upload, select a file. Let's just randomly select this file. It is Van Rossum, founder of Python, basically. Let's just say next, next, next. And the data is uploaded, guys. You can see the data being uploaded and my file is here for usage. So guys, this is how object and bucket kind of stuff works. You can see that this is the data that I have. If I click on it, I would get all the information. What is the key? What is the version value? For now, let's not discuss version, but this is the key or the name of the file that I've uploaded. So it is fairly clear, right, guys? So let us just quickly switch back to the presentation and discuss some other stuff as well. Now guys, another important topic that is to be discussed here is S3 storage classes. Now we've discussed how the data is stored or how buckets and objects work. But apart from that, we need to discuss some other pointers as well. As in, how does AWS charge me, or what kind of options do I have when it comes to storing this data? So it provides you with three options, guys: standard, infrequent, and glacier. Let me quickly give you an explanation to what do these storage classes mean and what all they offer to us. When I say standard, it is the standard storage which gives you low latency. So in case if there is some data that needs to be fetched right away, you can actually go ahead and use standard storage. Say for example, I wish to go to a hospital for certain kind of checkup. So in that case, my details would be entered in. And the fact that I'm getting myself checked in a hospital or diagnosed in the hospital, what happens is this data is important, and if it is needed right away, it should be available. So this kind of data can be stored in your standard storage where the latency is very less. The next we have infrequent access. Now what do I mean by that? Now in this case, my latency period has to be low because I'm talking about data that I would actually need anytime if I want to. But when I store this data for a little longer duration, all I want is this data to be retrieved quickly. Say for example, I get a particular report or a particular test done. So in that case, I would actually go ahead and submit my details, or say for example, my blood samples, but I need this information maybe after 3 days. So what happens is, in this scenario, I would want to store this data for a longer term, but the retrieval should be faster here. In the first case, that was not the case. If I needed that data right away, and if I wanted it to be stored for a very short duration, I would use standard. But if I want to store it for a longer duration and I want a quick retrieval, In that case, I would be using infrequent access. And finally, I have Glacier. We have already discussed this. Here, your retrieval speed is low and the data needs to be put in for a longer duration. And that is why it is more affordable. If you take a look at the stats that are there in the image above, you can see that minimum storage duration is nothing for standard. For infrequent, it is 30 days, and for Glacier, it is 90 days. If you take a look at latency, it is milliseconds, and 4 hours. So that itself explains a lot of stuff here. So what are storage classes and what do they do? I believe some idea is clear to you people. Again, as we move into the demo part, we would be discussing this part as well. And we would also discuss expiration and transition that supports these terms. But let us move further and try to understand something else first. Versioning and cross-region replication. Now guys, when I say versioning, I'm actually talking about keeping multiple copies of my data. Now, why do I need versioning and why do I need multiple copies of my data? I've already mentioned that AWS S3 is highly durable and secure. How is that? Because you can fix the errors that are there, and you can also have multiple copies of your data. You can replicate your data. So in case if your data center goes down, a copy of it is mentioned or maintained somewhere else as well. How is this done? By creating multiple versions of your data. Say for example, an image, I store it in my S3 bucket. What happens here is there is key, the name is same, image, and version is some 33333, right? Now take a look at the other image. If I actually go ahead and create a copy of the first image, its name would remain same, but its version would be different. So suppose both of these images, they reside in one bucket. What these images are doing is they are having multiple copies or giving me multiple copies. Now in case of image, not a lot would change, but if I have doc files or data files, in that case, versioning becomes very important because if I make changes to particular data, if I delete a particular file, a backup should always be there with me. And this is where versioning becomes very, very important. What are the features of versioning? By default, versioning is disabled when you say or when you talk about S3. You have to go ahead and enable this versioning. It prevents overwriting or accidental deletion. We've already discussed that. You get non-concurrent version by specifying version ID as well. What do I mean by this? That means if I actually go ahead and create one more copy of the data and store it, so the latest copy would be available on top. But I can go to the versions option, put in the ID that belong to the previous version, and I can fetch that version as well. So what is cross-region replication? Now guys, we've discussed versioning. Let us talk about another important topic, that is cross-region replication. Now when you talk about S3, basically what happens is you create a bucket in a region and you store data in that region. But what if I want to move my data from one region or from one bucket in one region to other bucket in other region? Can we do that? Yes, cross-region replications let you do that. So what you do is you basically go ahead and create a bucket in one region, you create another bucket in another region, and probably you give access to the first bucket to move data from itself to the other bucket. So this was about versioning, this was about cross-region replication. And I believe we've also talked about storage classes. Let me quickly switch into the demo part and discuss these topics to little more detail. So guys, moving back, what we have done is we've actually gone ahead and created a bucket already, right? When you talk about what was the name of the bucket, it was Remos, if I'm not wrong. Yep. So if you click on the bucket name, Remos, what it does is it basically shows you these details, guys. Now you can see that your versioning is disabled, right? So if I click on it, I can actually come to this page and I can say enable versioning. That means a copy of the data that I create is always maintained. So if I go to Remos bucket or I just move back, okay, this interface can be a little irritating at times. You have to move back and forth every now and then. So guys, there is a file which we have stored. You can just take a look at this date first. It says that it is 2:35. That was the time when the object was moved. Let me just say that upload the same file. This was the file we uploaded. I say next, 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 upload. So guys, this file is getting uploaded. You can see the name of the file is still same. We have only one file here. Why? Because it was recently modified at 245. From 225 to 235, it got changed to 245. So it is fairly clear, guys, what is happening here. Your data is getting modified. And if you wonder as in what happened to the previous version, don't worry. If you click on this show option, you can see that both of your versions are still here, guys. This was created at 235 and at 245. So this way, data replication and data security works much better. So you can secure your data, you can replicate your data. So in case if you lose your data, you always have the previous versions to deal with. How does the previous version thing works? So guys, what happens is if I delete this file, what Amazon S3 would do is it would set a marker on top of this file. And once I delete it, if I search for that ID won't be available. Why? Because the marker has switched to the next ID now. So whatever I want to do, I can do with the next ID as well. So guys, one more thing that you also need to understand here is what happens to the file. I mean, I've actually deleted a file, but a version is there with me. Can I delete all the versions? Yes, you can specify the ID and you can delete all the versions that you want. You can also do one thing, that is you can set a particular life cycle for your files. When I say life cycle, you can decide as in, okay, now I have a file in standard storage. We've discussed these storages, right? Standard storage, infrequent and glacier. What you can do with your lifecycle management is you can decide as in, okay, for a particular time duration, I want this file to stay in standard. Maybe after a while, I want to move it to infrequent, and after a while, I want to move it to glacier. Say, for example, there is certain data which was very important for me, but having used that data, I don't want to use it for next few months. So in that case, I can move to the substitutes or to the other storage classes where probably I won't be needing to use that data for a longer while. And doing that, I won't be paying for this data as I used to pay for the standard, because standard is the costliest of the three. So let us quickly see, can we do that, or how does it work at least? If I just go back, this is my file. I can actually just go ahead and switch to management. In that, I have the option of life cycle. If I click here, there is no life cycle. Add a life cycle. You can add a life cycle rule as well, guys. New, let me call it new, and let me say next. It asks me what do I want to do. You can add rules in lifecycle configuration to tell Amazon S3 to transition objects to another storage class. There are pre-request fees when using lifecycle to transition data to any other S3 or S3 Glacier storage. So which version do I wish to use? Current, I can say yes. Add transition, and I can select transition to this tier when after 30 days. And if I say next, it would agree. Expiration, you can select other policies as well. So guys, when I say transition, first thing what it does is it tells me what time to transition to which storage class. And expiration, it tells me when does this expire. So I can decide when to clean up the objects and when not to. Let's not do that for now. Let's just say next. Next. So guys, what will happen here is after 30 days, my data would move to standard 1A storage. So you can actually go ahead and decide whether you want to move to Glacier. In that dropdown, you had more options as well. I did not show you that, but it is pretty understandable. You can move to Glacier as well. So this is about lifecycle, guys. One more thing, you have something called as replication. You can add replication as well if you wish to replicate your data. Cross-region replication. I believe, guys, I do not have access to do that because I'm using someone else's account for now. But let me just give you some idea as to what you can do to replicate your data. You can just go ahead and click on Get Started. So replication, to remind you people, it is nothing but a process of moving your data from bucket in one region to other bucket in some other region. So for that, I need to select a source bucket. So let us just say that this is the bucket that I have. Next. Now guys, in my case, I haven't created the second bucket. What you can do is you can just go ahead and create one more bucket. Once you create the bucket, you can select the destination bucket. For now, let us just say that this is a bucket that has been created by someone else. I'm not going to transfer data here, but let's just select this for the demo sake. This is the bucket that I have. See, it says that bucket does not have versioning enabled. This is very important point, guys. I showed you how to enable versioning, right? If you select the bucket, there is an option on the right side saying versioning. You can actually go ahead and enable versioning there. So once you enable versioning, you would be able to use this bucket. Do you want to change the storage class for the replicated objects? If you say yes, it would give you the option of selecting what storage class do you want to select, right? If you don't, you don't have to. You can say next. You have to enter an IAM role. If you do not have any, you just say create a role and then the rule name. In this case, I do not have any details about this and I don't want to create a role because this account does not belong to me. Sorry for that inconvenience, but you can actually go ahead and select create a role and just say next. And I'm sure that you can actually go ahead and your bucket starts working or your cross-region replication starts working. What happens after that is once you store your object in a particular file, you can actually move that object, not in a particular file, in a particular bucket. You can move that data from that bucket to the other bucket. And a copy of your data is maintained in both the buckets that you use. So this is what cross-region replication is, guys. I believe that we've discussed what are storage classes, we've discussed what is cross-region replication, and we've discussed versioning in general. Let us quickly move back to the presentation and discuss the remaining topics as well. So guys, I've switched into the presentation part. Till time we've discussed how cross-region replication works, we've discussed how versioning works, and we've seen how to carry out that process. The other important topic that we need to focus on is we've known like how to create versions, how to move data from one place to the other. But the thing is, what if I have to move data from a particular location to a location that is very far away from me and still ensure that there is not too much latency in it? Because if you're moving data from one location to a location that is far away from you, it is understandable that it would take a longer while. Why? Because we are moving data from internet. So the amount of data that you move and the further you move, it should take a longer while for that. So how do you solve that problem? You have S3 transfer acceleration. You can do that by using other services as well. We discussed Snowball and Snowmobile as well, but they physically move the data and at times it takes n number of days to move your data. With S3 transfer acceleration, that is not the issue because it moves your data at a very fast pace. So that is a good thing. So how can you move your data at a faster pace by using S3 transfer acceleration? Now guys, let us first understand what it is exactly. So what it does is it enables fast, easy and secure transfers of files over long distances between your client and S3 bucket. And to do that, it uses a service called as CloudFront and the edge locations it provides you. As I move further, I would be talking about what CloudFront is. Do not worry about it. First, let us take a look at this diagram. So normally if you are moving your data or directly uploading your data to a bucket that is located at a faraway distance. I mean, suppose I'm a customer and I wish to put my data into an S3 bucket, which is located maybe a continent away from me. So using internet, it might take a longer while. Instead, what I can do is I can use transfer acceleration. So how is it different? Now guys, there is a service called as AWS CloudFront. What it does is it basically lets you cache your data. When I say cache your data, that means you can store your data at a location that is in the interim or that is close to your destination. Now this service is basically used to ensure that data retrieval is fast. Suppose I'm searching for a particular URL. What happens is when I type that URL, a request is sent to the server, it fetches the data and sends it to me. So if it is located at a very far location, it might take a long while for me to fetch the data. So what people do is they analyze as in how much requests are coming from a particular location. And if there are frequent and a lot of requests, what they do is they set up an edge location close to that particular region. So you can put your data, you can cache your data on that edge location and that data can be fetched from that edge location at a faster rate. So this is how edge locations work. What transfer acceleration does is it basically puts in your data at the edge location so that it can be moved to your S3 bucket at a quicker pace. And that is why it is fast. So guys, this was about S3 data acceleration. Let us quickly move into the console part and try to understand how S3 acceleration works. So guys, I've switched into the console. S3 acceleration or data transfer acceleration is a very easy thing to do. I do not remember the bucket name. I think it was Remos something. Okay, if I select this and open it, I can actually go to the properties part. Guys, there are other things that you might want to consider. You can come here and take a look at those as well. For now, I'm just going to say go ahead and enable transfer acceleration. It is suspended. I can enable it. It gives me the endpoint as well and I say save. So guys, what this means is if I'm putting my data into this bucket, it would be transferred very quickly, or I can use this bucket to transfer my data at a quicker pace by using data transfer acceleration by S3. Again, guys, I missed out on one important point. The fact that we have been talking about buckets and stuff like that, there is something important that I would like to show to you people. First, let us just go back and disable this part. I do not want it to have the transfer acceleration thing going. And I just wanted to show it to you people how it is done. I just say go back to suspended. And one more thing, guys, if you once you actually enable the transfer part and if you upload a file, you can see the difference in the speed. The problem is you need a third-party tool to do that. So you can actually go ahead and download a third-party tool as well. And using that, you can actually go ahead and see how it works. Having said that, I was talking about buckets in general. So let us just go back and go to Remos again. There you go. And I'm gonna copy the ARN. I'll tell you why. I've copied the ARN. Now, when I open this bucket, guys, we have quite a few things. Permissions, I talked about security, right? So you can decide public access as in who gets to access your bucket. So guys, you can actually go ahead and decide who gets to access what kind of buckets. Say for example, here in your block public access, you can decide who gets to access what data publicly. For that, you have access control lists. Using these ACLs, you can actually decide who gets to access how. Other thing you can do is you can just go ahead and create a bucket policy and decide who gets to access your bucket or who gets to put your data, delete your data, and do all these things. Let us just go ahead and create a policy. Now you can write your own policy or you can just use a policy generator, which again is a third-party tool. So I want to create a bucket policy for my S3. So let's just say S3 bucket policy. And what kind of effect I want? I mean, do I want someone to access my system or do I want to deny someone from accessing my system? I can decide that. So let's for now just say that I want to deny someone from doing something. And what I want that someone to do is to deny a particular thing for that person for all the objects. I mean, I do not want that person to access any of the objects that is there. So what I say is star. That means nobody should able to do anything to any of the objects that are there in this bucket. So it says star service Amazon S3. What action I want? I want to prevent someone from deleting an object. There you go. And this is the ARN. That is why I copied it. It should be followed by a / and a star. Add a statement. And I say generate policy. So guys, the policy has been generated. I just have to copy it. If I copy this thing and I go back to the console, if I paste it here, I can say save. It's saved. I'll save it again just to be safe. So guys, we have actually gone ahead and let me just go ahead and again go to Remos. So guys, now there is an object here. Let me just try and delete this object. If I just go to the actions part here and I say delete, see the file is still here. Is it the other version? No, it's not deleted. See, there's an error here. If I click on it, it says 100% failed. Why? Access denied, because I do not have the access to delete the object right now. Why? Because I've created a bucket policy, guys. So that is what bucket policies and ACLs do. They let you make your objects or your data more secure. And as you saw in the option, there are quite a few options that you have at your disposal, which you can choose from, which you can mix and match and decide as in, okay, this is what I want to do. I want to probably give someone an access to delete a bucket. I want to give someone an access to do this or do that. So guys, this was about S3 data transfer acceleration. And we've also seen how you create a bucket policy, how you attach it to your bucket and stuff like that. Now, let me just go back and kind of brush up this session or finish this session up with a use case so that you can probably understand the topics that we've discussed a little more. First, let us go back to the use case, guys. So guys, I've switched into my presentation console again, and we would be discussing IMDb Media. Now, for people who watch movies, they might know what IMDb is. It is a website that gives you details about movies. They tell you what are the movies that are nice. If you probably select or type a particular movie name, they would give you details about it, as in who were the actors, how was the movie, how was the review, a short snippet explaining you what the movie is about, its genre and stuff like that. Plus they have their own ratings to kind of gauge in the customers even better, as in IMDb being a popular site. And when they say that this movie is this person good or liked by these many people, people normally believe it. So they have that score as well. So if you talk about a website that basically deals with movies, you understand the number of movies that are released worldwide. And if most of them are present here on IMDb, that means that database is huge. But we are talking about data that is being processed in great numbers, great amounts. I mean, when you talk about the data that is here, what is happening here is you have n number of movies that are being released. So if someone searches for a particular movie, it has to go through the database and that data has to be fetched to him right away. So how do you deal with the latency issue? Well, this would answer a lot of questions, or it would sum up a lot of topics that we've discussed here. Let us go through this use case probably. So what happens here is, in order to get the lowest possible latency, all the possible results for a search are pre-calculated with a document for every combination of letters in the search. What this means is, probably based on the letters, you have a document that is created, and it is traversed in such an order that all the data is scanned letter wise. When you actually go ahead and put forth a query, what happens is, suppose if there is a 20 character letter or a word that you put in, so there are somewhere around 23 into 1030 combinations that are possible. So your computer has to go through these many combinations. What S3 does is, it basically lets you store the data that IMDb has. And once IMDb has stored that data, they use CloudFront again. We have discussed what CloudFront is. They use CloudFront to store this data to the nearest possible location, so that when a user fetches this data, it is fetched from that location. So what happens is, basically, when these many possibilities or combinations are to be dealt with, it becomes complicated. But in practice, what IMDb does is, it basically uses analytics in such a way that these combinations become lesser. So in order to search for a 20 character letter, they basically have to go through 150000 documents. And because of S3 and CloudFront, you basically can distribute all the data to different edge locations and to buckets within hours. And since we are talking about huge amount of data, it is more than terabytes. It is like hundreds, thousands of terabytes of data. So we can understand how much data are we talking about. And S3 actually features or serves a number of such use cases or requirements. So guys, I believe by now you've understood what S3 is.
What is Amazon VPC? Amazon Virtual Private Cloud is a service that lets you launch AWS resources in a logically isolated virtual network that you define, which means you will have a part of AWS Cloud that can be used only by your AWS resources and can be accessed only by you or the people you permit to access. Now, these people could be your business partners, your employees, or anyone you want. You will have complete control over your virtual networking environment, which would include selecting your own IP addresses range, creating of subnets, and configuration of route tables and network gateway. I will explain all this term in some time. Now, Amazon VPC allows you to create multiple layers of security, including security groups and network access control list, which will help you control access to your Amazon EC2 instances in each subnet. You can use IPv4 and IPv6 for most resources in your virtual private cloud, which will help you ensure secure and easy access to resources and applications. Now that you have some idea about what exactly is AWS VPC, let us move on to our next topic and see how does it work. But before we get into the working part, I would like to explain the terms which I mentioned before. So if you're wondering what are subnets, these are logical subdivision of a larger network. You can launch your AWS resources into a specified subnet. And when I say AWS resources, I mean your EC2 instances and so on. There are two types of subnet, the public and the private. You use a public subnet for resources that must be connected to the internet. And with a private subnet, the resources won't be connected to the internet. Now, another interesting point is IP addresses of all the subnet in a network will start with the same prefix. Next we have is a route table. Now, a route table contains a set of rules called route that are used to determine where the traffic in a VPC is directed. You can explicitly associate a subnet with a particular route table. Otherwise, the subnet is implicitly associated with the main route table. Each route in a route table specifies the range of IP addresses where you want your traffic to go, which is the destination, and the gateway, which is the network interface or connection through which to send the traffic, which is the target. Now, as I've mentioned about public subnets and private subnet, let us see the difference between them. So in a public subnet, resources are exposed to the internet using the internet gateway. They make use of both public and private IPs and are mainly used for external facing applications like web servers where you want your information to be visible to the users. Whereas in the public subnet, resources are not exposed to the outer world and it uses only the public IPs. They are mainly used for backend applications like database and application servers. Now that you have some idea about subnet and route table, let us move on to the working of VPC and understand it. Now, if your account was created after 4th of December 2013, your account comes with a default VPC that has a default subnet in each availability zone. We will see this in the demo part. Now your default VPC includes an internet gateway and has the benefits of advanced feature provided by EC2 VPC and is ready for you to use. Now if you launch your instance in a default VPC and do not specify a subnet where to launch your instance, the instance is automatically launched in your default subnet, which is a public subnet. You can also create your own VPC and configure it as you want. This is known as a non-default VPC. Now the subnets that you create in your non-default VPC and any additional subnet that you create in your default VPC are called as non-default subnets. Now you can see we have something called an internet gateway. Now an internet gateway is a gateway that allows your instances to connect to the internet. You can do this through Amazon EC2 Network Edge. Each instances that you launch in your default subnet has a private IPv4 address and a public IPv4 address, as you can see here. By default, each instance that you launch in a non-default subnet has a private IPv4 address but not a public IPv4 address unless you specifically assign it. These instances can only communicate with each other but cannot access the internet. But you can enable internet access for these instances by attaching the internet gateway to its VPC and associating an elastic IP address with the instance. Now, how can you connect your VPC to other VPC or to your on-premises network? So for this, you can create a VPC peering connection between the two VPCs that enables you to route traffic between them privately. Now, instances in either VPC can communicate with each other as if they were in the same network. You can also create a transit gateway and use it as an interconnection between your VPC and your on-premises network. The transit gateway acts as a regional virtual router for traffic flowing between its attachment, which could include VPC, VPN connection, AWS Direct Connect gateways, and transit gateway peering connections. Now I hope you have some idea about the working of VPC. Let us move on to our next topic and see some of the use cases of VPC. With Amazon VPC, you can host a simple web application such as a blog or a simple website with additional layer of privacy and security. You can help securing the website by creating security group rule, which will allow the web servers to respond to inbound requests from the internet while simultaneously prohibiting the web servers from initiating outbound connection to the internet. Now what this means is you can control your data traffic in and out of your VPC. You can create a VPC that supports this use case by selecting VPC with a single public subnet only from the Amazon VPC console wizard. With VPC, you can also host multi-tier web application and strictly enforce access and security restriction between your web servers, application servers, and databases. You can launch web servers in a publicly accessible subnet while running your application servers and databases in a private subnet. This will ensure that your application servers and databases cannot be directly accessed from the internet. To create a VPC that supports this use case, you can select VPC with public and private subnet in the Amazon VPC console wizard. With Amazon VPC, you can also back up and recover your data after a disaster. By using Amazon VPC for disaster recovery, you will receive all the benefits of a disaster recovery site at a fraction of the cost. You can periodically back up critical data from your data center to a small number of Amazon EC2 instances with Amazon EBS volume. Or you can also import your virtual machine images to Amazon EC2. To ensure business continuity, Amazon VPC allows you to quickly launch replacement compute capacity in AWS. These were some of the use cases of using VPC. Now let us move on to our next topic and see an overview of the other networking concepts in AWS. First, let us talk about Elastic Load Balancer. Elastic Load Balancing automatically distributes your incoming traffic across multiple targets. The targets could be EC2 instances, containers, and IP address in one or more availability zones. It will monitor the health of your registered target and route traffic only to the healthy target. It scales your load balancer as your incoming traffic changes over time. You can add and remove compute resources from your load balancer as your need changes. It will not disturb the overall flow of requests to your application. Now, Elastic Load Balancing offers 4 types of load balancer. First is the classic load balancer, which provides basic load balancing across multiple Amazon EC2 instances, and it operates both at request level and the connection level. A classic load balancer is intended for applications that were built within the EC2 classic network. Second, we have Application Load Balancer. It is best suited for load balancing of HTTP and HTTPS traffics and provides advanced request routing which is helpful in modern application architecture, including microservices and containers. Third, we have Network Load Balancer, which is best suitable for load balancing of TCP, UDP, TLS, where extreme performance is required. A network load balancer routes traffic to targets with an Amazon VPC and is capable of handling millions of requests per second while managing ultra-low latencies. Fourth, we have the Gateway Load Balancer. It is used to deploy, scale, and run third-party virtual networking appliances. Gateway Load Balancer is transparent to the source and destination of traffic, which makes it well suitable for working with third-party appliances for security, network analytics, and other use cases. This was about Elastic Load Balancer. Now let us take a look at AWS Direct Connect. AWS Direct Connect is a cloud service solution that makes it easier for you to establish a dedicated network connection from your on-premises to AWS Cloud. Using AWS Direct Connect, you can establish a private connection between AWS Cloud and your data centers or your office. You can increase the bandwidth throughput and provide a more consistent network experience than internet-based connections. AWS Direct Connect is also compatible with all the AWS services and is available in the speed starting from 50 Mbps and can be scaled up to 100 GB per second. It helps you build hybrid environment, which allows you to use the benefits of AWS and continue to utilize your existing infrastructure. Now let us move on to our next service, which is Route 53. Amazon Route 53 is a highly available and scalable cloud domain name system or DNS web service. It is designed to give developers and businesses a reliable and cost-effective way to route end users to internet applications by translating names into numerical IP addresses. This can be used for computers to connect to each other. Now Route 53 performs three main functions. First one is it registers your domain name. Every website needs a name, be it edureka.co or anything like facebook.com. So Route 53 lets you register a name for a website or web application known as a domain name. The second function is it routes internet traffic to the resources for your domain. So when a user opens a web browser and enters your domain name or the subdomain name in the address bar, Route 53 helps connect the browser with your website or web application. The third function is it checks the health of your resources. Route 53 sends automated requests over the internet to a resource, such as a web server, to verify if it is reachable, available, and functional. You can also choose to receive notification when a resource becomes unavailable and choose to route internet traffic away from the unhealthy resources. Now these were some of the networking services in AWS. Now let us move on to the demo part where I will teach you how you can create a VPC, your subnet, your route table, and an internet gateway. So for our demo, I've logged into my AWS console. If you do not have an AWS account yet and want to practice AWS services, I would highly recommend you to create an AWS free tier account where you can access more than 75 AWS services for free for a year. So a point to remember is your VPC will be set in this region. In my case, it is Ohio. You can see there are so many regions available here. Your VPC can be set in your selected location. Now let us start a demo. We'll search for VPC. You can just search over here, VPC. Here it is. Now when you click on your VPC, you can see there is a default VPC as I mentioned before. It will also have a default subnet inside it. So now let us create our own VPC. So we'll click on create VPC. So it will ask us to name our VPC. Let me name it demo VPC. Now when you create a VPC, you must specify a range of IPv4 address for the VPC in the CIDR block, which stands for classless inter-domain routing. We will go for the primary CIDR block, which is 10.0.0.0/16. Now mention 16 over here, which means 16 bits is reserved for my VPC network. Now we'll go with the default. I do not want any IPv6 CIDR block. Next we have tenancy. Now here you can see we have two options. One is default, the other one is dedicated. So what dedicated means is you can run your instances in your VPC on a single tenant or a dedicated hardware. So we'll just stick to default here and create our VPC. Then you'll get a message saying you have successfully created your VPC. This is your VPC ID and this is your VPC name. Now let us create our subnet. Now as I've told you in the theory session, a default subnet is created. And you see we have three default subnets over here. When I just scroll here, you see the three default subnets are created in three different availability zones. So each availability zone has one subnet in it. So now let us create a new subnet. We have to select a VPC from here. This is a VPC. Next we'll come down and we'll name our subnet. Let us name it demo subnet. Now we have to select the availability zone. We have 3 availability zones in OIO. We'll just select one of these. Now we also have to mention our IPv4 CIDR block for our subnet. So we'll just set it to 24. So when I type 24 over here, it means 24-bit is reserved for my VPC network. Now the starting of the IP address of the subnet should be the same as the starting address of your VPC. Now after this, let us create a subnet. This might take a few seconds, and you can see you have successfully created your subnet. This is your subnet ID and this is your subnet name. Next, we'll create our internet gateway. We'll get back to route table in a few minutes. Now as you can see, there is a default internet gateway, but we will go ahead and create our own internet gateway. So here it will ask us to name our gateway. Let's just name it demo internet gateway and just create our internet gateway. It is very simple. Now our internet gateway is created. This is our internet gateway ID, but the state is detached. Now you can go attach your VPC to your internet gateway. Just click on attach to a VPC over here and just select a VPC from here. Here is our VPC, so we'll just select it. And now attach internet gateway. So here, the state is attached. Now let us move on to the next step and create a route table. Now as I mentioned before, route table determines where the network traffic from a VPC is directed. Now these are some of the default route tables, but we'll create a new route table. So now we have to name a route table. Let us name it demo route table. And we have to attach a VPC to it. Here is a VPC. Let us create it. We'll get a message saying a following route table was created, and here is the route table ID. We'll close it. So after we create a route table, we have to associate a subnet to it. So we'll just click on route table over here. Go to subnet association, edit subnet association. Now select a subnet. So this is a subnet, demo subnet. So we'll save it over here. After the subnet association, we have to edit the route to access the internet gateway. So we click on route, edit our routes. Now let us add another route. So the destination will give 0.0.00. Now this means your traffic can flow anywhere. The target will keep it as internet gateway. So we're trying to access our internet gateway. So we'll select this and then save the route. Now we get a message saying route successfully edited. We'll close it. Now with this, we have created a VPC, a subnet, a route table, and an internet gateway. Now let us see if we can launch an instance in our VPC. But let me go to new tab, AWS Management Console. Let me type EC2 over here. I'll go to instances. I'll go to launch instances. Here, let me launch in window instance. So I'll select window. Now I'll select this instance and then go to configure instance. Now here under network, I'll remove the default VPC network and set my network. I'll change the subnet also. And we also have to change the auto assign public IP to enable. We will enable this to create a public IP. So after this, we'll make no changes. Go to review and launch. Before that, let us create a security group. Let us just name it demo security group. And now review and launch. We'll use an existing key pair and now launch our instance. Now let us click on view instance. Now this might take a couple of minutes. While our instance is getting created, let us go back to a VPC. We go to VPC dashboard, and here you can see there are two VPC. One is a default VPC and the other one which we have created. And there are 4 subnets. 3 are defaults and 1 which we have created. There are 2 default route table and 1 which we created. There was 1 internet gateway which was default, and then we created another one. Now let us check our EC2 instance. We'll refresh it. Now you can see 2-on-2 status check is passed. So we'll click on our instance ID. Now this is our instance ID. This is a public IPv4 address, a public IPv4 address. Now when we come down and see the VPC ID over here, You can see the instance was created in our VPC ID. That is the name of our VPC, and it was also created in our subnet, which is the demo subnet. And you can also see it was set up in the availability zone you had mentioned. Now the instance can be used only by me or the people I permit. A part of AWS Virtual Cloud was given to me to run my resources.
Suppose you are a particular user and you're trying to visit a particular website, and imagine that that website is based somewhere at a very far location. Suppose you're based somewhere in USA and that website, its server actually hosts or is based in Australia. Now, in that case, when you make a request for particular object or particular image or maybe content, now your request is sent to the server that is in Australia, and then it gets delivered to you. And in this process too, there are quite a few interrelated networks that deal which you are not aware about. The content directly gets delivered to you, and you have a feeling where you feel that you type in a particular URL and the content is directly made available to you. But that is not how it works. Quite a few other things happen in the interim. And due to that, what happens is the data that gets delivered to you, it does not get delivered to you very quickly. Why is that? Because you'd be sending in a request, it would go to the original server, and from there the content is delivered to you. Now, if you are based in USA, the situation would be convenient if the data is delivered to you from somewhere close by. Now, when you talk about a traditional system where you are sending a request to somewhere in Australia, this is what happens. Your data or your request is sent to the server based in Australia, and then it processes that request and that data is made available to you, which gets delivered to you. But if you have something like CloudFront, what it does is it sets in an intermediate point where your data actually gets cached first, and this cached data is made available to you on your request. That means the delivery happens faster and you save a lot of time. So how does AWS CloudFront exactly do it? Let's try to understand that. Well, when you talk about AWS CloudFront, what it does is first and foremost, it speeds up the distribution process, and you can avail any kind of content, whether it's static or dynamic, and it is made available to you quickly. What CloudFront does is it focuses on these 3 points. One is your routing, 2 is your edge locations, and 3 is the way the content is made available to you. Let's try to understand these one by one. When you talk about routing, I just mentioned that the data gets delivered to you through a series of networks. So what CloudFront does is it ensures that there are quite a few edge locations that are located close to you, and the data that you want to access, it gets cached so that it can be delivered to you quickly. And that is why the data that is being delivered to you is more available than in any other possible case. So what happens exactly, and how does this content gets delivered to you? Let's try to understand this with the help of this diagram. Suppose you are a user. So basically what you would do is you would send in a request that needs to reach a particular server. Now in this case, what happens is first your request, it goes to an edge location and from there to your server. To understand this too, you have to understand 2 scenarios. First and foremost, suppose you are based in USA and you want to fetch a particular data that is based in Australia, you would be sending in a request. But what AWS does is instead of sending that request directly to your server, which is based in Australia maybe, it has these interim edge locations which are closer to you. So the request, it goes to the edge location first and it checks whether the data that you're requesting is already cached there or not. If it is not cached, then the request is sent to your original server. And from there, the data is delivered to the edge location. And from there, it comes to you. Now, you might wonder, as in this is a very complex process. And if it is taking these many steps, how is it getting delivered to me quicker than in normal situation? Well, think of it from this perspective. If you do send in this request directly to the main server, again, the data would flow through some network and then it would be delivered to you. Instead, what happens here is at your edge location, the data gets cached. So if you request it again, it would be delivered to you quicker. If it is requested by anyone else, it would be delivered to them quicker. Plus, how edge locations work is when you do send in this request and when the edge location fetches this data from your so-called original server, in that case too, when the first byte it arrives at your edge location, it directly gets delivered to you. And how does this content exactly get stored here? Well, first and foremost, what happens is what your edge location has is it has some regional cache as well. Now this cache would basically hold all the content that is requested more frequently in your region. Suppose a website has some n number of content, and out of it some content is kind of requested a lot in a particular region. So surrounding that region, the closest edge location would have a regional cache which would hold all the content that is more relevant for those users, so that it can be frequently delivered to these users and can be made available to them quickly. In case if this data gets outdated and it is no longer being requested, then this data can be replaced with something else that is requested more frequently. So this is how CloudFront works. What it does is it creates a distribution and you have some edge locations through which you can actually request that data faster. So what are the applications that CloudFront has to offer to you? Now, I won't say applications. Instead, I would say some of the benefits of using CloudFront. Let's try to understand those one by one. First and foremost, what it does is it accelerates your static website content delivery. We just discussed that. That means if you're requesting a particular image or something like that, it gets delivered to you quicker. Why? Because it is cached at your edge location and you do not have to worry about any latency issues. Next, what it does is it provides you various static and even dynamic content. Suppose you need some video or a live session or something like that. Even that gets delivered to you quickly. I just mentioned that when you request a particular thing, when the first byte it arrives at your edge location, your CloudFront starts streaming that to you or start delivering that to you. Same happens with your live streaming videos as well. You would be getting that streams instantly without any latency whatsoever. Encryption. Now, when you do access this content, what AWS CloudFront does is it lets you have this so-called domain where you put in HTTPS and you get secured data. So you already have one layer of security, but it also lets you add another layer of security by giving you something called as encryption. By encrypting your data or by using your key value pairs, which is the same, you're actually ensuring that your data is more secured and it can be accessed privately as well. Customization at the edge. Now, what do I mean by this? Now, there is some content that needs to be delivered to the user or to the end user. If the customization it happens at the server, again, it might be time consuming and there are quite a few drawbacks of it. Say, for example, I need a particular content and it needs to be processed or customized at the very last moment. So these things can be done at the edge location as well, thus helping you save time, money, and various other factors as well. And finally, what it does is it uses something called as Lambda Edge, which again lets you deal with various customizations and lets you serve your content privately. So these were some of the applications or uses of CloudFront. What I'm going to do now is I'm going to switch into my AWS console and I'm going to talk about AWS CloudFront distributions and how can you go ahead and create one. So stay tuned and let me quickly switch into the console first. So yes, guys, what I've done is I've gone ahead and I've logged into my AWS console. Now, for people who are completely new to AWS, what you can do is you can actually go ahead and create a free tier account. You have to visit AWS website and search for free tier. You would get this option. Just create an account. They would ask you for your credit or debit card details probably, but they won't charge you. A minimal amount is charged and that is reverted back to your account. That is for verification purpose. And after that, what AWS does is it offers you certain services which are made available to you for free for one complete year. That is, as long as you stay in the limits or the specified limits which AWS has set. So those limits are more than enough to practice or to learn AWS. So if you want to go ahead and get a proper hands-on on various AWS services, I would suggest that you do visit their website and create this free tier account. Once you do have that account, you have all these services that are made available to you. As I just mentioned, there are 70 plus services, and these are the services that are there, which you can actually go ahead and use for different purposes. Our focus today, however, is creating a CloudFront distribution, which we just discussed in the so-called theory part. I would be repeating few topics here too while we do go ahead and create our CloudFront distribution. Now, as I've already mentioned, we want to fetch data or fetch a particular object, and if that is placed at a particular edge location, that would be made available to me. So what we are doing here is, imagine that our data is placed at a particular original server. In our case, let's consider it as an S3 bucket. Now, S3 is nothing but a storage service with AWS, that is simple storage service rather, that is SSS. and that is why we call it S3. So what we are going to do is we are going to go ahead and create an S3 bucket. In that, we would be putting in certain objects, and we would be accessing that by using our CloudFront distribution. So let's just go ahead and create a bucket first. You can see we have S3 in my recently used services. You can just type S3 here and that would be made available to you. You can click on it and your simple storage service opens. You would be required to go ahead and create a bucket. This is how you do it. You click on create and you give it some name, say maybe bucket, use small letters, bucket for AWS demo maybe, and I would give in some number 000. I say next. I need a basic bucket, so I won't be putting in any details. Do we have a bucket here? There you go. We have a bucket here, and in this bucket what I'm going to do is I'm going to put in some content that we can actually request for. So let's just go ahead and create an HTML file and put in maybe an image or something. So I have a folder here. In that folder I have a logo of Edureka. I would be using that logo, and I would want to go ahead and create an HTML file which I can refer. So I would open my notepad and I would write a simple HTML code. I won't get into the details of how to write an HTML code. I assume that you all know it. If not, you can use this code. So let's create a head file basically, or a head tag rather. Let's say demo tag maybe, and I close this head tag. I need some body in here, right? So let's say let the body be say welcome to Edureka, and I end the body here, and I save this file. I say save as. Where do I want to save it? And save it here, and I would save it as say maybe index.html. I say save. It probably got saved somewhere else. Let me just copy it and paste it here. I've done that. This is the file. Now we have these files. Let's upload it to our S3 bucket. Come here, I say upload. I want to add files. So add files. Where do I go? I go to the F folder, I go to demo, and I select these two files and I say upload. There you go. My files are here and I say upload. Small files, so should not take a long time. 50% successful, 100% successful. There you go. You have these two files. Now we have our S3 bucket and we have two files. This is our origin server. Now I need to create a distribution and use it. To do that, I would click on services and come here and I would search for CloudFront. There you go. And I say create a distribution. So I click on this icon. Now you have two options. First one is something that lets you have your static data moved in or moved out. Or if you want to live stream your data, you should go for this option, but that is not the case. We would be sticking to this thing. I say get started. I need to enter in a domain name. So it gives me suggestions, and this is the first one which I just created. Original path is something that you can give in for the folders from where you want to access the data, but mine directly resides in the bucket. There are no extra folders, so I don't need to enter anything. Original ID, this is what I have here basically. I can use this, or I can just go ahead and change the name if I want to, but I would let it stay the way it is. Restrict bucket access, yes, I want to keep it private, so I say restrict and I create a new identity. And there you go, I have a new user created here. Apart from that, grant read permissions on bucket, yes, update my bucket policy accordingly is what I would say. Then I would scroll down, customer headers and all, I don't need to put in these details. How do I want my data to be accessed? The protocol policy. I would say redirect HTTP to HTTPS so that it is secured. If I scroll down, I have some other options as well. Cached HTTP methods and all those things. Do I need to change these? Object caching, can I customize it? Yes, I can, but again, I would be using the by default one. If you want to, you can customize it. Smooth streaming, no. These are some of the things that you need to focus on. If you have some streaming data, you can put in details accordingly, but we are not doing that. What is the price class that you want to choose? You have some options here which you can pick from. I would be going for the default one. And then I just scroll down and I say create a distribution. So your distribution is getting created now. And this process might take a longer while. If you click on this thing, you'll realize that it is in progress, and it takes somewhere around 10 to 12 minutes for this distribution to get created. So meanwhile, I'm gonna pause this session and I would come back with the remaining part once this distribution is completed. So bear with me for that while. So there you go. The distribution has been deployed. The status is deployed here. So we can actually go ahead and use this thing. Now we have a domain name here, which I can use, and I can just enter it here and we would be redirected to the page. And what happens here is you would be actually given access to this page through the edge location. That means you're not going to the server. Instead, the data is being cached to you from your distribution or your edge location rather. So you enter this website and you hit the enter button. There's an error. It shouldn't have been. Oh, I know what just happened. When you do go ahead and create your so-called distribution, in that you actually have an option of selecting a by default file, which I did not. So I'll have to give in an extension here saying /index.html. And if I hit the enter button now, it should redirect you to the demo tag, which says welcome to Edureka, right? So this was the HTML file that we created. And we also had a PNG file which we wanted to access. The name was logo.png. Okay, this is funny. This should not happen. Why is this happening? Let's take a look at it, whether we have that file there, because if it was there, we should be able to access it. And what was my bucket? This was the one. Oh, this has happened. When I uploaded that file, it got saved with this extension .png. So if I come here and I type .png here, there you go. You have that object delivered to you through your so-called distribution.
Why do we need access management? All right, so to discuss this topic, let's understand it using an example. Say you have a company in which you have a server, and this server has everything in it. It has all the modules in it, and it gives you it gives different users the permission to use the different servers, right? Now, in your company, first of all, you should have an administrator which will have all the rights to access the server, right? So nobody in the today's IT world works on the root account, right? So there has to be an administrator account. So first we will create an administrator account with all the permissions. Now tomorrow, say a UI developer comes into your company, right? Now a UI developer will only work on the graphical tools, right? So he should only be allowed the graphical tools and not some other tools. Maybe he shall not be given the internet access or something like that, right? Maybe he's not giving the PowerPoint access, maybe he's not given some folders access, some drives access, anything like that. So all of that can be defined in the server by the administrator, and specific rights will be given to a UI developer, right? Similarly, if after that a business analyst comes in, so he should only be able to access the analytics module which is there in your server, right? He should not be able to get into the UI development part, or he should not be able to see the other aspects of what is there in your server, right? So each and every user or every role will have specific rights assigned to them, right? And this is done by policies which are in turn given by administrators, right? So this is what access management is, that giving each role the specific rights that they deserve. And this is what we are going to accomplish today in AWS, right? So this is why we need access management. Let's go ahead and understand how can we accomplish this in AWS, right? So to accomplish this in AWS, you need a service called IAM. You have a service called IAM which uses this concept of access management and allows you to give it to your users who are going to use your account, right? So what is IAM? So IAM is basically a service from AWS using which you can give permissions to different users who are using the same AWS account that you have created, right? So in a company in any company, be it, you don't have to have 2 or 3 AWS accounts. You can have one AWS account on which a number of people can work, right? For example, you can define that maybe a developer would like to work on your AWS account, and he should only have the EC2 instances, or he should only work on the EC2 instances. You decide that, right? So you can define a policy like that only the developers will only be able to access the EC2 instances on your AWS account. Similarly, if say a database administrator comes in, so he should be only able to access the DB instances on your AWS account, and so on, right? So all of that is possible using IAM. But IAM is not only about creating users and creating policies. It's more, there is more to IAM, right? And hence we'll be discussing the different components of IAM now. So let's go on and see what are the different components. So there are basically 4 different components in the IAM service. So the first service is user, then we have groups, then we have roles, and then we have policies. Right? So the way we are going to go about these are, first I'm going to explain you each role or each service in IAM, each component in IAM, and then we're going to see how we can execute them or create them in the AWS console. Right? So let's start with the users. So the very first time you actually create a AWS account, that is basically the root account that you have created, right? So there is no user inside it. So why do we basically need a user? You need a user because you are supposed to give permissions to someone, right? So say I first of all want to give administrator rights to a user. Right? So you understand, you have to have an entity first to which you can assign permissions, right? So these entities are called users on AWS. So any person who wants to access your AWS account has to be added as a user in IAM, and then you can attach different policies onto that user. Right? So this is what user is all about. Let me go to my AWS management console and show you how you can create a user in IAM. All right, so give me a second. All right, guys, so this is my AWS sign-in page. All right, so this email ID, when you log in through your email ID and your password, that is basically your root account. So what I'm going to do right now is I'm going to log in using my root account and first create a admin account for myself. All right, guys, so you should never work in your root account. You should always have an administrator account through working. The root account should only be used when there is an emergency. Say you have been logged out of your administrator account, only then you should be using your root account. So the first thing that you should do when you enter your root account is go to IAM, which is just right here. Go to IAM and then you will have this dashboard thing, right? Over here you can see there is a thing called users. You will click on users and you will click on add user. All right, so now it will ask you for the username, so you can provide a username. Say I'll add my name first, so that be Hemant, right? And what kind of access do I want to give to this particular user? So there are basically 2 kinds of access that I can give. First is the AWS management console access, and then we have the programmatic access, right? So what is these two? If you want to, so there are basically 2 ways you can access the AWS resources, right? You can either access them using APIs, that is using your code. Say you have created an application which is interacting with your AWS resources, right? So in that case, if you're interacting with the APIs, using the APIs, that is called the programmatic access. Right. Secondly is the AWS management console access. That is when you are using the AWS website to actually deploy resources or create or remove policies or whatever, right? So that is called the AWS management console access. So for my user, I'd be giving it both the accesses, that is programmatic access and the management console access. Also, guys, when you enable the programmatic access, basically you get the access key and the secret key as well. What are these? I will be explaining you in a bit. All right, so we have selected both of these options and then move ahead to choose the password. So do you want an auto-generated password or a custom password? I'll choose a custom password since I'm creating account for myself, right? So I'll choose a custom password. And do I want to reset the password on my first login? No, I don't want that. So I'll click on next permissions. All right, so what kind of permissions do I want my account to have? I will be configuring that over here. So as of now, there are no groups. There is no existing user that I can copy from. So I'll attach existing policies. And since I want to attach the administrator access, that is the first policy over here, I'll select that and click on next. All right, so you can review all the settings that you did over here. and click on create user. This will create a new user in your AWS account. So as you can see, I have got my access key ID and a secret access key. Now guys, the secret access key, you only get it to see one time, only one time when you have created your account. So it is essential that you store your access key and a secret access key once you get this page. All right, so let me store it quickly. So this is my access key ID. Why we are copying it, you'll get to know during the session. Don't worry. And my secret access key, which is this, so let me copy this and paste it in the notepad. All right, so don't worry, you might be thinking that I've exposed my secret key to you, so I'll be deleting this account afterwards, so you don't have to worry about that. All right, so I've got my access key ID and my secret access key, so that is done. Now what I'll be doing is I'll be logging out from my root account and logging in this user account that I just created. All right, so one more thing that you have to be very careful of, that you will not be logging in through the same login page that you just saw, right? So you'll have to log in through a different login page now, and the URL for that is this, right? So you'll be logging in through this link as from now on. So whenever you create a user, if you want them to log into your account, you have to give them this link to log into, right? So let us copy this link over here and log out from our root account. All right, so I've logged out. I'll close this and I'll come here and go to this particular link. All right, so once you reach this particular link, it will be asking you the account name, which will be self-filled by your link, right? So you have to give your username now, which is Hemant, and then the password. So I'll type in the password that I've given it and click on sign in. So now I have basically signed in to the user that I've just created on my root account. Right, so I no longer have to use my root account. I can basically lock away my root account for emergency purposes. I'll be using my administrator account from now on. I can do everything from my administrator account that could be done from my root account as well. But there are cases wherein you get locked out from your administrator account. In that cases, you will be needing your root access. All right. So moving on, guys. So I'll go to IAM now. So as you can see, we have created a user and we have logged into that user. And if I go to IAM now, you can see that it will show that one user has been created. That is here. All right. So let's get back to our slide and discuss the next component. All right. So we've discussed what are users. Let's move on to the second component, which are groups. All right, so whenever you create users, they can also be combined into groups. Now, why do we need groups? We need groups because, say, let's take an example. So say you have 5 users and these 5 users have to be given identical access, right? Say these 5 users belong to the development team and the developing team has to have some common access that they all will have, right? Now, one way of doing this would be that I would go to each and every user and attach a policy that they need. Right, the smart way to do this would be to include them inside one group, and to that group I will only once I will attach the policy and it will apply to all these 5 users, right? So these are why groups are very important. Now how we can create groups, let me shed a light on that. So you will go to you can see you can click on groups over here, and what you'll do basically is you'll click on create new group. All right, so let me give the group name as live demo. All right, and I'll click on next step. Now it will ask me the policy that I want to attach to this particular group. All right, so say for example, I just want this group to be able to access the S3 service from AWS. So what I'll do is I will select the policy which says Amazon S3 full access, and I'll click on next step. Now this policy basically tells you that you're going to only use the S3 service in the management console and no other service. All right, so I'll click on create group, And now whichever user I will be putting inside this group will have this property. All right, so I don't have to configure the policy for any user now. So what I'll do is I'll create a new user now. So say I create a new user saying test. All right, and then I'm not giving him the programmatic access, I'm just giving him the management console access. All right, I'll click on this and I'll give it a custom password, and then I don't want him to reset his password. I'll click on next. Right, and now it is asking me whether I want to include it inside a group. So yes, I do. I want to include it inside the group that I've just created, and I'll click on next and review all the settings that I've just did and click on create user. All right, so the test account has just been created. Now, as you can see, guys, in the case of my account, which I created, I got an access key and a secret access key. Right, so in this case I'm not getting any because I didn't select the programmatic access. Only when you select the programmatic access, it will give you the key so that your application can actually interact with the services that you have launched. All right, so I've created a test user successfully. Let's log into this test user. So I will type in the URL that has been given to me. Right, now when I'll reach this page, I'll enter the username as test and the password as what I have entered, right? And I'll click on sign in. Now with this, you can see that I will now be able to see the management console. The management console will exactly look like how it was used to see, how I used to see it in my root account or my administrator account. But when you will try to access, say, a service which you have not been assigned to, say, for example, I only have access to S3 right now because I've deployed it in the group where it has only the access to S3. If I try to go inside EC2, let's see what will happen. Right, so it says you're not authorized to describe running instances. As a matter of fact, I'm not authorized to see anything on my EC2 page. All right, so that is because I don't have access to the EC2 dashboard. But let's see if I can see the S3 dashboard. So I'll quickly go to S3. And if I have the S3 access, I'll be able to see all the buckets which are there in my S3. And yes, I do. So let me go inside a bucket and delete something so that, all right, so let me delete an object from this particular bucket. So yes, I can delete it. All right, so let me check if what happens if I delete or I detach this particular policy from that group. All right, let's see what happens. So I'll go to IAM and I'll go to groups. I'll go to this particular group and I can see that the policy is listed over there. What I'll do is I'll click on detach policy and let's see what happens now. Right, so I'll go to management console. So if now I try to access S3, it will show me that access is denied. Right, so I no longer have access to the S3 service on my AWS console. So this is how you can control access to different users. You can revoke access, you can include access, right? You can do all of that in IAM. All right, so let us come back to our slide to discuss our next component. All right, so we've discussed what are users, we've discussed what are groups. Now let's come down to roles. All right, so roles are similar to users, but roles are actually assigned to applications. All right, so users are actually assigned to people, right? So whenever you have a developer in the company, you will assign him the developer roles, right? But when you have roles are basically assigned to applications. How? Let me explain you. Say you create an EC2 instance, and inside that EC2 instance, you're hosting a web application. Now that web application has been designed in such a way that it has to interact with your S3 services, for example, that we'll be doing today. I'll be showing you the demonstration today for this, right? So say that application has to interact with the S3 service. Now, if I want to want that application to interact with the S3 service, I have to give it permissions. And to give it permissions, I will use role. So I will create a role wherein I will specify that this role can access the S3 service, and I will attach this particular role to that particular EC2 instance in which my application is hosted. And in that case, my application will be able to interact with the S3 service. Right? It might sound complicated, guys, but it is very easy to implement. Let me show you how. So what I'll do now is I'll go back to my management console, which is here. All right, I'll go to the dashboard and say I'll go to roles now. All right, so I'll create a new role. Now roles can be assigned to any AWS service which is listed here. What I'll do is I'll assign it to, I'll create a role type of EC2. All right, so I'll select Amazon EC2. And what type of role do I want to apply it to? I want to say have the access to S3, right? So I'll select Amazon S3 full access over here, and I'll click on next step. So it'll ask me the role name. So let me specify the role name as Edureka_1, right? And I'll click on create role. So with this, a role has now been created, but mind you guys, I've not attached this role to any EC2 instance, right? So what I'll do now is I'll go to my EC2 console. So over there, I already have built an EC2 instance. It is stopped, so I'll start it and attach this particular policy to that EC2 instance. All right, so my EC2 instance name is Hemant_1. So here it is. I'll go to actions. I'll start this particular instance, right? And what I can do is I can attach the policy using instance settings. It says attach or replace IAM role. I'll go here. I will go to the drop down and select the role that I've just created, which is Edureka_1. I'll select that and I'll click on apply. Now with this, what will happen is my role is now my EC2 instance is now configured to interact with the S3 service in this particular account. All right, so any application that I deploy in this EC2 instance will be able to interact with the S3. Okay, so I don't have to specify any access key, any secret access key. If you're still confused with that, be patient. We are getting on to where do we actually use these keys and where do we not. All right, so this is what your roles are all about, right? So roles, like I said, they are for resources in AWS. Users are for people. Roles and users are similar things. You attach policies onto them, and they basically identify a particular instance or a particular person as the owner of that particular service, right? So we've discussed what roles are. Let's move on and discuss policies. So if you think about it, guys, we've actually been dealing with policies, right? So policies are nothing but permissions that you give to your with whatever role or user or group that you have created, right? So for example, I want to give the EC2 instance access, right? So that EC2 instance access is basically a policy that I'll be attaching to the user or to the roles. All right, let's see how we can create policies, guys. So I'll go to my management console. I'll go to IAM. Right, so you can either create policies or you can actually use the already existing ones. So there are a couple of policies that have already been created in your AWS account, but you can go ahead and create your own policy as well. All right, so let me show you how. So say for my test account, what I'll do is I will go inside test account. All right, and I will add permissions and I will attach existing policies directly, and here I am, guys. So now you can create policies as well. So you see the tab over here, guys, it says create policy. So if you feel the kind of policy that you want to create is not listed over here in the default policies, you can actually create one. And creating a policy is very easy, guys. You'll just click on create policy and you will see this page. All right, so you'll have three options. You can either copy an AWS managed policy, that is a default policy. You can create your own policy by just typing in the JSON code. And if you're not comfortable with coding, what you can do is you can use the policy generator. Now, what is policy generator? Let me explain you. So with policy generator, you just have to select what effect do you want. Do you want it to allow it or do you want it to deny it, right? So say I want to allow the EC2 service to this particular test account. All right, so I'll go to EC2. All right, here it is. I selected EC2. What kind of actions can he perform? Say I want to give him all the actions. You can do anything with EC2, and resource name is basically a particular resource. So with ARN, you can identify a particular resource. So I don't want a particular resource to be assigned to him. I want he can access every resource in EC2, right? So I just add star for all of them, right? And click on next step. So with this, as you can see, it has automatically created a policy document for you. All you have to do now is click on create policy and it will create the policy for you. So as you can see, there were 18 customer managed policies. There are now 19. So I can go here and select the policy over here. All right. So if I go to my user now, which is test, and go to permissions, I will just click on add inline policy, click on select, again go to EC2, select actions, all actions, right, and put it to star. So I'll click on add statement, click on next step, and click on apply policy. So a policy has been applied on the test user that it can actually access the EC2 instances now. So if I go to my test user now, in which I was not allowed to access the EC2 instances, I can actually use the EC2 instances now. So if I go to EC2, you can see it will not give me the access denied thing, right? So I can access all the instances over here as if I was using the root account, but only for the EC2 service, right? If I go to S3, you can see I will still have the access denied page because I've not been assigned the access to this particular service. All right. One more thing, guys. What if you add an allow and a deny policy together inside a group? What will happen then? So in that case, so since I have allowed EC2 access, what I'll do is I'll deny EC2 access as well in this particular user. So I'll create one more policy and I'll say deny. I'll select EC2. Right. I'll select the actions as all actions. I'll give the resources all, add the statement, and click on next step, apply the policy. So now I have denied EC2 instances as well and created and allowed EC2 instances as well. What do you think will happen now? So if now I try to go to EC2, let's see what will happen. So it will say you're not authorized to use EC2 anymore, because whenever you're creating policy, guys, you either get the allow option or the deny option. If you have selected both of them, it will always prefer the least permission that you have given. So in our case, that is the deny option, right? So it will always deny the case even if you have allowed it in the same user, right? If you have mentioned that that particular service has to be denied to that particular user. All right, so this was about policies, guys. Let me come back to my slide. So we have discussed what are users, what are groups, what are roles, and what are policies. Let's go ahead and discuss the very important part of authentication, which is called the multi-factor authentication. So what is multi-factor authentication, guys? So multi-factor authentication is basically something like OTP that you get when you're logging into your Gmail account, right? So you enter your Gmail email ID, you enter your password, and when you click on continue, it'll ask you for your OTP, right? So same is the case here as well. You can configure your AWS account in such a way that you will enter your username, you'll enter your password, and when you click on login, it'll also ask you for a code that has to be given to it. Now that code is basically the multi-factor authentication thing that we're talking about. So there are basically two layers of security now. One layer is a password, and second layer becomes the code that you'll be entering, right? Now, with AWS, there is an application called the Google Authenticator, right? Which you can use to create a virtual multi-factor authentication device. Now, for those of you who already are using multi-factor authentication in your companies, so there's a thing called Gemalto, right? So people who work from home and they have to connect to their company's network, the way you connect it is using a Gemalto token, right? And so those of you who are from the IT background, you can relate to it, right? But if you want to go through a simpler way, you can actually create a virtual multi factor authentication device. And to create that in your AWS is pretty simple. You just have to download an application called Google Authenticator on your phone, and you have to connect that application to your AWS account, and that is it. Now it might sound tough, but it's very simple. Let me show you how. So you will basically go to your AWS management console, and you will go to the particular user that you want that multi-factor authentication to be assigned to. All right. So for example, I want it to be assigned to the test user, right? So what I'll do is I'll go to users, I'll go to test, right? And in the security credentials tab, I will have this page which says assigned MFA device. So it says no as of now. So I'll assign it a device. I'll click on edit, and now it'll give me an option between a virtual MFA device and a hardware MFA device. Now I have to choose among the two. So since I said you can create a virtual MFA device very easily, so I'll select the virtual MFA device. And now it is basically asking you to install the application on your phone. So we have already done that. Let's click on next step, and now you'll be presented with the screen. So basically now what you have to do is you will be logging into your Google Authenticator app, and you will be scanning this barcode from your phone. So let me show you how. Let me connect my phone to the computer so that you can see the screen. Give me a second. All right, so this is a screen to my phone, guys. So what I have to do now is I'll have to go to the Google Authenticator app, and it'll ask me to create an account. So I'll click on begin, and once I have that, basically now I'll have to scan the barcode from my mobile. So the way to do that is I'll click on scan a barcode, and then I'll scan this barcode over here. Right, it might take some time, so be patient. Yeah, so it's done. Now you're all set, right? So you'll just click on done, and now you have to enter two codes that you will be receiving on your Google Authenticator. So basically these codes change from every 30 seconds, right? So I have to enter these codes over here. So it's 204 and then 020 and 353. 020-353, and I have to enter the next code as well. So let's wait for the next code, and it's 127891. So I'll enter that over here as well. So it's 127891, and that is it, guys. So now I'll click on activate virtual MFA, and it says the MFA device was successfully associated. So I'll click on finish, and that is it, guys. You're done. Right, so now if I log out from my test account, that is from here, right? This is my test account. So if I log out from here right now, and try to log in again using test, So I'll come to my normal login page, right? So I'll enter my username and my password, which is this. And now I'll click on sign in. So now it'll ask me for the MFA code. So let's see what is our MFA code as of now. So it has changed to 734552. So let us enter that, 734552, and click on submit. So with this, I'll now be able to log in to my AWS console using the test account, which I configured using the administrator account in IAM. All right, so it's very simple, guys. You can actually get world-class security with a click of a button using IAM. All right, so we have seen how we can do multi-factor authentication. Let's move on to the hands-on part now. So this is what you guys have been waiting for. So just give me a second so that I can configure everything on my end. All right, so what we'll be doing now is I have created an application which can interact with the S3 service. All right, so using that S3 service now, we'll be uploading files to our S3 console. And how we are going to do that? First, we are going to do that using localhost, and that is where our secret keys and my access key comes in. And then we have assigned a role to our EC2 instance, right? So we'll be accessing that website using EC2 without the access key and the secret access key, and we'll see, do we get the access to our S3 service or not? All right, so let us do that. So now what I'll do is I will go to my localhost application. So guys, this is basically my application. What I have to do is I'll choose a file, I'll upload a picture from any sample pictures, and then it'll upload it to a particular bucket that I've defined in S3, and the bucket looks something like this, right? So that bucket's name is quarantine demo. So let me show you the bucket. So as of now, I think there are some objects, so let's delete those objects. So here it is. This is the bucket quarantine demo. So I have like 3 objects over here as of now. So let's delete these objects. All right. So now what I'll be doing is this is the code for my application, guys. All right. So in this code, as you can see, I've not specified the key and the secret key as of now. So I'll get the key and the secret key from here, right? So let me show you without the secret key and access key, how is this localhost website functioning. So if I try to upload a file as of now, say this is the file that I want to upload, I'll click on upload image, and I'll get an error, right? Because it is not authenticating itself to the service that I want to go to. So now I'll add the credentials, that is the key and the secret key. Now the way to do that is like this. So I'll copy it and I'll paste it here. I'll delete this and this as well, not required. And now I'll paste my key and my secret key, which is this, right? So I'll copy the key over here, and then my secret key as well over here. And now I'll save it. And if I try to access my localhost website now, I should be able to upload a file, right? So if I try to upload the file now, it says well done, S3 upload complete. So these credentials that I've just entered are basically credentials for my Hemant account. So if you want to see where did I get these credentials from again, you can basically go to users, you can go to your user, and you can go at security credentials, and over here it will list you the access key ID. It will not list you the secret access key because it is only available once. You can only use it once. copy it once, you will not be able to see it again. And if I make this particular key inactive from over here, and if I try to upload anything again, I will again get an error, because without the keys my account will not be authenticated to the S3 service. So as you can see, it says invalid access key because it is not valid anymore. All right, so I can make it active again, but that is not required as of now. So what I'll do now is I've already configured this website on the EC2 console. All right, so let me go to my EC2. Right, here it is. So remember, in the starting of the session, we created a role for S3 full access, right? So that role has been attached to my EC2 instance. So let me show you the website. Here it is. All right, so I can access the website on my EC2. Now, if I choose a file as of now and I try to upload the file, I'll be able to do so because my policy has been attached. Now, let's see what happens if I detach the policy, right? So I'll go to this and I'll select no role, click on apply, yes, detach. And now if I try to upload a file again, as you can see, I see a blank page, which basically means that an error has occurred. All right, so I am not able to upload any file because my role has been detached from my EC2 instance. So if I want it to be working again, I'll just simply go here, go to actions, settings, attach the role, that is this, click on apply, and it will again work. Right, I'll choose a file, say this file, upload the image, and it will work again. Works like a charm, right? So that is it, guys. You don't have to configure much. You just have to have the knowledge of IAM, and with that you can do complex procedures with the click of a button, and you don't have to swear about it. All right, you might be wondering, did I change anything in the code when I uploaded it to EC2? So you don't have to do anything, guys. You just have to delete the credentials, key, and secret, and you will upload the code as it is. You don't have to change anything. If it doesn't have the key mentioned in this particular function, it'll basically get those keys from the metadata of EC2, and metadata is the place where your role is actually assigned, or your role is actually attached, right? So if it doesn't find the key in the code, it basically goes to the metadata and picks the key from over there. Why cloud security is important. So let's take an example here and talk of three very popular companies: LinkedIn, Sony, and iCloud. So LinkedIn in 2012 experienced a cyber attack wherein 6.5 million usernames and passwords were made public by the hackers. After that, Sony experienced the most aggressive cyber attack in history, wherein their highly confidential files like their financials, their upcoming movie projects were made public by the hackers, right? And this made a huge impact on the business front of Sony. iCloud, which is a service from Apple, also experienced a cyber attack wherein personal or private photos of users were made public by the hackers, right? So guys, now in all these three companies, you can see there's a breach in security which needs to be addressed, right? So cloud security has to be addressed. It needs to be there in the cloud computing world. So since now we've established that cloud security is really important, let's move on to understand what cloud security actually is. So what is cloud security? So it is a use of latest technologies and techniques in programming to secure your application which is hosted on the cloud, or the data which is hosted on the cloud, and the infrastructure which is associated with the cloud computing, right? And the other part to this is that whatever security techniques or whatever techniques or technology that you're using to secure your application should be updated as frequently as possible, because every day new threats are coming up, right? Every day there are new workarounds to problems, right? And you should be able to tackle these problems or these workarounds, and hence you should upgrade your security as frequently as possible, right? Moving ahead, let's understand how we can choose between a public, a private, and a hybrid cloud. So we've understood that what cloud security actually is. Now let's talk in terms of security and understand how we can choose between a public, a private, and a hybrid cloud. So if you were to choose between these three infrastructures, what should be our basis of judging which cloud we should choose, right? So you would opt for a private cloud when you have highly confidential files that you want to store on the cloud platform, right? Now there are two stories, or there are two ways of thinking a private infrastructure. You can either opt for private servers or private infrastructure on your own premises, or you can look up for servers, dedicated servers by your cloud provider, right? So that all comes under the private infrastructure. Then we have the public cloud infrastructure. In public cloud infrastructure, you would basically use websites that are public facing. So say if you have a products page where you have application which can be downloaded by the public, so that can be hosted on the public cloud, because there is nothing that has to be secret over there, right? So things like websites, things like data that is not confidential and you don't mind public seeing it, can be hosted on your public cloud. The third infrastructure is the most important infrastructure, which is the hybrid infrastructure, and this is the setup that most companies go for, right? So what if there's a use case wherein you have private files, highly confidential files, and a website as well, right? So if you have this kind of use case, you might go for a hybrid infrastructure, which is kind of best of both worlds. You get the security or the comfort of the private infrastructure and the cost effectiveness of the public cloud as well, right? So your hybrid cloud is basically, if you want your highly confidential be stored on your own premises and your website be hosted on your public cloud, this infrastructure would be hybrid cloud infrastructure. So basically you would choose a private cloud if you have highly confidential files, if you choose a public cloud if you have files that are not that important or files that you don't mind people seeing, and you would choose a hybrid cloud infrastructure if you want best of both worlds, right? So this addresses how we can choose between a public, private, and hybrid cloud. Moving on, let's understand whether cloud security is really a concern. So we have discussed that why cloud security is important. We've discussed what is cloud security, right? Now let's talk about whether this really makes sense, right? So if we say that cloud security is really important and there's no one who's actually thinking about it, there's no point, right? So let's see if companies who are making a move to the cloud actually think about cloud security. So here's a Gartner research on companies who are making a plan to move to the cloud or who has not moved to the cloud yet, right? So what are their concerns? Why are not they doing so? So the topmost reason listed by these companies was security and privacy concerns, right? So as you can see, these companies who want to make a move to the cloud are also worried about their security on the cloud infrastructure. And this makes it clear that cloud security is actually very important, right? Now we've understood that cloud security is really important. We have understood that companies are looking for cloud security, are actually following the practices for cloud security. But now, how secure should you make your application, right? What is the extent to which you should make your application secure? So let us start with this line. So it is said that cloud security is a mixture of art and science, right? Why? Let's see that. So it's a science because obviously you have to come up with new technologies and new techniques to protect your data, to protect your application, right? So it's a science because you have to be prepared with the technical part. But it is art as well. Why? Because you should create your techniques or you should create your technologies in such a way that your user experience is not hindered. Let me give you guys an example. Suppose you make an application, right? And for making it secure, you think, okay, after every 3 or 4 minutes, I'll ask the user for a password, right? From the security point of view, it seems okay, but from the user's point of view, it is actually hindering his user experience, right? So you should have that artist in you that you should understand when to stop or till where should you extend your security techniques. And also you should be creative as to what security techniques can be implemented so that the user experience is not hindered. For example, there is a two-step authentication you get that when you're logging into your Gmail account, right? So if you know your password, that is not enough. You should have an OTP as well to log into your Gmail account, right? So this might be hindering with user experience to some extent, but it is making your application secure as well, right? So you should have a balance between your science and the art part that you're applying on cloud security. Moving on, let's now discuss the process of troubleshooting a threat in the cloud. So let's take an example here. So like you're using Facebook, right? And you get a random message from some person saying there is some kind of story, like you usually get that while you're using Facebook, right? That such and such thing happened and click here to know more, right? You get that similar kind of message here. And by mistake, you actually click on that link. You didn't know that it's a spam and you click on that link. Now what happens is all the users that are there or all your friends on the Facebook chat gets that message, right? And they get furious as to why this kind of spam message is there in their inbox, right? And you get scared. Now you get angry as well and you have to bring your frustration out on Facebook. So you contact Facebook and you get to know that they already know the problem and they're already working on it and they're near to their solution. Now, how did they come to know that there is this kind of problem and needs to be solved, right? So basically cloud security is done in 3 stages. So the identification process or the threat identification process is done in 3 stages. The first stage is monitoring data. So you have AI algorithms which know what a normal system behavior is. And any deviation from this normal system behavior creates an alarm. And this alarm is then monitored by the cloud experts or the cloud security experts sitting over there. And if there's a threat, they see there's a threat, they go to the next step, which is gaining visibility, right? So you should understand what caused that problem, right? And or who caused that problem precisely. So your cloud security experts look for tools which give them the ability to look into the data and find or pinpoint that statement or pinpoint that event which caused this problem, right? So that is done using gaining visibility stage. And once we have established, okay, so this is the problem, then comes stage 3, which is managing access. So what this basically will do is it will give you a list of users. In case we are tracking the who, it will give you a list of users who have access and we will pinpoint the user who did that, right? And that user can be wiped out of the system using the managing access stage, right? So these are the stages which are involved in cloud security. Now, if we were to implement these stages in AWS, how would we do that? Let's see that. So the first stage was monitoring data, right? So if you have an application in AWS and you are experiencing this same kind of thing, what will you do for monitoring data? So you have a service in AWS called AWS CloudWatch. Now what is AWS CloudWatch? So basically it's a cloud monitoring tool. So you can monitor your EC2 and your other AWS resources on CloudWatch. How you can monitor them? You can monitor the network in, network out of your resource, and you can also monitor the traffic which is coming onto your instance, right? You can also create alarms on your CloudWatch. So if there's deviation from normal system behavior, like I said, so it'll create an alarm for you. It'll escalate the event and alert you about that thing so that you can go on and see what that problem actually is, right? So this is cloud, the monitoring tool, right? So this was about AWS CloudWatch. Let me give you a quick demo of how the AWS CloudWatch dashboard actually looks like. Okay guys, so this is your AWS dashboard. So now for accessing CloudWatch, you can go under the management tools. Here is CloudWatch, you'll click on CloudWatch. Now over here you can monitor anything, right? You'll go to metrics and you can see there are 3 metrics over here. You can monitor your EBS, you can monitor your EC2, you can monitor your S3, right? Now say suppose I want to monitor my EC2. So as you can see, so I have 2 instances running in my EC2. One is called for batch instance and the other is called WPS instance, right? Now these are all the metrics which are there. So I can check metrics for my WPS instance for network in, I can check the disk read ops. So let me select the network out metric, and there'll be a graph over here. So I can see this graph, and as you can see, between 6 o'clock and 6:30, I experienced a surge in my traffic, right? So basically this is how you monitor your instance in CloudWatch, and you have all these default metrics to check how your instance is doing in your AWS, right? So this is what CloudWatch is. You can also set alarms here, right? So if you go to alarms, click on create alarm, you'll go to EC2, and you can select your metric from over here. Now I've selected discrete bytes over here. Now once I do that, it'll ask me if there's a time range to which I want to monitor that instance, right? Okay, let's not set any time range. Let's click on next. So when you click next, you will be prompted with this page. So you can set your alarm name, you can set your alarm description here, and then you can specify that for what read write number you should get this alarm for, right? So you'll be setting that over here. After that, you'll go to actions. So once an alarm is triggered, where should that alarm go? Who should that alarm go to, right? So you can set it over here. Now, whenever the state is alarm, right, what should we do? So when the state is alarm, you can send your notification to your SNS topic. Now, what is SNS? So basically, it's a notification service. We'll be discussing what SNS is in the next session. Don't worry if you don't understand. So basically, for now, what you can understand is that SNS is a protocol wherein you set, if you get a notification, what to do with that notification or whom to send to that notification, right? So if there's a topic called notify me in SNS. So in notify me, I have configured an email address that is my email address, that whenever a notification comes to the SNS service, or the notify me topic to be precise, it sends an email to me, right, with that message. So I'll get a message with this alarm that such and such thing that has happened in CloudWatch. Now you do whatever is required. The other thing that you can do over here is, in the same SNS topic, you can also configure a Lambda function to be executed, right? Now what that Lambda function will do, so say suppose I configure the metric to be of CPU usage, right? And I say whenever the 40% metric is crossed, create an alarm, or like go to an alarm state, and it notifies the SNS notify me topic about this. In the notify me topic, I can configure a Lambda function to clear all the background processes in that EC2 instance, right? So if I do that, the CPU usage will automatically come down, right? So this becomes a use case that you want to launch a Lambda function whenever your CPU usage goes beyond 40%, right? And hence, this is the way you would do it. So this was about CloudWatch. There's nothing much to it. You create alarms and you monitor metrics, right? Moving ahead, let's move on to the second process, which is gaining visibility. So for gaining visibility, basically you have to track your whatever activity is happening in your AWS account. So there's a service in AWS called CloudTrail, right? So the CloudTrail service is basically a logging service wherein each and every log to each and every API call is made. Now, how is it useful? Let's talk about the security perspective, right? So your hacker got access to your system. So you should know how he got access to your system. So if you have a time frame, say he got access to your system, or you started to face the problem, say around 4 o'clock, right? So you can set the time between 2 o'clock and whatever the time is right now and monitor what all has been going around. And hence you can identify the place where that hacker got access to your system, right? Now this is the part where you'll get to know who that person actually is, or you can isolate the problem or which caused that. So if you take Q from our Facebook example, over here you can actually pinpoint who is responsible for those spam messages, because you'll all have those logs, right? You'll see the origin of those messages. Now, once you've done that, the next step is managing this guy out of the system, or wiping this guy out of the system. But before that, let me show you guys how CloudTrail actually looks like. So let's go back to our AWS dashboard and go to our CloudTrail service. So again, under the management tools, you have the CloudTrail service. You'll click on the CloudTrail service and you will reach this dashboard. All right, so here you have the logs. So as you can see, you can set the time range here, but I'm not doing that. I'm just showing you the logs. So even for logging into my console, it is showing me that I've logged into my console at this time on this date, right? So every event is logged, guys. Every event that is happening on your AWS console is being logged. So let's talk about the S3 bucket. So somebody deleted a bucket and that has again been logged, right? So it happened at 7:38 p.m. on 28th of March 2017, right? So any activity, any kind of activity which happens in AWS will be logged over here. Okay guys, so this was about CloudTrail. So let's go back to our slide and move ahead in today's session. So like I said, so now you've identified who is responsible for your problem, right? So now the next step is managing access, right? So now you should be able to throw that person or remove that person from the system. So most of the times what happens is, like if you take our Facebook use case, so basically there was a user who triggered that problem, right? So the two things that you have to do is, first of all, you have to remove that spam from your system. So you've got to know where it originated. So now you start wiping it. After that, you have to debar that user from doing it again, right? So from the source, you'll get to know who that user is. Now, using managing access, you will actually get access to do all that, right? So if you talk about AWS, this service is called AWS IAM. So what AWS IAM does is, it basically authenticates that particular service. Now you are a root user, right? So you can do anything. But what if you have employees, and obviously all employees will not have all the rights, right? Now what if you want to give granular permissions to your employees? Now for like in our example, what if one specific employee is capable to track down this problem, right? Or track down what has to be done. So you can give that particular person the rights. How? Using IAM, right? So IAM is used to provide granular permissions. It actually secures your access to the EC2 instances by giving you a private file, and also it is free to use, right? So let's see how IAM is used. So let me go back to my AWS console. Okay guys, so this is my AWS dashboard. I'll go to the security, identity and compliance domain and I'll click on IAM, right? Now over here, I'll click on roles. Now I can see all the roles which are there in my IAM, right? So since I would have identified which role is creating a problem, so I'll go to that role. So for example, I have a problem in say AWS Elastic Beanstalk EC2 role, right? I'll click on this. Now once I click, I will be getting this screen. So now I can see the permissions, the trust relationships, the access advice and the revoke sessions, right? So I'll go to revoke sessions and I'll click on revoke active sessions, and hence I'll be able to wipe out that user from accessing my AWS resources, right? So this is how you use IAM, guys. Now one more thing that you can do over here is you'll go back to your dashboards, go to roles. Now like I told you guys, you can actually create a role for a person who will be able to access restricted things on your AWS account, right? So let me quickly show you how you can do that. So you'll click on create new role and you'll give your role some name. So let's give it hello over here, right? Click on next step, go to role for identity provider access, right? And now you can select how that user of yours will be accessing your AWS account, right? So allow users from Amazon Cognito, Amazon, Facebook, Google ID. All right, so let's select this. Now let us select Facebook and let's give it some random application ID, right? So anyways, not going to create this role. I'm just telling you guys how to do it, right? So basically you get your application ID by Facebook. Over there you'll be, since you are using Facebook to authenticate that guy to your AWS account, you'll get an application ID by going on to graph.facebook.com. You can do all of that over there. Okay, so that is not the concern. You'll enter the application ID and click on next step, right? So you'll get that policy document. So whatever you configured in your text boxes has actually been created in a JSON file, right? So you don't have to edit anything over here. Click on next step. Now you have to attach a policy. Now what is the policy? So policy is basically what all permissions you want to grant that user. right? So if you want to grant him the execution role for Lambda, you can do that. You can grant him the S3 execution role, right? So whatever policy that you create, you can actually create a policy in your IAM, right? I'm not going much in details of this because all of this is covered in your IAM session, but I'm showing you guys because as I just told you guys how this can be done. So let me show you how it can be done, right? So you'll select whatever policy you want and click on next step and review it and create that role. This is it, guys, right? So you can actually select a policy, whatever policy you want that role to have, and hence, so policy is basically a permission that you want that role to have. So if he gets a permission to just review your instances, he'll be only able to review your instances. Okay, one more thing I want to make clear is that you don't have to give your security credentials to that guy anymore, because now you'll be specifying that user will be able to connect to Facebook. Okay, so also you have a part here wherein you can specify what specific user can access it, right? So I can type in my name here, and if I'm being logged in through Facebook, if my username is Hemant Sharma, only then I'll be able to connect to my AWS account, right? Now this is ID, right? So I can also set the locale parameter, right? So ID I think is fine, wherein you will be adding the ID of the guy whom you want this AWS account be accessed by, right? So you all have Facebook IDs, right? So you all have to just punch in your Facebook IDs over here, click on next step, and then you'll be able to access this AWS account if I create this role right now with the policies that I'll be attaching to your role, right? So this is how you use IAM, guys. Let us go back to our session. Okay, so these are the three services, guys. So you have IAM, you have CloudTrail, and you have CloudWatch, using which you can control or you can actually see what is going on in your AWS account.
Are you excited to learn how your application is managed in AWS and the services it provides? Then let us look at the services that manages our application resources known as CloudFormation. We know that AWS has many services, but managing those services manually consumes more time and resources. Instead, AWS helps us by controlling our services and resources through CloudFormation. What is AWS CloudFormation? This is a service provided by AWS that helps you create and manage the resources so that you can spend less time managing those resources and more time focusing on your applications that runs in AWS. You have to create a template that describes all the resources you require, and thus AWS CloudFormation will take care of managing and provisioning all the resources. AWS provides a CloudFormation designer for designing the templates where you can put all the resources. You can also define the dependencies of all the resources that are needed, and you can also reuse your templates to replicate your infrastructure in multiple environment and region. So now let us see how AWS CloudFormation works. What it does is it creates or uses an existing template where user application composer of your text editor to create or modify a CloudFormation templates in JSON or YAML format. You can also choose your provided template where the CloudFormation templates describes the resources you want at the settings. For example, suppose you want to create an EC2 instance. Next, we are going to save the template locally or in an Amazon S3 bucket. If you created a template, then save it with a file extension like .json, .yml or .txt. Next, create a CloudFormation stack by specifying the location of a template file such as the path on your local computer or an Amazon S3 URL. If the template contains parameters, you can specify input values when you create the stack. Parameters allows you to pass in the values to your templates so that you can customize your resources each time you make a stack. You can create stacks by using the CloudFormation console, create stack API operation or create stack AWS CLI command. So this is how the CloudFormation works. So now let us see some of the use cases of CloudFormation. Infrastructure provisioning. So AWS CloudFormation provides infrastructure, which means infrastructure has code. This process can be performed multiple times to get exact replica across all environments. Next, auto-scaling environment. The infrastructure provides using AWS CloudFormation will always be provisioned with scaling environment. which will help you scale up or scale down depending on the incoming load. Integration with services. You can also integrate the AWS CloudFormation with different services like CodePipeline, Jenkins CI or CD pipeline, and so on, which will help automate the deployment. Deployment in multiple regions. You can manage the AWS CloudFormation to deploy it in multiple regions, which will help you in disaster. So now let us see the main components of the CloudFormation. There are two main components such as templates and stack. Templates. An AWS CloudFormation template is a structured text file written in JSON or YAML format that defines the infrastructure and resources that needed to be deployed and manage the application on AWS. It acts as a blueprint for provisioning AWS resources in a replicable and consistent manner using declarative syntax. CloudFormation templates with their efficiency enables automation of infrastructure deployment, allowing users to define dependencies, configurations, and relationship between resources in a scalable and efficient way, making developers more productive. The main object is used to create the templates are AWS template format versions, where this specifies the CloudFormation template versions being used. It is typically at the top of the template and defines the versions of the CloudFormation template languages being used. Description. It provides an optional description of the templates. This helps document the purpose and the details of the CloudFormation stack. Metadata. Optional section that can include additional information about the template. Metadata can be used for documentation purpose or for other tools that process CloudFormation templates. Parameters. It defines input that are passed to the templates when it is deployed. Parameters allows customization of resources, configuration at deployment time. Mapping allows you to define conditional mapping for input parameters to actual values. Mapping are useful when you have different configuration based on various condition or environment. Conditions. It specifies condition that provides you with full control over whether certain resources are created or how they are configured. Condition can be intrinsic, function, and parameters to define the logic, ensuring a secure and controlled deployment. Resources defines the AWS resources that will be created or modified by the CloudFormation stack. Each resource is defined by its type and other attributes. Next is stack. In AWS CloudFormation, a stacks refer to a collection of AWS resources that are created, uploaded, and deleted together as a single unit. A stack is defined by a CloudFormation template which specifies the resources and their configuration. There are many types of stacks. The main types of the stacks are main stack. A main stack is a primary CloudFormation stack created directly from a template. It can include various AWS resources defined within the template and manage their lifecycle. Nested stack. Nested stack are the CloudFormation stack that are referred within another CloudFormation template as resources. They allow you to break down complex applications or infrastructure into smaller, reusable units. Nested stack improves the organization, modularity, and reusability of CloudFormation templates by encapsulation groups of resources that logically belongs together. They can be updated and managed independently while being part of a larger stack. Change set. While not exactly a type of stack, change set are a mechanism in CloudFormation that allows you to preview changes to your AWS infrastructure before implementing them. Change set shows you how proposed changes to a stack and would impact your resources while helping you to understand the scope and impact of updates. They are particularly useful for reviewing potential updates to maintain or nested stack before applying them to ensure they meet your requirements. So now let us see a demo on how we can create a stack in CloudFormation that manages our resources using the template for our applications. So before that, we'll see a sample template which we'll be using to create a stack. As you can see that this is a sample template which we'll be using to create a stack. So basically it contains the AWS template format version and it contains resources where it will be having order tables and other properties of the table such as author name, book titles, etc. It also has a key schema which specifies author name with a key type as hash and book title has a key type of range. And it uses live specification to know the time expiration of the stack when we create and when we want to delete the stack. And we use different policies Here we are using DynamoDB query policies, where we'll be using IAM roles, which specifies IAM roles in the DynamoDB query policy. When we are creating a stack, database that we're creating in a stack will be stored in DynamoDB, and which will help us to know the difference or changes that we made in template to show in the database. So now let us create a stack. So as you can see that I have recently opened the CloudFormation. If you want to open the CloudFormation, you can directly search in search button as CloudFormation. So click on CloudFormation. So as you can see that AWS console opens a AWS CloudFormation services, where there is an option called as create stack. So when we click on create stack, there will be three options to create a stack using three different methods of templates. First, we can choose an existing template that we have already seen before, and we can use a sample template which will be already present in the AWS services, or else we can build a AWS template from the scratch where we can specify our design and all other things. So what I'm going to do here is I'm going to choose an existing template. So I'm directly going to upload a template file from the template that I have been shown you before. So I'm going to choose the file. So this file can be in any format. It can be in JSON, YAML, TXT, text format. So I'm going to click on a file called as temp, where there will be templates. So after getting uploaded, you can get an S3 URL which confirms that there is no error in your templates, and if there are any error, it specifies here. So after that, if you want to know how your application composer looks, you can go through this and you can see the application composer, or else you can directly click on next. After clicking on next, a page appears where you have to specify your stack name so that you can create your stack. So I'm going to specify DynamoDB demo as my stack name. If you want to define the parameters, it is up to you. You can define it, or else you can click on next. So after clicking on next, there are two options here, tags and permission options. In tags, you can specify particular tags for the IAM role to access, or else you can give the tag so that your templates looks well organized enough, or else there are many other options you can use. It is up to you. There is another option called as permission optional. Here you have to specify IAM role if you're IAM user. As you can see that I am a route user, so I doesn't need to specify the IAM role. So these are the advanced options. So make it as default and click on next. So next, there is a page appearing with reviews and create. So you can basically create your templates or provide a stack name or parameter, give a tag name, give certain permission to your tag name and parameters that you're creating if you're creating. Then there are other options like stack policies and all. And when you scroll down, there is an option called as I acknowledge the AWS CloudFormation to create IAM resources. As you can see that before I didn't allow it to create an IAM resource. So it is asking a permission for us to create an IAM resource. So I'll click on that, then click on submit. As you can see that our stack is in progress, it's creating. So it may take some time. So better be patient and keep on refreshing until it shows us it is completely created. So as you can see that the order table query role is still in progress. And you can see that order query table is created completely. And next, they're creating for DynamoDB query policy. So it is still in progress. Please be patient. As you can see that the DynamoDB query policy is also created completely. Next, they are creating order tables. Make sure that you refresh it correct to create the stack completely. So as you can see that the order table is also created and the stack DynamoDB demo is finally created. So now what we are going to do is we are going to DynamoDB service, where we'll be assuming or we'll check whether there is an database created in the DynamoDB. So let me type search DynamoDB. So as you can see it appears, click on that. So when you go to DynamoDB, you can see this as a dashboard. So on the left side, you can see there is an option called as tables. Please click on that. So after clicking on the tables, you can see that our table, authors table is created. A database is created here, where we are giving the reading capacity as 5 and writing capacity as 5. So this is how the stack works. When we create a stack, a database is created in DynamoDB and this is how it looks. So now what we are going to do is we are going again back to CloudFormation. So what I'm going to do here is, as you can see that the creation is completed. So what I'm going to do is I'm going to update here. So before updating, I'm going to make some changes in the templates. So what I'm going to do here is, there is a reading capacity unit of 5. So I'm changing it to 10 and saving this. After saving this, so you have to go to stack actions. There is an option called as create change set for current stack. Click on that to update or create your stack. So again, after that, there will be a 3 option where you can use the existing template. You can use the replace existing template. That means that when there is a changes made in the template, you can replace it with the current template, or you can edit in application composer. So what I'm going to do here is replace the existing template. So I'm going to upload the template that I have changed now. So I'll choose a template. As you can see that the template is uploaded and there is no error. So click on next. So this is the overview to make sure that the change set name is here. And if you want to specify why you're changing for your reference, you can specify it, or else you can leave it blank. Then after that, you can click on repeat. After that, you can click on next. So these are the same settings that we have done when we are going to create that stack, to make sure that there is no any changes while you are changing or updating your stack. Click on next. Same. Again, you have to give and acknowledge that you are allowing the AWS CloudFormation to create IAM resources. Then click on submit. As you can see that the stack is updated completely, and here it shows as modified the order table. You can see the details here of the author table prod. It is modified. It shows the option as modified. Now what we are going to do is we are going to execute the change set. So at the right side of the top corner, there is an option called as execute change set. Click on that. They'll ask for the permission if you want to make any changes in the settings. I'm not going to make any changes. I'll make it as default and execute the change set. So as you can see that there is an option coming here to known as update in progress. So your data set will be updated here, or a template that you have changed will be updated here, and this may take some time. So please be patient and make sure to refresh it. As you can see that the update is completed. So this is what we can do by using update option, where we can change or update in templates and make sure that those updates are there in our stack, and it is useful to create our resources. So if you want to know if that is updated or not, go to DynamoDB, go to tables. So as you can see that the reading capacity mode, it was 5 before. As I have changed or updated in the template, it is also changed here. So this is a difference when we use a stack or update or create a stack. Now we have seen how to create a stack, how to update a stack. Now let's go to CloudFormation again. See, even here also it shows us it is updated completely. So now what I am going to show is, we have seen how to create a stack, how to update a stack. Now the last one is how to delete a stack. This is a very simple option. As you can see that there is an option called as delete option. When you click on it, it will ask your permission whether you want to delete it permanently, because it cannot be undone. So before you delete it, make sure that you have a copy of it. And if the data is not so important, you make sure you delete it, or else you make a copy of it. So I'm going to delete this. So you can see that here it shows as delete in progress. The status is delete in progress. So when I refresh it, it may take some time to delete the stack. So please be patient and refresh again. This may take some time, so please be patient. As you can see that the delete is completed. So when we refresh this stack, so there will be no stack. So there will be an option to create a new stack. So this is how we can create a stack, update a stack, and delete a stack by using CloudFormation. This is mainly to help our applications when we use many services together. It saves our time and resources also.
First, let us try to understand why we need cloud-based monitoring with a couple of scenarios. In our first scenario, Consider that you have hosted a messenger app on cloud, and your app has gained a lot of fame, but lately the number of people using your application has gone down tremendously, and you have no idea what the issue is. Well, it could be due to two reasons. Firstly, since your application has complex multi-tier architecture, monitoring the functionality of every layer by yourself will be a difficult task. Don't you think? And secondly, since you're not using any kind of monitoring tool here, you wouldn't know how your application is performing on cloud. Well, one solution for that is to employ a monitoring tool. This monitoring tool will provide you insights regarding how your application is performing on cloud. And with this data, you can make necessary improvements, and you can also make sure that your application is in par with today's customer needs. And definitely after a while, you'll notice that the number of people using your application has increased. Moving on to our next scenario, let's say your manager has assigned you with a project and he wants you to make this project as cost effective as possible. So as you can see in this project, you're using 5 virtual servers which perform highly complex computations. And all these servers are highly active during daytime. That is, they handle most traffic during daytime. But during nighttime, the servers are idle. By that I mean the CPU utilization of these servers during nighttime is less than 15%. And yet, as you notice here, in both the cases, you are paying same amount of money. You have to notice 2 points here. Firstly, all your virtual servers are underused during nighttime. And secondly, you're paying for the resources which you're not using. And this definitely is not cost effective. So, one solution is to employ a monitoring tool. This monitoring tool will send you notification when these servers are idle, and you could schedule to stop the servers on time. So guys, this is one way to make your project most cost effective and avoid paying unnecessary operating costs. Let's consider another scenario for better understanding. So let's say I have hosted an e-commerce website on cloud, and during sales season, many customers are trying to access my website, which is definitely a good thing. But for some unfortunate reason, application downtime has occurred, and you guys have to remember that I'm not using any kind of monitoring tool here. So it'll be difficult for me to identify the error and troubleshoot it in reasonable amount of time. And it's quite possible that in this period, my customer might have moved on to different website. So you see that I've lost a potential customer here. So if I've had a monitoring tool in the situation, it would have identified the error in earlier stages itself and rectified the problem. Well, I could have easily avoided losing my customer. So I hope guys, with help of these use cases, you were able to understand as to why we need cloud-based monitoring. So let me just summarize what we've learned till now. We need monitoring firstly because it provides a detailed report regarding performance of your applications on cloud. And secondly, it helps us to reduce unnecessary operating costs which we are paying to the cloud provider. Moreover, it detects problems at earlier stage itself so that you can prevent disasters later. And finally, it monitors the user's experience and provides us insights so that we can make improvements. So well guys, in this session, we will be discussing about one such versatile monitoring tool called Amazon CloudWatch. Amazon CloudWatch basically is a powerful monitoring tool which offers you a most reliable, scalable, and a flexible way to monitor your resources or applications which are currently active on cloud. It usually offers you with 2 levels of monitoring, which are basic monitoring and detailed monitoring. If you want your resources to be eligible for basic monitoring, all you have to do is to sign up for AWS free tier. In basic monitoring, your resources are monitored less frequently, like say every 5 minutes, and you're provided with a limited choice of metrics to choose from. Whereas in detailed monitoring, all your resources are monitored more frequently, like say every 5 minutes, and you're provided with a wide range of metrics to choose from. But if you want your resources to be eligible for detailed monitoring, you'll have to pay a certain amount of money according to AWS pricing details. Now, let's have a look at few monitoring services offered by Amazon CloudWatch. Amazon CloudWatch, firstly, it provides a catalog of standard reports which you can use to analyze trends and monitor system performance. And then it monitors, stores, and provides access to system and application log files. Moreover, it enables you to set up high-resolution alarms and send notifications if needed. And Amazon CloudWatch also sends system events from AWS resources to AWS Lambda functions, SNS topics, etc. So if you have not understood any terms which I've used here, don't worry, we'll get to know more about these terms as we progress through the course of this session. Earlier, I mentioned that Amazon CloudWatch allows administrators to monitor multiple resources and applications from single console. These resources include virtual instances hosted in Amazon EC2, databases located in Amazon RDS, data stored in Amazon S3, Elastic load balancers, and many other resources like auto-scaling groups, Amazon CloudTrail, etc. So guys, now let's try to understand Amazon CloudWatch a little deeper. Firstly, we'll have a look at few Amazon CloudWatch concepts, and then I'll explain you how Amazon CloudWatch actually operates. So it's metric. A metric represents a time-ordered set of data points that are published to cloud. So what I mean by that is, suppose let's say you have three variables x, y, and z, and you have created a table which has values of x with respect to y over a period of time. In this scenario, the variable x which you have been monitoring till now is a metric. So you can think of metric as a variable which needs monitoring. Next we have dimensions. Let's consider same variables x, y, and z. Previously you had created a table which has values of x with respect to y. Now let's create another table which has values of x with respect to z. So basically we have two tables which describe same variable x but from two different perspectives. These are nothing but dimensions. So basically a dimension is a name value pair that uniquely identifies a metric. And Amazon CloudWatch allows you to assign up to 10 dimensions to a metric. Then you have statistics. Previously we had created two tables which had values of x with respect to y and as well as z. You can combine data from these tables like to create a chart or maybe plot a graph for analytical purposes. This combination of data is nothing but statistics. Statistics are metric data aggregations over a specific period of time. Then you have alarm. Let's say you have been monitoring this variable x for some time now and you want a notification to be sent to you when the value of x reaches certain threshold. All you have to do is set an alarm to send you notification. So basically, alarm can be used to automatically initiate actions on your behalf. Now that you have clear understanding of concepts of Amazon CloudWatch, let's see how Amazon CloudWatch operates. Amazon CloudWatch has complete visibility into your AWS resources and applications which are currently running on cloud. So firstly, it collects metrics and logs from all these AWS resources and applications. And then by using these metrics, it helps you visualize your applications on CloudWatch dashboard. Moreover, if there is some sort of operational change in AWS environment, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective action, like maybe it sends you a notification or it might activate a Lambda function, etc. And finally, it provides you real-time analysis by using CloudWatch Metric Math. So if you're wondering what CloudWatch Metric Math is, it is a service which integrates multiple CloudWatch metrics and creates a new time series. And you can view this time series on CloudWatch dashboard as well. So working this way, Amazon CloudWatch provides you with system-wide visibility. It even provides you actionable insights so that you can monitor your application performance. Moreover, it allows you to optimize resource utilization if needed. And finally, it provides a unified view of operational health of your AWS environment. So I hope that by now you know what Amazon CloudWatch is. So now let's try to understand how Amazon CloudWatch works with help of a demo. So guys, this is my AWS console. Let's say AWS Management Console. And the services which you can see on the screen are the services offered by Amazon AWS. But in this demo, we're going to use only few services. Let's say CloudWatch, and then you have EC2 and a service called Simple Notification Service. And when I click on EC2, it takes me to EC2 dashboard where you can see that I have 4 instances which are currently active. You know that here in this demo, I'm supposed to get a notification saying that CPU utilization of my instance is less than 25%. For me to receive a notification first, I'll have to create a topic and subscribe to it with my email ID. So let's explore a service called Simple Notification Service, where you can create a topic and subscribe to it. Once you reach SNS dashboard, click on Topics option on the navigation pane and click a Create New Topic. Give your topic a name. Let's say CW topic and give the display name as well. Let's give the same name. and click on create topic option here. You can see that I've successfully created a topic. Now click on the topic which you have created and select actions and subscribe to topic option. Well, I want notification to be sent to me in form of email. You have different options as well in form of Lambda function or JSON, etc. But I'm going to choose it as email and give my email ID, which is here, and then click on create subscription option. So now whenever AWS console wants to send me a message, it will send to the email ID which I used to subscribe the topic. Now let's go back to CloudWatch dashboard. So guys, this is my CloudWatch dashboard and you can see different options on navigation pane. Firstly, I have dashboard where I can view all my metrics at same place. Then you have alarms, which shows the list of alarms which you have configured. And then you have events and logs, which we'll be exploring later. Our topic of interest is the last one, which is metrics. Select the metrics option here and then choose EC2 and then per instant metrics. When you do that, a list of metrics will be shown to you like network out, CPU utilization, network packets in, network packets out, and various other metrics for various resources which are currently active on your cloud. So, but we are interested only with CPU utilization. So I'm going to type that here. Well, it shows the list of instances which are active on my cloud. And I'm going to choose Windows 2 instance and then click on graph metrics option here. Okay, let's select Windows 2 only. And then on the right side, you can see you have a alarm button. When you click on that, a dialog box will be open where you can configure your alarm. Firstly, let's give alarm a name. Let's say low CPU utilization and a brief description as well. Let's say lower than 25%. Lower than 25% CPU utilization. Now I'm going to set the threshold, which is less than 25% in this case. And on the right side, you can see a period option. If your resources are eligible for basic monitoring, this period option by default is 5 minutes. And if your resources are eligible for detailed monitoring, it's usually 1 minute. And when you scroll down, you can see a send notification to option here. So select the topic which you have previously created. That will be C topic in my case, and then click on create alarm. Well, there is some error. Okay, it says there's an alarm already with this name. So let's give it another name of my instance. Now let's try again. And when you click on this alarm button and click on refresh option here, it says that I've successfully created an alarm. Here you can see that low CPU utilization of my instance. And when you click on that, it shows you all the details like description, threshold, and what action it is supposed to take when alarm is configured and all the details. So guys, try it out. It'll be easy for you to understand CloudWatch console much better. Okay guys, now you know what Amazon CloudWatch is, what it does, and the way it operates. But to understand the capability of Amazon CloudWatch completely, we should be aware of two important segments of Amazon CloudWatch, which are CloudWatch events and CloudWatch logs. So let's discuss them one by one. Firstly, we have Amazon CloudWatch events. Consider the scenario. Let's say you've created an auto-scaling group, and this auto-scaling group currently has terminated an instance. So you can see this as some sort of operational change in AWS environment. When this happens, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective actions. Like in this case, it might send you a notification saying that your auto-scaling group has terminated an instance, or it might activate a Lambda function which updates the record in Amazon Route 53 zone. So basically what Amazon CloudWatch events does is it delivers a real-time stream of system events that describe change in your AWS resources. Now let's have a look at few concepts related to CloudWatch events. Firstly, we have event here. An event indicates change in AWS environment, and AWS resources generate events whenever the state changes. Let's say you have terminated an active EC2 instance. So the state of this EC2 instance has changed from active to terminated, and hence an event is generated. Then you have rules. Rules are nothing but constraints. Every incoming event is evaluated to see if it has met the constraint. If so, the event is routed to target. Target is where the events are handled. Target can include Amazon EC2 instances or a Lambda function or an Amazon SNS topic, etc. Now let's try to understand Amazon CloudWatch events better with help of use case. In this use case, we are going to create a system that closely mimics the behavior of dynamic DNS. And for those who don't know what dynamic DNS is, let me give an example. Let's say you want to access internet at home, then internet service provider assigns you an IP address, but since internet service provider uses different kind of online systems, this IP address keeps changing, because of which it might be difficult for you to use this IP address with other services like webcam, security camera, thermostat, etc. So this is where dynamic DNS comes into picture. What dynamic DNS does is it assigns a custom domain name to your home IP address, and this domain name is automatically updated when IP address changes. So basically, dynamic DNS is a service that automatically updates a name server in domain name system. And Amazon offers you with a similar kind of service called Amazon Route 53. So in this use case, we are going to update Amazon Route 53 whenever an Amazon EC2 instance changes its state. Now let's see how the use case actually works. This use case precisely works this way. So whenever an EC2 instance changes its states, Amazon CloudWatch event becomes aware of these operational changes and it triggers a Lambda function. This Lambda function uses different kind of information regarding the instance like its public and private IP address, and it updates a record in appropriate Route 53 hosted zone. So let's say you have an EC2 instance and you have terminated the instance. So Amazon CloudWatch events become aware of this and it triggers a Lambda function. And this Lambda function deletes the record from Amazon Route 53. Similarly, if you have created a new instance, again Amazon CloudWatch events become aware of this and it triggers a Lambda function, and this Lambda function creates a new record in Amazon Route 53. I hope you have understood what Amazon CloudWatch events is and what it does. Now let's discuss how Amazon CloudWatch events works with help of a demo. So in this demo, we will schedule to stop and start EC2 instances with help of Lambda function and CloudWatch events. So let's go ahead with demo. So guys, you can see that I have 4 instances which are currently active. First, I'm going to create a Lambda function which is going to stop my Windows 2 instance. And you guys need to know that for Lambda function to do that, we need to assign permission. So Amazon provides you with a service called IAM, which is Identity and Access Management, where you can assign permissions. When you search for IAM in the tab, it shows you the service. Select that, and on IAM dashboard, on the navigation pane, you can see a policies option here. Select that and click on create policy option. First, it's asking you for a service here, which will be EC2 in our case. Click on EC2 function, then actions, which will be to start and stop my EC2 instances. So let's search for start instance. Well, a predefined function is already there, so you can choose that. Then you have stop instance. Again, select that. And then I want this to be eligible for all the resources, so I'm going to choose all resources here and click on review policy option. Let's give our policy a name, that is to start and stop EC2 instances, and description as well, a brief description, let's say to start and stop instances. And now click on create policies. It's taking a while. So I've successfully created a policy here. Next, we have to assign this policy to Lambda function. So click on roles here, then click on create role, choose Lambda function here and click on next permission. Search for the policy which we have created earlier, that is to start and stop. I found the policy, select that and click on next review option. It's asking for a name. Let's give a name. Start, stop instances and click on create role. I've successfully created a role. So what we have done here is we have assigned permission for Lambda function to control EC2 instances. Now let's create a Lambda function. You can search for Lambda in the search tab and there click on create function. Give your Lambda function a name. Let's say to stop instance and select the role which you have previously created and click on create function. You can see that I've successfully created a Lambda function. And now I'm just going to copy the code to stop EC2 instances here. I'm going to select this and paste it over here and make sure to save it. As you can see here in this function, it asks for instance region and instance ID. So let's configure the details. Let's give it as stop instance. And here you'll have to insert instance region and ID. Instance region and instance ID. Now we'll have to copy the instance region and ID of the instance whichever we need. So let's go to EC2 dashboard here. Now let's say I want my Windows 2 instance to be stopped. This is the instance ID which I'm going to paste it over there. Similarly, instance region now. Well, in this case, I'm choosing Windows 2 instance. You can choose whichever instance you want to stop. Once you're done that, you click on create option here. Test the configuration details. When you scroll down, you can see the execution results here. It says that my instance has been successfully stopped. Let's go and check in the EC2 dashboard. Here on the EC2 dashboard, I'm going to refresh it. And you can see that my Windows 2 instance has successfully stopped. Now we'll create another Lambda function which will restart this function. Again, the same, search for Lambda function in the search tab and click on create function option. It asks for a name, so let's say start instance, and choose the role which you have previously created and click on create function. Again, you'll have to paste the code to start the instances over here and click on save option. Let's try to configure this. Let's name it as start instance. And again, it asks for two attributes which are instance region and ID. Now all we have to do is copy the instance region and ID here like we did earlier. Let's go to EC2 dashboard and copy the instance ID and region. Well, you guys can see that here my Windows 2 instance has been successfully stopped. Now I'll copy this and paste it over there. Similarly, instance region as well. And click on create option. Now test the configuration. And when you scroll down, you can see that my instance has successfully restarted. In the EC2 dashboard, I'm going to refresh this. Well, my Windows 2 instance is on its way to get restarted. Till now, I've used Lambda function to start and stop my instances. But now I'm going to automate this process with help of Amazon CloudWatch. So let's go to CloudWatch dashboard here. Well, it's taking a while to load. Then choose events option and click on create rule. So here we're going to schedule to stop my instances every day at 6:30 p.m. and to restart this instances every day at 6:30 a.m. So click on schedule. If you want to know more about cron expressions, you can visit Amazon documentation. So let me show you. It has 6 fields. Firstly, it's minutes, then you have hours, then day of month, day of week, and year. We're concerned only with minutes and hours because we want our instances to be start and stopped every day, every month. So let's give the details. So if you're going to create a rule to stop the instance, let's say 6:30 in the evening, 30 minutes and 18, which is nothing but 6 p.m. And then rest all, you don't have to mention anything. When you give a proper cron expression, sample timings will be provided to you. You can see here the rest of the sample timings. And now let's add a target function, which is Lambda function in our case, and select on stop instance function and click on configure details. Give your rule a name. Let's say stop my EC2 instance, and description to stop my EC2 instance at 6:30 p.m. every day, and click on create rule here. You can see that I've successfully created a rule to stop my instance every day at 6:30 p.m. Now let's create another rule to restart this instance every day at 6 a.m. in the morning. Again, the same. Choose the schedule here and cron expression, which will be 6 a.m. in the morning. Again, the sample timings are shown here. Then let's add target function, again Lambda function, and select the function that is to start instance and click on configure details. Let's name it as start my EC2 instance and description as to start my EC2 instance every day at 6 a.m. and click on create rule. So now we have successfully created 2 rules to start and stop the EC2 instances at 6:30 p.m. and 6:30 a.m. respectively. So what we have done is we have saved our time here. we've automated the process of stopping and starting EC2 instances. So try it on yourself. It'll be easier for you to understand. So guys, now let's discuss our next topic, which is Amazon CloudWatch logs. Have you guys heard of log files? Well, log files are nothing but detailed record of events that occur when you're using your AWS environment. You can view your log files on your on-premise server as well. Search for an app called Event Viewer. Select the app and click on Windows Logs and select Systems. A list of log files will be shown to you. When you choose a particular log file, all the details regarding that log files will be shown, like the number of keywords, the login time, number of hours the file has been logged onto, and various other details. Similarly, you have log files created when you use AWS environment as well. So you can consider these log files as a data repository. Most of the metrics are generated from these log data. So whenever a metric is generated, a part of data is extracted from this log data. So you're designing metrics according to your like by choosing a part of data from this log data. So basically these log files are what you call a primary data storage place. And Amazon CloudWatch logs is used to monitor, store and access log files from AWS resources like EC2 instances, CloudTrail, Route 53, etc. Let's try to understand CloudWatch logs better with help of some features. Firstly, you can use Amazon CloudWatch logs to monitor your application and system log files. Let's say you have made a lot of errors but trying to deploy your application on cloud. In this scenario, you can use CloudWatch logs to keep track of your errors and send a notification to you when the error rate increases certain threshold so that you can make avoiding errors again. Then you have log retention. By default, logs are kept indefinitely. But CloudWatch provides you with an option where you can set the period between 10 years to 1 day. Then you have log storage. You can use CloudWatch logs to store your log data in highly durable storage. And in case of system errors, you can access raw log data from this storage space. And then you have DNS queries. You can use CloudWatch logs to log information about the DNS queries that Route 53 receives. Now let's have a look at a few concepts regarding CloudWatch logs. Firstly, we have something called log event. So log event is just a record of activity that has occurred in AWS environment. It's straightforward. Then you have log stream. A log stream is a sequence of log events that have same source. Then you have something called log group. Log group defines group of log streams that has same monitoring and access control settings. By default, you have to make sure that each log stream belongs to one or the other log group. Guys, now let's try to understand CloudWatch logs better with help of this use case. In this use case, we are going to use Amazon CloudWatch logs to troubleshoot the system errors. You can see that I have 3 instances here and a CloudWatch agent which is monitoring all these 3 instances. So what CloudWatch agent does is it collects custom level metrics from all these EC2 instances, and then all these metrics and logs collected by the agent are processed and stored in this Amazon CloudWatch logs. Amazon CloudWatch logs then continuously monitors these metrics, as you can see here. By then, you can set an alarm which will send you notification when some sort of error occurs in the system. So whenever you receive a notification saying that some sort of error is there in your system, you can access the original log data which is stored in CloudWatch logs to find the error. So this is how you can use Amazon CloudWatch logs to troubleshoot the system errors. So basically you are having a look at original data so you can solve your problems faster and quicker.
In this video, I'll demonstrate how to use AWS Lambda and API Gateway to create a REST API, showing how Lambda functions are triggered by incoming requests and also display results directly in the browser. Now let's take the example of Netflix, which is one of the world's leading entertainment services with over 260 million members in more than 190 countries and is transforming its infrastructure with AWS Lambda. Netflix is no stranger to complexity. Each quarter, they deliver billions of hours of videos to millions of customers worldwide. Supporting this demand requires a powerful, agile infrastructure, and Netflix as an AWS customer relies on AWS Cloud Power to keep up. With Neil Hunt, Netflix's Chief Product Officer, leading the way, Netflix plans to use AWS Lambda to create rule-based, self-managing infrastructure to replace outdated, inefficient processes, reduce errors, and free up time. By integrating Lambda, they have set their sights on automating tasks that are once required hands-on management. With Lambda, Netflix now has the potential to improve efficiency, reduce costs, and also deliver a more seamless experience. Here's how Lambda has already helped solve some major challenges. First we have is encoding media file. Netflix receives huge volume of media files from studios. With Lambda, every new file triggers rules that break down, encode, and reassemble content for streaming. This automation speeds up the encoding process, reducing wait times and manual effort. Next we have is backup for disaster recovery. Previously, data backups were time-intensive. Now, Lambda can trigger backups whenever new data is saved, ensuring all data is backed up automatically and securely, and rerunning failed backups when needed. Similarly, two more problems: security and conformity, and then dashboards and monitors. By building this rule-based, self-managing infrastructure with AWS Lambda, Netflix is turning its vision of a fully automated and efficient system into reality, serving millions of members with a smarter, faster, and more secure service. But how? You only have to spend running the code once. So, there is no wasted resources and no need to worry about under or over provisioning servers. Pretty cool, right? AWS Lambda really helps businesses like Netflix, Flipkart, which handle high volume tasks without the stress of managing all the infrastructure. Now let's understand what exactly means by AWS Lambda. AWS Lambda is a serverless computing service provided by Amazon Web Services that allows you to run code without provisioning or even managing servers. Alright, let's dive into a demo where I'll show you how to use Lambda function and API Gateway to create a REST API. We'll also see how it triggers the Lambda function and how it all works together. Let's get started. Now as you can see this AWS platform, let's start with the first step. Now let's create a Lambda function. This function will act as our API backend. Now let's go to AWS Lambda service and click on Create Function and name it as New API Lambda. We have the runtime as Node.js. Now let's change the runtime to Python. Let's click on Create Function. For this demo, I'll keep it simple with a basic message response. But in a real-world setup, this function could hold any backend logic for your application. Add the desired functionality for your API in the Lambda function code. For this demo, add code to simply return the message here. By default, we have hello from Lambda. Now let's type into hello from Edureka as well. Moving forward, now click on Deploy. So here you can see the deployment is successful. Moving forward, we have to create a REST API in API Gateway. For that, let's go to API Gateway service in AWS and select REST API. Now, choose New API, name it as My First API and set the endpoint type to regional and click on Create API. Now we will create a method for the API. Select the /resource in the API Gateway and click on Create Method. Then choose Get as HTTP method. For the integration type, select Lambda function. Choose the Lambda function created in the previous step, that is, New API Lambda. Click on the Create method. Confirm any prompts to grant API Gateway permission to invoke the Lambda function. Here you can see that the API is successfully created by the Get method. Now let's configure the integration and test the setup. If you see here, this is how the API works. First we have the client. The client sends a request to the API. So in method request, the API checks the request like permissions and then an integration request. The request is forwarded to the Lambda function and then comes the Lambda integration. Lambda processes the request and returns a result. Next in the integration response. The Lambda output is formatted for the API. And in the method response, the API prepares the response for the client. At the last in, we have the client. The final response is sent back to the client. This is how the flow works from the client to the Lambda and back. So, we can also test this API. For that, let's deploy the API. In API Gateway, go to Actions, Deploy API, create a new stage. Let's put the stage name as Dev and click Deploy. Now the API is deployed. Now let's invoke the API. Copy the invoke URL from the deployed stage. Paste the URL in a browser like Chrome or a tool like Postman to test the GET request. Here you can see the response as status code 200 along with hello from Edureka. So this is a short demo using the AWS Lambda function and API Gateway to create a REST API.
What is Elastic Beanstalk? If I have to define Elastic Beanstalk in Amazon terminology, then it is a platform as a service where you can deploy your application which you might have developed with programming languages like Java, .NET, PHP, Node.js and many others on familiar servers such as Apache, Nginx, Passenger and Tomcat. The definition which I just mentioned seems to have a lot of technical terms, isn't it? Well, let's try to figure out what Elastic Beanstalk is in simple terms. Alright, let's say you need to build a computer tonight. Well, you have two ways to go at it. First, you can go to a computer warehouse. Computer warehouse is a place where you have different components of computer laid out in front of you. Like you have CPU, motherboards, router, disk drive, modems, and many other components. You can choose whichever component you need and assemble them and form a brand new computer. This is similar to a situation when you try to deploy an application without using Elastic Beanstalk. When you try to develop an application by yourself, you'll have a list of tasks which you need to do. Like you might have to decide on how powerful you want your EC2 instance to be. Then you have to choose a suitable storage and infrastructure stack for your application. You might have to install separate softwares for monitoring and security purposes as well. Moving on to option B, you can always visit an electronic retail store which has pre-configured computers laid out in front of you. Let's say you're a graphic designer and you want a computer which has a modern graphical user interface installed in it. All you have to do is specify this requirement to a salesperson and walk out with a computer of your choice. Well, I personally prefer this option. This is similar to the situation where you're trying to deploy an application using Elastic Beanstalk. When you use Elastic Beanstalk to develop your application, all you have to do is concentrate on your code. Rest of the tasks like installing EC2 instances, auto-scaling groups, maintaining security and monitoring, etc. is done by Elastic Beanstalk. That is the beauty of Elastic Beanstalk. So let's go back and take a look at definition again and see if we'll understand it this time. Well, Elastic Beanstalk is a platform as a service where developers just have to upload their application. Load balancing, auto-scaling, and application health monitoring are all handled automatically by Elastic Beanstalk. Now let's try to understand how Elastic Beanstalk as a platform as a service is beneficial to an app developer. I'm sure most of you know what platform as a service is, but let's try to refresh what we know. Platform as a service is a cloud computing service which provides you a platform where you can deploy and host your application. Elastic Beanstalk makes the process of app development much more fun and less complex, and I have 5 points to prove that to you. Firstly, it offers quicker deployment. Suppose you're developing an app by yourself, then you'll have to do a lot of tasks by yourself. Like you might have to decide on EC2 instance, choose a suitable storage and infrastructure stock, as well as install auto-scaling groups as well, and then you might have to install separate softwares for monitoring and security purposes. Well, this will take quite a lot of time. But if you have used platform as a service to develop your app, then all you have to do is develop a proper code for your application. Rest will be handled by platform as a service or Elastic Beanstalk in this case, which makes the entire process of app development much more faster. Secondly, Elastic Beanstalk simplifies entire app development process. Like I said, all developers have to do is concentrate on developing a code for their application. Rest, like monitoring servers, storage, network, etc., and managing virtualization, operating system databases is done by Elastic Beanstalk, which simplifies the entire process for a developer. Using platform as a service to deploy application makes entire app development process more cost effective. If you're trying to deploy an app by yourself, then you might have to install separate softwares for monitoring and security purposes, And I'm sure for that you'll have to pay a lot of money, extra money. But if you're using an Elastic Beanstalk to deploy your application, it will provide you all this additional software as a package, and you can avoid paying unnecessary operating costs. Also, Elastic Beanstalk offers multi-tenant architecture. By that I mean it makes it easy for the users to share their application on different devices, and that too with high security. When I say high security, Platform as a Service will provide you a detailed report regarding your application usage, different people or users who are trying to access your application as well. With this information, you can be sure that your application is not under any cyber threat. And finally, Platform as a Service provides you an option where you can know if the user who is using your application is getting a better experience out of it or not. With Platform as a Service, you can collect feedback at different stages of your app development, like during development stage, like testing stage, production stage, design stage. By doing so, you'll have a report regarding how your application is performing at every level, and you can make improvements if needed. So this is how Platform as a Service like AR and Elastic Beanstalk makes it easy for developer to develop an all-around perfect app. Guys will be able to relate to this point when we try to deploy an application using Elastic Beanstalk in the later part of this session. You will understand how Elastic Beanstalk is beneficial to an app developer. In market, there are quite a lot of application hosting platforms which are providing Platform as a Service. Let's have a look at few of them. First, we have something called OpenShift. It is a web hosting platform offered by Red Hat. Then you have Google App Engine, which we all know. A Scalingo, it is a platform as a service where you can deploy your application in just 2 minutes. Apparently, it will provide you a production-ready environment where all you have to do is deploy your application code. Then you have Python Anywhere. It is an online integrated development platform and web hosting service as well, but based on Python language. Then you have Elastic Beanstalk offered by Amazon. Moving on, we have Azure App Services by Microsoft and many others. But today, our main focus will be on Elastic Beanstalk, which is a web hosting platform offered by Amazon. Now that you have basic understanding of Elastic Beanstalk, let's go ahead and take a look at few of its features. Mostly, all these features are similar to the ones which we discussed earlier. Like Elastic Beanstalk makes an app development process more faster and simpler for developer. Moreover, all developer has to do is concentrate on developing code. Rest of the configuration details and managing and monitoring details will be handled by Elastic Beanstalk. Also, Elastic Beanstalk automatically scales up your AWS resources which have been assigned to your application by Elastic Beanstalk based on your application specific needs. But there is one feature which is specific to Elastic Beanstalk. Suppose you have deployed an application using Elastic Beanstalk, but now you want to make changes to the configurations which have been already assigned to your application by Elastic Beanstalk. Though Beanstalk is a platform as a service, it provides you with an option where you can change the pre-assigned configurations like you do in infrastructure as a service. Well, if you remember, if you're trying to use infrastructure as a service to deploy your application, you will have full control over AWS resources. Similarly, Beanstalk also provides you with full control over your AWS resources, and you can have access to the underlying resources at any time. Let's try to understand Elastic Beanstalk a little deeper. First, we'll be discussing a few components of Elastic Beanstalk, then we'll have a look at its architecture. Let's see what we have here first. We have something called application. Suppose you have decided to do a project. So what you do, you go ahead and create a separate folder on your personal computer which is dedicated to your project. Let's say your project needs Apache server, SQL database, and a platforming software like Eclipse. So you install all the softwares and store them in the folder which is dedicated to your project. So that will be easy for you to access whenever you need all the softwares. Similarly, when you try to deploy an application on Elastic Beanstalk, Beanstalk will create a separate folder which is dedicated to your application. And in AWS terms, this folder is what we call an application. If I have to define folder or application in technical terms, then it is a collection of different components like environments, your application versions, and environment configuration. Let's try to understand each of these components one by one. We have something called application version. Suppose you have written a code, stored it in a file, and deployed this code on Elastic Beanstalk, and your application has been successfully launched. But now you want to make certain changes to the code. So what you do? You go ahead, open the file, make changes to it, save it, and then again deploy it on Elastic Beanstalk. Elastic Beanstalk again successfully launches your application. So you have two versions of your application now. It's just a copy of your application code but with different changes. And Elastic Beanstalk will provide you with an option where you can upload different versions of your application without even deleting the previous ones. Then we have something called environment. Environment is a place where you actually run your application. When you try to launch an Elastic Beanstalk environment, Beanstalk starts assigning various AWS resources like EC2 instances, auto-scaling groups, load balancer, security groups to your application. The point which you have to remember is, at a single point of time, environment can run only a single version of your application. But Elastic Beanstalk will provide you with an option where you can create multiple environments for your single application. Suppose I want a different environment for different stages of my app. Like I want an environment for development stage, one for production stage, and one for testing stage. I can go ahead and do that, create a different environment for different stages of my application. And suppose you have same version or different version of your application installed on all these environments, it's possible to run all these application versions at same time. I hope that was clear. Well, you'll understand them practically when we try to deploy an application in the later part of the session. Then we have something called environment tier. When you try to launch an Elastic Beanstalk environment, Elastic Beanstalk asks you to choose among two environment tiers, which are web server environment and then you have worker environment. If you want your application to handle HTTP requests, then you choose web server environment. And if you want your application to handle background tasks, that is where a worker environment comes into picture. I'll show which to choose, either web server or worker environment, and how to work with them when we'll try to deploy an application in the later part. And lastly, we have something called environment health. Based on how your application is running, Beanstalk reports the health of your web server environment, and it uses different colors to do so. First, gray indicates that your environment is currently being updated. Let's say you have installed one version and now you're trying to upload different version, but it's taking a lot of time. So that time it shows gray color. It means your environment is still under updating process. Then you have green, which means that your environment has passed the recent health check. Then you have yellow, which means that your environment has failed one or more checks, and red failed 3 or more checks. Moving on, let's try to understand the architecture of Elastic Beanstalk. Like I said earlier, when you try to launch an Elastic Beanstalk environment, Beanstalk asks you to choose among two different environment tiers. Firstly, we have web server environment. Web server environment usually handles HTTP requests from clients, and it has different components. Firstly, we have something called environment. You know what environment is? It's a place where we actually run your application, and Beanstalk provides you with an option where you can create multiple environments. And the main point is, at a point of time, this particular environment can run only one version of your application. Moving on, we have something called Elastic Load Balancer. Let's say your application is receiving a lot of requests. So what Elastic Load Balancer does is, it distributes all this request among different EC2 instances so that all the requests are handled and no request is being denied. What actually happens is, when you launch an environment, a URL is created, and this URL in the form of CNAME is made to point Elastic Load Balancer. CNAME is nothing but an alternate name for your URL. So when your application receives request, all these requests are forwarded to Elastic Load Balancer, and this load balancer distributes these requests among EC2 instances of auto-scaling group. Then we have auto-scaling group. Well, if your web server is trying to handle a lot of traffic and it's having a scarcity of EC2 instances, then auto-scaling group automatically installs few EC2 instances. Similarly, if traffic is very low, then it automatically terminates underused EC2 instances. Then we have EC2 instance. So whenever you try to launch an Elastic Beanstalk environment, Beanstalk will assign your application with a suitable EC2 instance. But the software stack, like the operating system, the servers, and different softwares which are supposed to be installed on your instance are decided by a device called container type. For example, let's say my environment has an Apache Tomcat container. So what it does, it installs Amazon Linux operating system, Apache web server, and Tomcat software on my EC2 instance. Similarly, depending on your application requirements, it installs different software stack on your EC2 instances. Then we have a software component called Host Manager, which runs on every EC2 instance that has been assigned to your application. This Host Manager is responsible for various tasks. Firstly, it will provide you a detailed report regarding performance of your application. Then it provides instant level events. It monitors your application log files as well, and it monitors your application server. You can view all these metrics, log files, and create various alarms on CloudWatch monitoring dashboard. Then you have security groups. Security group is like a firewall to your instance. Not anybody can access your instance. It's just for the security purposes. So Elastic Beanstalk has a default security group which allows client to access your application using port 80. You can define more security groups if you need. And then Elastic Beanstalk also provides you with an option where you can define a security group for your database for security purposes. Moving on, we have something called worker environment. First question that comes to our mind is, what is worker? Well, suppose your web server has received a request from client, but on the way, while it's trying to process the request, it has come across tasks which are consuming a lot of resources and taking a lot of time, because of which it's quite possible that your web server might deny other requests. So what it does, it forwards these requests to something called worker. This worker handles all these tasks on behalf of web server. So basically, worker is a process that handles background tasks which are time intensive and resource intensive. And in addition, if you want, you can use worker to send email notifications, to generate metric reports, and clean up databases when needed. Let's try to understand why we need worker with the help of use case. So I have a client. He has made a request to web server, and the web server has accepted the request, and it starts processing the request. But while it's processing the request, it comes across tasks which are taking a lot of time. Meanwhile, this client has requested or sent another request to web server. Since web server is still processing the first request, it denies second request. So what is the result of this is, the performance and the number of requests accepted by your web server will drastically decrease. Alternatively, let's say a client has made a request and your web server has accepted it and it starts processing the request. And again, it comes across tasks which are taking a lot of time. This time what it does, it transfers or it passes all these tasks to worker environment. And this worker environment will handle all these tasks. And request 1 is successfully completed. Meanwhile, if it receives a second request, since it has completed processing request 1, it will accept request 2. I hope the scenario was clear. Well, all we are doing by installing worker environment is we are avoiding spending a lot of time on single request here. Now you know what web server environment is and worker environment is, and why do we need worker environment. But there has to be some way so that this web server environment can pass on this task to worker environment. Let's see how. So you have your web server environment. It has received a request, and while processing, it has encountered tasks which are taking a lot of time. So what it does, it creates an SQS message. SQS is a simple queue service offered by Amazon. And this message is then put into SQS queue. And the different requests are arranged based on priority in the SQS queue. Meanwhile, when you're trying to install worker environment, Elastic Beanstalk installs something called daemon. What this daemon does, it pulls SQS message from SQS queue. And then it sends this task to web application which is running on worker environment. As a result or as a response, this Beanstalk application handles all this tasks and responds with an HTTP response option. So this is how the entire process of handling tasks, transferring and then handling tasks goes on. So you have a client. He has made a request to web server, but the web server is encountered with tasks which are time consuming and resource consuming. So it passes this request to SQS queue. And when you try to install worker environment, there's a daemon which pulls out all these messages or tasks from your SQS queue. And then this daemon sends all these tasks to your application. Application resolves all these tasks and then it responds with a HTTP response option. So this is how your two applications communicate. I think that was a lot of theory. Don't worry, we have arrived at the fun part of session where we'll be trying to deploy an application using Elastic Beanstalk. Here, by creating an application on Elastic Beanstalk practically, you'll understand different concepts, its architecture, and different environment ties and all this. So let's go ahead. So this is my AWS management console. And if you want to take a look at all the services, then you have all the services here. But we're mainly concerned with Elastic Beanstalk, which I've recently used. So it shows the all recently used resources or services here. So I'm going to choose that Elastic Beanstalk. And this is my Beanstalk console. If you're trying to deploy an application for first time, this is the page where you land. When we scroll down, it says that I can deploy an application in 3 easy steps. All you have to do is select a platform of my choice. then upload a application code if I have one, or use a sample application code and then run it. Let's see if it's as easy as it says here. So go ahead and click on create new application option here. It'll ask you for application name and description. I'm going to name my application as Tomcat app, then description as my new web app. And then I'm going to click on this create option. See, when I try to create an application, it has created a separate folder which is dedicated to my application. And in that folder, we have different components. As you can see here, I have my environment, then I have application versions. And if I've saved any configuration, it will show all the saved configurations here. Now let's go ahead and create an environment. On the right side, you see an actions option, and you click on that, you get different choices. You can just select create environment here. So again, it's asking you to choose among two different web environment tiers. You have web server environment and worker environment. In web server environment, your application handles HTTP requests from clients. Then you have worker environment, where your application will process background tasks like time intensive and resource consuming tasks. In this demo, I'm going to work only with web server environment. You can go ahead, explore and create worker environment once you understand how to deploy an application on Elastic Beanstalk. So I'm going to click on the select option here. It will take me to a page where I'll have to give a domain name, or in technical terms, a URL to my application. You can give any URL of your choice and see if it's available. So let's say my Tom app, and let's see if it's available. It says the domain name is available. Then description, I'm going to give it the same as before. So my new web app. Then when I scroll down, it asks me for a platform of my choice. There are different options. You have Go, then you have .NET, Java, Ruby, PHP, Node.js, Python, Tomcat. And if you're trying to deploy an application on the platform which is not here, you can configure your own platform and deploy it on Elastic Beanstalk. It provides you an option. Here you can see there's a custom platform here. So I'm going to choose Tomcat platform for my application. And since I'm not any kind of developer, I'm just going to go ahead and use the sample application provided by Amazon. But if you have any application code, if you have created or developed some code, you can store that in a file and upload here. It says you can upload your code. Then you have a zip. You need to convert your file to zip or WAR file and then upload it here. So I'm going to just select sample application and then click on create environment here. So it's going to take a while for Elastic Beanstalk to launch my environment. Though it's not as much time as it would have taken me to develop entire application by myself. While Elastic Beanstalk is trying to launch environment, let's discuss some points. In the earlier part of the session, we discussed some benefits of Elastic Beanstalk. Firstly, I said that it fastens your process of developing an entire app. So it's true, doesn't it? All I did was select the platform of my choice. Rest is done by Elastic Beanstalk itself. So thereby it's saving a lot of time. Similarly, it simplifies the process of app development. Again, all I did was select a platform of my choice, like installing EC2 instances, security groups, auto-scaling groups, and assigning IP addresses. Rest is done by Elastic Beanstalk. I even mentioned a point where I said that Elastic Beanstalk provides you with an option where you can change the pre-assigned configuration. We'll explore that once the environment is created. Let's go ahead and see what Elastic Beanstalk is doing. It says that it has created a storage for my environment where S3 bucket, so that all my files where I have my application code are stored there. Then it has created a security group as well, an Elastic IP address. Then it says it's launching an EC2 instance. So you see, it's as easy as that. All you have to do is select a platform of your choice. Rest is handled by Elastic Beanstalk. And later on, if you're not satisfied, if you want to change some configuration, you can go ahead and do that. Here, look at this. This is the IP address or domain name which I assigned to my app. It says new instance has been added. And in addition, it's showing each task while it's doing. Isn't that cool? You'll know what your environment is currently doing. So it's still taking a while. So it says it has installed and added instance to my application, and my environment has been successfully launched. It has finished almost all the tasks. It should have taken to environment page now. So this is my environment page, or you can say a dashboard. First, you have environment health here. It says green. It means that my environment has successfully passed the health check. Then it shows the sample version of your application. Since I've used the sample application, it's saying sample application here. Since I've chosen Tomcat as my platform, it has installed suitable infrastructure stack like Amazon Linux, and you have Java 8 programming language. Let's go ahead and explore this page. First, we have something called configurations here. Like I said, though it is a platform as a service, it provides you with an option where you can change configuration. So you will have full control of your resources. First, we have something called instances here. When I click on modify option, you can see that Elastic Beanstalk has assigned micro instance to my application. If I want, I can go ahead and change it to different instance based on my application requirement. Scrolling down, I have CloudWatch monitoring. If I want detailed monitoring, then I can go for 1 minute. If I want basic monitoring and not so detailed monitoring, then I can choose 5 minutes here. Then I have an option of assigning storage to my application as well. It says we have magnetic storage, general purpose, and provisioned IOPS as well. When we scroll down again, we see different security groups. I can just click on that and the security group will be added to my application. So once you've made the changes, you can click on apply option here. Though I haven't made any changes, I'm just going to click here. So now Elastic Beanstalk is trying to update my environment. So it's showing gray color here. If you recollect, I mentioned during the earlier part that gray indicates my environment is being updated. Okay, let's go back to configurations. We did have a look at instances. Then you have something called capacity. Apparently, Elastic Beanstalk has assigned a single instance to my application. If I want, I can go ahead and change to auto-scaling groups. You have an option called load balancer. You can click on that here. And you can set the minimum and maximum number of instances that your auto-scaling group can install as well. Then if you have chosen a load balancer option earlier, then a load balancer would have been enabled here. Then we have monitoring details, which provides you with two options, enhanced monitoring and basic monitoring. And when we scroll down, you can see a streaming to CloudWatch logs option here. So if you want your log files, you can view them on CloudWatch dashboard as well. You can set the retention period according to your choice. And suppose you want your application for some private purpose, then you can generate a private VPC for your application. Similarly, you can add or decrease the amount of storage as well. So by explaining all this, what I want to say is your hands are not tied. You can make changes to configurations if you want. Then we have logs option. If you want to have a look at the last 10 lines of your log files, then you have an option. It says last 100 lines. Then if you want full log files, then you click on that. It will provide you a file in download format. You can just download it. Then we have health option here, where it provides the health of your AWS resources. Basically, it shows EC2 instance here. It says it's been 7 minutes or 6 minutes since my EC2 instance has been installed. Then you have monitoring, where it shows different monitoring details like CPU utilization, network in, network out. If you want, you can go ahead and create an alarm with alarm option here. Suppose you want a notification to be sent to you when the CPU utilization or when the number of EC2 instances are scarce in your auto-scaling group. Then you have events here. Events basically are nothing but it's a list of things which has happened since you started launching an environment. When I go down, it says, we have seen earlier on the black screen, the same things are replied here. So it says create environment is starting. Then we saw that EC2 instance has been installed, security groups, Elastic IP address. So basically it shows all the events that has happened from the time Elastic Beanstalk has started to launch your environment until the time you terminated the environment. So that's it. Then you have tag files. You can assign different key values as well. Let's go back. This is a sample application which I've tried to use. Now let me try to upload and deploy a new application version here. Okay, I'm going to go to documentation here. I'm interested with Elastic Beanstalk. I'm going to select on that and then developer guide. Click on getting started here. When you scroll down and deploy a new application version here, based on your sample application, you have different versions of your application. Since I've selected a Tomcat as my platform, I have a Tomcat zip file here. I have already downloaded that. So I'm just going to upload the file there. So let's go back and it says upload and deploy. But let's go back to our folder. Then there's an application versions option here. So it gives you deploy and upload options separately here. I'm just going to upload first, then we'll deploy it. Version label, new version, and upload the file. I have it here, zip file. I'm just going to attach the file and then click on upload option. The new version of my application has been uploaded, but it's not been deployed yet. So when I go back here, you can see that I can still see the same version which was there before. Now let's go back and deploy it. Okay, I'm going to select this and then I'm going to click on deploy option and select deploy here. Let's go back to environment and check. So my environment is being updated. So again, the gray color here. Once it's updated, it will show the new version name here. It is uploaded. So as you can see, it's showing the version name of my new version, application version. Like I said earlier, both my application versions are there. I haven't deleted any. You don't have to delete your application versions when you create a new one. Similarly, you can upload multiple versions of your application. Going back, actions option. Then you have load configuration, which will definitely load your configuration. Then you have save. You can save this configuration. Suppose you want to create an application with same configurations. Again, you don't have to start from the beginning, from creating application, environment, all that. You can just save the configuration and use for the other application or other environment of your application. Then you can clone your environment as well, rebuild the entire environment and terminate as well. So here I have saved configuration. If I have saved this configuration, the configuration will have been listed here, and like that configuration I can use when I'm creating a new environment. Okay, just let's see if I've explored all the options. Environment. Well, I forgot to show you one most important thing. When I click on this URL, it takes me to a page where it shows that my application has been successfully installed. Well, that's it. So now you know how to deploy an application using Elastic Beanstalk. Though I have used the sample application here, you can go ahead and upload a code of yours if you have any and try it out. Well, all the options here seems to be user friendly, so you will know what to do. It seems to be easier process. You will understand it better when you try to deploy an application by yourself. I'm sure you know what a data warehouse is. You can think of data warehouse as a repository where data generated from your organization's operational systems and many other external sources is collected, transformed, and then stored. You can host this data warehouse on your organization's mainframe server or on cloud. But these days, companies are increasingly moving towards cloud-based data warehouses instead of traditional on-premise systems. And to know why, we need to understand the underlying architecture and the disadvantages of using traditional data warehouses. So let's begin by looking at architecture part. It is important to understand where the data comes from. Traditionally, data sources are divided into two groups. First, we have internal data, that is, the data which is being generated and consolidated from different departments within your organization. And then we have external data, that is the data which is not getting generated in your organization. In other words, that is the data which is coming from external sources. So this traditional data warehouse follows a simple three-tier architecture. To begin with, we have bottom tier. In bottom tier, we have a warehouse database server, or you can say a relational database system. In this tier, using different kind of backend tools and utilities, we extract data from different sources and then cleanse the data and transform it before loading it into data warehouse. And then comes the middle tier. In middle tier, we have OLAP server. OLAP is an acronym for Online Analytical Processing. This OLAP performs multidimensional analysis of business data and transforms the data into a format such that we can perform complex calculations, trend analysis, and data modeling on this data very comfortably. Finally, we have top tier. This top tier is like a front-end client layer. This tier holds different kind of query and reporting tools using which the client applications can perform data analysis, query reporting, and data mining. So to summarize what we have learned till now, traditional data warehouse as a simple three-tier architecture. In the bottom tier, we have backend tools using which we collect and cleanse the data. And then in middle tier, we have tools, which is OLAP server, using which we transform the data into the way we want. And then finally, top tier, in which using different query and reporting tools, we can perform data analysis and data mining. Moving on to the disadvantages of traditional data warehouse concept, there is this leading US business service company, and this company is running a commercial enterprise data warehouse. This data warehouse has data coming from different sources across different regions. The first problem that this company faced was when it was setting up a traditional data warehouse. As we discussed earlier, the architecture of traditional data warehouse is not very simple. It consists of data models, extract, transform, and load processes, which we call ETL, and you have BI tools sitting on top. So this US-based company had to spend a lot of money and resources to set up a traditional data warehouse. Data warehouse, which was initially 5 terabytes, was growing over 20% year over year, and it was expected that there might be higher growth in future. So to meet this continuously increasing storage and compute needs, the company had to continuously keep upgrading the hardware. Again, this task of upgrading the hardware continuously involves a lot of money, manpower, and too many resources. So, autoscaling in traditional data warehouse is not an easy concept. And since the company could not meet all the storage and compute needs easily, it was facing a lot of performance issues as well. And finally, the company had to deal with increasing costs. Initially, they had to spend a lot on setting up data warehouse, like that to spend on hardware, manpower, electricity, security, real estate, and deployment costs, and many other. And as their data warehouse grew, they had to spend again to meet storage and compute needs. So to sum it up, setting up a data warehouse and deploying it and managing it later involves a lot of money and resources. Moreover, auto-scaling in traditional data warehouse is not an easy concept. Because of all these reasons, many companies are increasingly moving towards cloud-based warehouses instead of traditional on-premise systems. So guys, in this session, we'll be dealing with one of the most famous cloud-based data warehouse provided by Amazon, which is Amazon Redshift. In simple words, Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost-effective for you to analyze all your data across your data warehouse and data lake. Guys, I have a definition which is put up on the screen, and I have few words which I have highlighted over there. So as we progress through the course of this session, we'll know what those words exactly mean. So let's ignore them for now. But there are certain key concepts which you should be aware of when you're dealing with Amazon Redshift. So we'll discuss them now. Amazon Redshift Dataware is a collection of compute resources which we call nodes. And these nodes, when organized into a group, they become clusters. Each of these clusters run an Amazon Redshift engine and it contains one or more databases. So this cluster has a leader node and one or more compute nodes. As for the leader node, it receives queries from client applications and then it passes these queries and develops a suitable query execution plan. And then it coordinates the parallel execution of these plans with one or more compute nodes. Once the compute nodes finish executing this plan, again the leader node aggregates the results from all these intermediate compute nodes and then sends it back to client application. Then we have compute nodes. You can think of these compute nodes as a compute resources that execute the query plan which was developed by leader node. And when they are executing this plan, they transmit data among themselves to solve many queries. These compute nodes are further divided into slices, which we call node slices. Each of these node slices receive part of memory and disk space. So the leader node distributes data and part of user query that it receives from client application to these node slices. And all these node slices work in parallel to perform operation and increase the performance of your Redshift data warehouse. So to say, we have leader node, we have compute nodes and node slices. But how do they interact with client application? That is the question here. So I have these client applications, basically BI tools or it can be any other analytical tools, which communicate with Amazon Redshift using drivers like JDBC and ODBC. JDBC refers to Java Database Connectivity Driver. It is an API for programming language Java. Then we have ODBC. It refers to other database connectivity driver and it uses SQL to interact with leader node. So basically using these drivers, client application sends a query to leader node. Leader node, on receiving the client application's queries, it passes these queries and develops a suitable execution plan. Once the plan is set up, compute nodes and compute slices start working on this plan. They transmit data among themselves to solve these queries. So once the execution is done, leader node again aggregates the results from all these intermediate nodes and sends it back to client application. So this is the simple explanation of Amazon Redshift concepts. Moving on, when you launch a cluster, you need to specify the node type. Basically, we have two types of nodes. Dense storage nodes. These are storage optimized and they are used to handle huge data workloads. And basically, they use hard disk drive or HDD type of storage. And then we have dense compute. These dense compute nodes are compute optimized and they are used to handle high performance intensive workloads. And they mainly use solid state drive or SSD kind of storage. But there are three things that you should keep in mind when choosing one among them. Firstly, you should be aware of the amount of data that you want to import into your Amazon Redshift. And then the complexity of the queries that you run on your database. And the need of downstream systems that depends on the results of these queries. So keeping these three things in mind, you can choose either dense storage nodes or dense compute nodes. So guys, that was the architecture and its key concepts. Now we'll take a look at few reasons as to why Amazon Redshift is very popular. As we discussed earlier, setting up a traditional data warehouse involves a lot of money and resources. But it's very easy to set up, deploy, and manage a suitable data warehouse using Amazon Redshift. On Amazon Redshift console, you will find Create a Cluster option. When you click on that option, Amazon Redshift asks you for certain details like the type of node you want to choose, the number of nodes, the VPC in which you want to create your data warehouse, user ID, password, and many other details. Once you feel that you have given the right set of details, you have an option which says Launch the cluster. And one click, your data warehouse is just created. So with one click, you can easily create a data warehouse in Amazon Redshift. Once your data warehouse is set up, Amazon Redshift automates most of the common administrative tasks like managing, monitoring, and scaling your database. So you don't have to worry about managing or scaling your database needs. So that's how easy it is to develop or set up a data warehouse using Amazon Redshift. We also learned that auto-scaling is difficult in traditional data warehouse, but you can scale quickly to meet your needs in Amazon Redshift. Well, we already know that a cluster node has a leader node and one or more compute nodes. So if you want to auto-scale in Amazon Redshift, all you have to do is resize your cluster size. As we know, these compute nodes are like compute resources. So if you want to scale up, you can increase the number of compute nodes. Similarly, if you want to scale down, you just have to decrease the amount of compute nodes. Alternatively, we have something called single node and multiple node. In single node cluster, one node takes the responsibilities of both leader and compute functionalities. And the multi-node cluster contains one leader node and user-specified number of compute nodes. So suppose you want to resize your cluster and you are using a single node cluster, then you can change from single node cluster to multi-node cluster. Similarly, you can change from multiple node cluster to single node cluster when needed. So that's how easy it is to scale up and down in Amazon Redshift. Moving on, we learned earlier that while using traditional data warehouses, it's possible that the performance of your data warehouse might decrease. But with Amazon Redshift, you can get 10 times better performance than any other traditional data warehouse. It uses a combination of different strategies like columnar storage and massively parallel processing strategies to deliver high throughput and response times. So let's discuss these strategies one by one. Well, first we have columnar data storage. To understand what that is, first we should know row storage. Most of the traditional data warehouse and databases use this row storage. In row storage, all the data about a record is stored in one row. Okay, so let's say I have this database here. I have 3 columns and 2 rows. The first column contains the unique number associated with student. The second column contains the name of a student and the third column contains the age. As we already know, data is stored in form of blocks in databases or data warehouses. So as you can see in row storage, the block 1 contains all information there is about a particular student, his SSN, his name, and then age. So basically it stores all the information that there is in a single row. So in the first block, you have information about first student, and in the second block, you have information about second student, and it goes on. Now the columnar storage. Again, I'm using the same database. Again, I have 3 columns and 2 rows. But column storage stores data by columns, with data for each column stored together. So again, we have blocks, but the first block here has all the data that is there in first column. So you have all the SSN stored in first block, and all names stored in second block, and all the ages stored in third block. So it goes on. There are a lot of advantages of using this column storage. Firstly, since in column storage, a single block contains same type of data, you can achieve better data compression. As you can see, columnar storage can hold values 3 times the records as row-based storage. Because of this, the number of input-output operations decreases. And thirdly, by storing all the records for one field together, columnar database can query and perform analysis on similar type of data far quicker than row storage. So this is how the concept of columnar storage, which is used by Amazon Redshift, provides us a better performance. And then we have massively parallel processing. I'm sure you might have heard of parallel processing in computer science. It's just that number of different processors work together or compute together or in parallel. Similarly, massive parallel processing in Amazon Redshift is nothing but clustering. We have already discussed this earlier. We have a cluster, and this cluster has a leader node and one or more compute nodes. And this compute nodes is further divided into something called node slices. So when this leader node receives a query, it develops an execution plan, and this compute nodes and compute slices work together or in parallel to execute this plan. And later, this leader node sends the results back to client application. So basically, this compute slices and compute nodes work in parallel to achieve better performance. Moreover, Amazon Redshift is also able to smartly recognize the data on nodes before running a query, which dramatically boosts the performance. So that's how we can get a 10 times better performance using Amazon Redshift. And then the cost. In traditional data warehouses, people had to spend a lot of money to set up and then later to maintain the data warehouse. But Amazon Redshift is the most cost-effective cloud-based data warehouse. If you remember, in traditional data warehouse, they had to spend on hardware, real estate, manpower, electricity, and deployment cost and many others. And as their data warehouse grew, they had to spend again on meeting the storage and compute needs. But in Amazon Redshift, we don't have to pay any upfront cost. So Amazon Redshift is most cost effective and it costs 1/10 of traditional data warehouse. You can start small for just $0.25 per hour without any commitments, and you can gradually scale up later if you need. In addition to all those advantages, Amazon Redshift allows you to query data from Data Lake. Data Lake is a storage repository that holds a vast amount of raw data in its native format until it is needed. So in Data Lake, you have data in different formats. You can load data from Amazon S3 into your Amazon Redshift cluster for analysis very easily. That is, from Data Lake, you can store easily into your Amazon Redshift. But it needs more effort and cost. Effort because loading data into Amazon Redshift cluster involves extract, transform, and load, which we simply call ETL process. And this process is very time consuming and compute intensive. And it's costly because uploading lots of data, cold data from Amazon S3 for analysis requires growing your clusters, which is again costly and requires a lot of resources. So as a solution, we have something called Amazon Redshift Spectrum, which acts as an interface between your Amazon S3 or Data Lake and Amazon Redshift. So you can directly query data stored in Amazon S3 or Data Lake with this Redshift Spectrum without need for unnecessary data movement. I hope that was clear. And finally, with Amazon Redshift, your data is safe and secure. It offers backup and recovery. So as soon as data is created or stored in Amazon Redshift, a copy of that data is made, and through secure connections, a snapshot of it is sent to Amazon S3 for later. So suppose you lose your data, or if you have deleted the data from Amazon Redshift by mistake, you can restore the data easily from Amazon S3 service. Amazon Redshift also provides you with an option to encrypt your data. So when you enable this encrypt option, all the data in your cluster, in your leader node and your compute nodes and node slices is encrypted, and this way your data is very safe and secure. So guys, these are all the advantages of using Amazon Redshift. So now you have a basic idea of its architecture, its various key concepts like clusters, nodes, leader node, node slices. Now it's time to work on a demo. In this demo, we'll see how to transport data from Amazon S3 to Amazon Redshift data warehouse and perform simple queries. So I hope that was clear to you guys. Let's get started. But the first thing, there are certain softwares which you need to pre-install so that you can start working on Amazon Redshift. First, suppose you want to perform queries on the data on Amazon Redshift, then you need a SQL workbench where you can perform your queries. And as we learned earlier, the client application need a connection to communicate with Redshift. So we need to install a JDBC driver. And for that JDBC driver to run, we need to have a Java runtime environment. So we have 3 things to install here now. I'll show you how to install each of them. And I have this Java runtime environment download link by softonic.com. So it says free download and you click on that, it'll be downloaded. You can store it anywhere. And once you're done with that, search for Amazon Redshift documentation. So here it is. Okay, not that. This one. And when you scroll down, it says Amazon Redshift get started. Click on that. And in the step 1, we have prerequisites. Okay. Scroll down and it says in the step 2, you have an option where you can download or go to SQL Workbench website and download it. So click on that. And here it says build current version. And you have download generic packages for all systems. You can download it. Once you click on that, it'll start downloading. And there is one more thing, which is JDBC driver. Go back to documentation part. Scroll down and the step 4, you can see configure a JDBC connection. Click on that. It'll take to your page where you have JDBC drivers of different version. You can download the first one. Click on this and it'll be downloaded. So once all these three things are downloaded, store them in a file of your choice. Well, I have stored them on my desktop. I have this AWS folder and in that Redshift. So here's my workbench, a zip file. It was a zip file, so I extracted all the files. And then I have my JDBC driver here. Well, Java runtime environment isn't download, so that's okay. So I hope that was easy. So just install all these things and you're set to go. And we're back to our Amazon management console. I have previously used Amazon Redshift, so I have this Amazon Redshift in recently visited services. Anyway, you can search for Amazon Redshift here. Here it is. Well, it's taking time to load. Okay, this is my Amazon Redshift console page. And you have different kind of options on your navigation pane on the left side. And there are two ways to create or launch a cluster. First, you have quick launch cluster option and launch cluster option. This is the very easy way to launch a cluster. But suppose you want the freedom to specify all the details as in the VPCs, the security groups, different type of nodes, username, password, and all that, you can go for launch cluster option. Let's go ahead and explore that. So first it asks for a name, let's say my cluster, and database, DAT1, and the port, this is default port, 5439 is the default port which will be handled by Amazon Redshift. Then the master username, let's say AWS user, and password. That's it. And confirm your password and click on continue option. So cluster details are done and dusted. Then you have node configurations. Well, for the free tier, you only have DC2 large. But suppose you have a premium membership, then you can choose any of this. For this DC2 large, this is the CPU capacity, memory, and storage. And the input output performance is moderate. You can go ahead and choose the cluster type. We discussed this. We have multi-node and single node. In single node, we have both the leader and the compute node responsibilities handled by single node. The multi-node, we have a single leader node and user-specified number of compute nodes. Click on continue. And then here it asks for the VPC details, parameter group, and suppose you want encryption or not, and all the details. So basically, in this launch cluster option, you have the freedom to specify all the details. But for this demo, I'm going to use quick launch cluster option. So again, as for the free tier, I'm using DC2 large. And again, for the free tier, I'm using DC2 large type. It says there are 2 compute nodes. And let's retain the same cluster name. As for the master user, AWS user. Now let me give the password. And the default port is 5439. And last option, we have to choose among the available IAM users or IAM roles. But the question is why we need an IAM role here. In this demo, I said that we're trying to import data from Amazon S3, but you need certain set of permissions to access data which is stored in Amazon S3. For that, we need to create an IAM role. So let's go back to IAM service. Let me close all these tabs. Okay. Here you have roles option. You can click on that and click create role. And since we're dealing with Amazon Redshift, select Redshift, Redshift customizable, and click on next permissions. So we want Amazon Redshift to access data from Amazon S3. So search for S3 here. And you have a permission which says Amazon S3 read-only access. Well, for this demo, this is enough. But there is one more permission which says Amazon S3 full access. So you can perform read and write operations as well. As for this demo, I'm going to choose this permission which says Amazon S3 read-only access provides read-only access to all the buckets in Amazon S3. And click on next review. Give your role a name. Let's say my Redshift role 2. And click on create role. So now our Amazon Redshift database has permission to access data from Amazon S3. Let's go back to Redshift console. Okay, let me refresh this. And now it's showing the role which has been created is showing here. So as you can see, unlike other launch option in this, I didn't have to specify much details, just the node type, the number of nodes, and then the master username, cluster identifier, and password, and the default database port. And you can click on launch cluster option. So with one click, you've easily deployed a database on Amazon Redshift. If you remember, when we tried to use this launch cluster option, we had option to select a default database or use or create our own database. But when you use this quick launch cluster option, a default database called dev will be created for us. So guys, this cluster has been created. So before we connect it to your SQL workbench, let's try to explore here. You need to make sure that the database health status and in maintenance status, everything is in green color. As for the cluster status, it should be available. And for the database health, it should be healthy. Only then you can make a perfect connection with your SQL workbench. So you have this icon here, click on that. Well, you get all the information there is about your cluster. or you can just go ahead and click on this cluster. So this is the endpoint. This tells me all about how to make a connection with this cluster. I have this. When I click on that, it says publicly accessible, yes. And the username is AWS user. And the security groups, apparently it just shows the TCP rules which are set. So that's about the endpoint. Then the cluster name, you have cluster type, node type, and it shows the nodes and the zone and the date and time when it was created. And you have cluster version as well. On the right side, you have cluster status, which is available, database health healthy. So is it currently in maintenance mode? No. And then you have parameter group apply status, which is in sync with your database. And there are a few other features as well. But here you can see this VPC group. Click on that. Go for inbound and make sure it is set for TCP. Okay, edit. Make this custom TCP rule. And here 5439. Custom. That's it. And click on save option. So that's the default port with which you can access the Redshift. And let's go back. Clusters. Okay, where were we? We changed the default group of VPC. So this is the URL with which you can connect to the SQL workbench. So let's copy this and paste it in our text file. I've pasted it over there. Well, if you're using ODBC connection, then you can use this URL. When you scroll down, you have capacity details of your entire cluster. It's DC2 large. So 7 EC2 compute units, total memory, storage, and platform. Okay. Let's go back to this IAM role. But I should have an IAM role option here. Let me see. Check it out. Okay. There's an option which says see IAM roles. You can copy this entire thing and paste it again in the editor so that while connecting it, it'll be easy for us to find it. Okay. Then, so now your cluster is created, your database or data warehouse is set up. Now you can just connect it with SQL Workbench and start working on it. So let's go back to the folder where I've stored my Workbench. Here it is. When you scroll down, there's a file which says SQL Workbench executable jar file. Open. So here it is. It's asking for a default profile name. Let's say new profile 1. Okay. Then driver. That was Amazon Redshift driver only, JDBC driver. And this was the URL. We copied it earlier in the editor. So I'm going to paste it over here now. This is the URL. Control C and paste it. AWS user in the password. Okay, that should work. Make sure that you select this auto commit, save it, and then click on OK. It says connecting to the database. Now it's successfully connected. So I can easily perform queries now. First, let's create some tables. Well, I'm using the sample database from Amazon S3. So you have this AWS Redshift documentation. Go back to that. And here it says get started. And in the step 6, you have this default SQL queries and tables provided. So you can go ahead and use that. I have it stored in my editor. So I'm going to copy. First, I'm going to create all the tables. Control C and paste it over there. Let's check what tables are there. First, we have user table. Well, this is like an auction data schema. So you have user table, many users, and you have category users, the category, different categories to which users belong to. And then you have date on which a particular event occurred. Then you have event table, all the details regarding an event. Listing, as in the items which are being sold are listed here, all the details about the items. Then you have sales, as in which user is buying, how much, which item, and all that details. So basically we have 6 to 7 tables. I'm going to select all that and say run option. So here it says table users created, table venue created, category, date, event, listing, and sales. So all the tables are easily created now. As for the next part, we need to copy the data or the data for the database from Amazon S3 to Amazon Redshift. Let's go back to the editor. And I have this copy command. I'll explain you the format. Control C. And let's paste it here. Okay, let's explore this copy command. It says copy to the table users which you just created from this path. That is from the file which is stored in S3 bucket. But this is the credentials AWS IAM role which we copied to the editor earlier. Apparently, we're just giving a permission to access the data from S3. So we need to copy this IAM role here. And then we have delimiter. As in, let me go back to editor and show you an example. Okay. Let's say I have a data. Let's say I have name Archana space some age, DE, hobbies. So you can see this straight line. This is the delimiter, as in the thing which you're using to separate all the fields or the columns. So going back, so that's delimiter which separates the data. And this is region in which your S3 bucket is located. So that's it. But we have to replace the IAM role. This is the ARN of the role. I'm going to copy it. And wherever this is, you need to just paste it. Control V. Okay, we're done. Last one. So select everything and click on this execute button. It might take a while because the data set which was stored in Amazon S3 might contain large number of rows, so it might take a while. So as you can see, it states executing statement here. It says 1 out of 7 finished. So we have 6 more to go. So this SQL workbench has successfully executed all the script which we have written here. Let's go and start performing some simple queries. Let's say I want to extract the metadata of user table. I have this query. Okay, select star from page table definition. So since we are extracting metadata from table name, let's say users, and click on execute option. So you have so many columns. Here it says first column user ID of type integer, encoding delta. Then you have username, first name, last name, city, state, email. So basically that's the metadata or the structure of user table. So we have sales ID, list ID, seller ID, buyer ID, and many other details. Let's execute some other command. Let's say I want to find total sales on a given date. Okay. Sum the count. Here I have some function which will count the number of sales from sales and date, where the sales date ID is date ID, and the date on which I want to calculate, I've specified it here, and then click. Okay, the sum error, it should show a number here. Rest is working, only that is not working. I've selected the user table and I've asked them to display all that there is in the user table. So this is the data. Okay, select star from users. So I want to extract the names of people who are from, let's say some states. Let's consider some state. Let's take NH. So STATE like NH. It should work now. It says executing statement. So these are the people who are from state NH. So basically, once you have the perfect connection from your SQL workbench to your Amazon Redshift, you can perform whatever queries you like. So let's go back to our Amazon Redshift console. Well, so this is the cluster. I'm going to click on this. Here you have queries. When you click on that, all the queries which you performed till now will be shown. So this is the query. So it says first name from users who was from state NH. This was the query which we performed earlier. So you have all the data or all the information regarding the queries which you executed. Well, that's all about Amazon Redshift. So guys, this is how easy it is to create a data warehouse using Amazon Redshift. Go ahead and explore many other features of Amazon Redshift. Well, I've just showed a part of them here. So go ahead and create a database, perform various queries, and have fun.
What is AWS Kinesis? So Amazon Kinesis is one of the best managed services which particularly scales elastically, especially for real-time processing of the data at a massive point. These services can be used to collect large streams of data records which are especially consumed by the application process that runs on Amazon EC2 instances. This Amazon Kinesis is used to collect, streamline the process and analyze the data so that easily we can get the perfect insights as well as the quick response with respect to the information. It is also offering the key capabilities at a cost-effective price in order to process the streamlined data at a particular scale with the help of flexible tools according to the needs and requirements. Through the Amazon Kinesis, you can also get the real-time data like the video, audio, application logs, as well as the website click streams, machine learning, and other applications too. This new technique by the Amazon will help you to analyze and process the data instantly instead of waiting for long hours after collecting the data. So this was a quick overview of AWS Kinesis. So now let us move on to the next part here, which is the advantages. So basically the first and foremost advantage of Kinesis is that it is real time. Amazon Kinesis enables you to ingest, buffer, and process streaming data in real time so that you can derive insights in seconds or minutes instead of hours or days. The next point here is that it is fully managed. Amazon Kinesis is fully managed and runs your streaming applications without requiring you to manage any complex infrastructure. And the third point here is the scalability. Amazon Kinesis can handle any amount of streaming data and process data from hundreds of thousands of sources with very low or minimal latency. So these were a few advantages of using Amazon Kinesis. And now let us talk about the next part here, which is the Amazon Kinesis capabilities. So the first service or the capability of Amazon Kinesis is the Kinesis video streams. The Amazon Kinesis video streams are used to secure all the stream data like videos, photos, and the connected devices to the AWS for machine learning, analytics, and other processing, which can give access to all the video fragments and encrypts the saved data without any problem. So you can refer to the diagram that is present on your screen right now. The next point here is Kinesis data streams. So this Amazon Kinesis data streams in the Amazon is specifically used to build the real-time custom model applications by preceding the data stream process by using the most popular frameworks. It can easily ingest all the stored data with all the data streaming prices by using the best tools like Apache Spark that can be successfully run on the EC2 instances. So the next point here is Kinesis data firehose. In order to capture, load, and transform the data streams into the respective data streams, this Kinesis data firehose is used to store in the AWS data store near all the analytics with all the existing intelligence tools. These tools can be used to prepare all the loads of the data continuously according to the destination with the durable for analytics, which gives an output like analyzing the streaming data. And the last point here is the Kinesis data analytics. The Kinesis data analytics in the Amazon Kinesis is one of the easiest ways in order to process all the real-time technique with SQL that has to learn all the programming languages with processing frameworks. This Kinesis data analytics is used to capture the streamed data that can run with all the standard queries against the data streams in order to precede the analytical tools for creating alerts by responding it in real time. So these were the capabilities of AWS Kinesis. So now let us discuss the use cases of Amazon Kinesis. So the first point here is the video analytical applications. This Amazon Kinesis in the application is also used to secure all the streaming video for the camera equipped devices which are placed in factories, public places, offices, and the homes to AWS account. This video streaming process is also used to play the video, monitor the security, machine learning, and face detection along with other analytics. The second point here is batch to real-time analytics. Using Amazon Kinesis, you can also easily perform all the real-time analytical steps on the respective data to analyze the batch processing from the data warehouses through Hadoop frameworks. Data lakes, data sciences, and machine learning are one of the most common methods used in such cases. In order to load the data continuously, you make the use of Kinesis Firehouse to update all the machine learning models more frequently for the new and accurate data outputs. The third point here is building real-time applications. If you want to build the real-time applications, you can also use this Amazon Kinesis in order to monitor the fraud detection along with the live leader results. This process can be used to ingest all the streaming data easily to the Kinesis streams with the analytics and the data that is stored in the application itself with the end-to-end latency. All these processes can help to learn more about the clients, products, services, and the applications to react immediately. And the last point here is analyzing the IoT devices. This Amazon Kinesis is used to process the streaming data directly from the IoT devices like the embedded sensors, TV setup boxes, and consumer appliances. You can also use this data in order to send the real-time alerts to the actions programmatically when the sensors exceed the entire threshold operating. It is better to use the sample of IoT analytics codes while building an application. So these were the use cases of Amazon Kinesis. And now we will move to the next part here, which is the comparison between Kinesis and SQS. Amazon Kinesis is differentiated from Amazon's simple queue service, that is SQS, in that Kinesis is used to enable real-time processing of the streaming big data. SQS, on the other hand, is used as a message queue to store the messages transmitted between distributed application components. Kinesis provides routing of records using a given key, ordering of records, the ability for multiple clients to read messages from the same stream concurrently, replay of messages up to as long as 7 days in the past, and the ability for a client to consume records at a later time. Kinesis streams will not dynamically scale in the response to an increased demand. So you must provision enough streams ahead of time to meet the anticipated demand of both your data producers and the data consumers. SQS provides for messaging semantics so that your application can track the successful completion of work items in a queue, and you can schedule a delay in messages of up to 15 minutes. Unlike Kinesis streams, SQS will scale automatically to meet application demand. SQS has lower limits to the number of messages that can be read or written at one time compared to Kinesis, so applications using Kinesis can work with messages in larger batches than when using SQS. So this was a comparison between Amazon Kinesis and Amazon SQS. So the next part here is to understand how does it work. So here I'm going to discuss the Amazon Kinesis data stream, which is one of the capability of Amazon Kinesis. So you can use Amazon Kinesis data streams to collect and process large streams of data records in real time. You can create data processing applications known as Kinesis data streams applications. A typical Kinesis data stream application reads data from a data stream as data records. These applications can use the Kinesis client library, and they can run on Amazon EC2 instances. You can send the processed records to dashboards, use them to generate alerts, dynamically change pricing and advertising strategies, or send data to a wide variety of AWS services. Kinesis data streams is a part of Kinesis data streaming platform, along with other components as we previously discussed, such as Kinesis data firehose, Kinesis video streams, and Kinesis data analytics. So before discussing the architecture, let us have a look at the few of the terminologies that are used very frequently with Kinesis data stream. First term here is, what is a Kinesis data stream? A Kinesis data stream is a set of shards. Each shard has a sequence of data records, and each data record has a sequence number that is assigned by Kinesis data streams. So we will discuss shards and sequence in the later part of this session. The next term here is a data record. A data record is the unit of data stored in the Kinesis data stream. Data records are composed of a sequence number, a partition key, and a data blob, which is an immutable sequence of bytes. Kinesis data streams does not inspect, interpret, or change the data in the blob in any way. A data blob can be up to 1 MB in size. The next term here is the retention period. The retention period is the length of the time that the data records are accessible after they are added to the stream. A stream's retention period is set to a default of 24 hours after creation. You can increase the retention period up to 168 hours, that is 7 days, using the increase stream retention period operation, and decrease the retention period down to a minimum of 24 hours using the decrease stream retention period operation. So additional charges apply for streams with a retention period set to more than 24 hours. The next term here is the producer. So producers put the records into Amazon Kinesis data streams. So say for example, a web server which sends log data to a stream can be called a producer. And next term here is the consumer. Consumer gets the records from the Amazon Kinesis data streams and processes them. These consumers are known as Amazon Kinesis data streams application. The next term here is Amazon Kinesis data streams application. An Amazon Kinesis data streams application is a consumer of a stream that commonly runs on a fleet of EC2 instances. So there are two types of consumers here. So the first one is the shared fan-out consumer, and the second one is the enhanced fan-out consumers. The output of Kinesis data streams application can be an input to another stream, which enables you to create complex topologies that process the data in real time. An application can also send data to a variety of other AWS services. There can be multiple applications for one stream, and each application can consume data from the other stream independently and concurrently. So the next term here is a shard. A shard is a uniquely identified sequence of data records in a stream. A stream is composed of one or more shards, each of which provides a fixed unit of capacity. Each shard can support up to 5 transactions per second for reads and up to 1000 records per second for writes. The data capacity of your stream is a function of the number of shards that you specify for the stream. The total capacity of the stream is the sum of the capacities of its shards. If your data rate increases, you can increase or decrease the number of shards allocated to your stream. The next point here is the partition key. A partition key is used to group data by a shard within a stream. Kinesis data streams segregates the data records belonging to a stream into multiple shards. It uses a partition key that is associated with each data record to determine which shard a given data record belongs to. Partition keys are Unicode strings with a maximum length limit of 256 characters for each key. An MD5 hash function is used to map partition keys to 128-bit integer values and to map associated data records to shards using the hash key ranges of the shards. When an application puts data into a stream, it must specify a partition key. So the next term here is the sequence number. So each data record has a sequence number that is unique per partition key within its shard. Kinesis data streams assign the sequence number after you write to the stream with client.putRecords or client.putRecord. Sequence number for the same partition key generally increase over time. The longer the time period between the write requests, the larger the sequence numbers become. The next term here is the Kinesis client library. The Kinesis client library is compiled into your application to enable fault-tolerant consumption of data from the stream. The Kinesis client library ensures that for every shard, there is a record processor running and processing that shard. The library also simplifies reading data from the stream. The Kinesis client library uses an Amazon DynamoDB table to store the control data. It creates one table per application that is processing the data. So these were some of the terms that you must be aware of before moving on to the architecture part. So the next part here is the architecture of how does Amazon Kinesis data streams work. So what happens here is, as you can see the diagram that is present on your screen right now, the producers continuously push data into the Kinesis data streams. So as you can see here, these are the producers which produce the data. So for example, EC2 instances, client, mobile client, or the traditional servers. So these devices produce the data here, and the consumers process the data in real time. So as you can see here, this data produced by the producers is processed using the Kinesis data stream here. So these are the number of shards that are required for this data here. And these are the consumers which consume the processed data. So say for example, here it is shown that EC2 instances are the consumers. So consumers can store their results using an AWS service such as Amazon S3, DynamoDB, Redshift, EMR, Kinesis Firehose, and so on. So this is the overall working of Amazon Kinesis data streams. So now let us just move on to the last part of this session here, which is the demo. So as far as demo part is concerned, I will show you how do you create a Kinesis data stream and how do you add data to that stream and how do you read that data. So let us just move on to the Amazon console here. So for that, you have to log into your Amazon console here. And once you log in, you will see this main page here, and here you have to click on services. So in the services part, in the analytics section, you have to click on Kinesis. Okay. So once you're done with that, you have to click on get started. So here you can find the documentation part of Amazon Kinesis, which you can read for your further understanding. So let me just click on get started here. So as discussed earlier, these are the 4 capabilities of Kinesis: data stream, delivery stream, which is the Firehose, analytics, and the video streams. Okay. So as of now, I'll click on this create data stream here. So let me just name it. You can name it whatever you want. So let me just name it my Edureka stream. So, and here you have to click on the number of shards. For time being, I'm just writing here 1. So this is the bare minimum value that you can enter here. And depending upon your account, so in my case, it is a free tier account. So for that, I can enter maximum of 200 shards. So the write capacity is 1 MB per second, that is 1000 records per second, and the read capacity is 2 MB per second. So click on Kinesis stream here. So creating a stream takes only a few seconds. So as you can see here, you get this message here, stream, my Edureka stream has been created and the status is active. So now what we will do, we'll go to the command prompt here and we will try and execute a few commands. So the first command here is the describe stream command. So the command for describing an already created stream is AWS Kinesis described-stream here. And then you provide the name of the stream using this parameter stream name, that is my Edureka stream. And then you just have to specify the region here. Okay, so the region here in my case is Asia Pacific South 1. Okay, once you do that, just hit enter here. Okay, so as you can see here, you get the description or the information of the stream that you just created. And for this, we have one shard ID here, as you can see here, this part. So we will see how to use this shard ID here. So this is the description of the stream that we just created. So the next command that we're going to see is, you have to put the data in this stream, data, or you can see the record. So the command for that is AWS Kinesis put record, stream name, the name of the stream, the partition key, I've just specified it to 1, and the data. So data, you can enter whatever value that you want here. For time being, or for this example, I have entered here 1, and then you have to specify the region here. So just hit enter here. So for this record here, you have the shard ID and the sequence number. So similarly, let me just enter one more record here. So let me just enter the data 11, and the partition key should be different. So it's 2 here. Again, hit enter here. So one more record has been added. Just let's add one more record here. Data is 111 and partition key is 3. Okay, so just hit enter here, and you'll see this record has also been entered with a shard ID and sequence number. So the next command that we're going to see here is the command to get the shard iterator. Okay, so what a shard iterator will do, so let me just brief you regarding that. So a shard iterator will iterate through a set of records here. So if you just had to iterate through the number of records that you have in your data stream, so for that purpose we use shard iterator here. So the command for that is very simple, as you can see on the screen. AWS Kinesis get shard iterator type, which is trim horizon here in this case, and then you have to enter the shard ID here. So for these records, so say for example for the first record here, the shard ID is this one. Okay, so let me just copy it and paste it here. So once you do that, you just have to hit enter here, and after this command gets executed, you will get a shard iterator. So this is the shard iterator that we have just got. Okay, so this lengthy thing here. So let me just copy it. So now once you have the shard iterator, what you have to do is you have to get the number of records here. So for that, the command is AWS Kinesis get records shard iterator, and then you have to copy this iterator here. Copy it. You can just paste it here, and you have to enter the limit here. So say for example, if you want only 2 records, so you can do that using this flag or parameter called limit here. So let me just enter the limit for 3 here, since we have entered 3 records. So if you just hit enter here, so as you can see here, you have got 3 records here. Okay, so this is the data and this is the partition key. So data is in encoded form here, this MQ equal to, okay, and the partition key is 1. So similarly, we have another data, and the partition key for that is 2. Okay, so this was 1, this was 11, and this was 111. So you can also decode this data if you want. And for the third record here, the partition key is 3, and this is the data here. So this is how you write data and you get records from the Kinesis data stream here. So I hope this demo here, it is good enough to get you started with Amazon Kinesis here. Similarly, you can get started with other Amazon Kinesis services here, such as the Firehose, Analytics, and the video streams. So this was the demo part here that I've just covered.
What is an API? API is basically the acronym for Application Programming Interface, which is a software intermediary that allows two applications to talk to each other. Suppose you're searching for a hotel room through an online travel booking site. Using the site's online form, you will fill the necessary information like the city you want to stay in, check-in and check-out dates, number of guests, and the number of rooms. Then you click Search. But what exactly is going on between entering your information to receiving your hotel choices? Yes, that's API. The site aggregates information from many different hotels, and when you click Search, the site then interacts with the hotel's API, which delivers results for available rooms that meet your criteria. And all this happens in seconds because of an API, which acts like a messenger that runs back and forth between applications, databases, and devices. So what exactly is the AWS API Gateway? The AWS API Gateway is basically a service provided by Amazon that is used to create, publish, maintain, monitor, and secure various APIs such as REST API, HTTP, and WebSocket at any scale. As an API developer, you can create APIs that can access either Amazon Web Services or any other web services along with the data stored in the AWS cloud. As an AWS Gateway API developer, you can create APIs for use in your own client applications as well as make your APIs available to third-party app developers. The API Gateway creates RESTful APIs. The term REST basically stands for Representational State Transfer. It is an architectural style that defines a set of rules in order to create web services. In a client-server communication, REST suggests to create an object of the data requested by the client and send the values of the object in response to the user. For example, if the user is requesting a movie in Bangalore at a certain place and time, then you can create an object on the server side. So over here, you have an object and you are sending the state of an object. This is why REST is known as Representational State Transfer. The architectural style of REST helps in leveraging the lesser use of bandwidth to make an application more suitable for the internet. It is often regarded as the language of internet and is completely based on the resources. The features of API Gateway. Amazon API Gateway offers features such as support for stateful or WebSocket and stateless or HTTP and REST APIs. It is powerful, provides flexible authentication mechanisms such as AWS Identity and access management policies, Lambda authorizer functions, and Amazon Cognitive user polls. You can also make use of the developer portal for publishing your APIs. It also provides canary release deployments for safely rolling out changes. It provides CloudWatch access logging and execution logging, including the ability to set alarms. You will also be able to use the AWS CloudFormation templates to enable API creation. It also provides support for custom domain names and integration with AWS WAF for protecting your APIs against common web exploits. Also, integration with AWS X-Ray for understanding and triaging performance latencies is available. So those were some of the features of the AWS API Gateway. Talking about the benefits of using the AWS API Gateway. Now, there are a number of benefits of using the AWS API Gateway. First is that it supports efficient API development. You will be able to run multiple versions of the same API simultaneously when you make use of the API Gateway, which allows you to quickly iterate, test, and release new versions. Also, you will have to pay for calls made to your APIs and data transfer out, and there are no minimum fees or upfront commitments. Performance at any scale. You can provide end users with the lowest possible latency for API requests and responses by taking advantage of the global network of edge locations using Amazon CloudFront. Throttle and traffic authorize API calls to ensure that backend operations withstand traffic spikes and backend systems are not unnecessarily called. The Amazon API Gateway provides a tiered pricing model for API requests. With an API request price as low as $0.9 per million requests at the highest tier, you can decrease your costs as your API usage increases per region across your AWS accounts. Easy monitoring. Performance metrics and the information can be monitored on API calls, data latency, and error rates from the API Gateway dashboard, which allows you to visually monitor calls to your services using Amazon CloudWatch. Flexible security controls. You will be able to authorize access to your APIs with AWS Identity and Access Management or the IAM and Amazon Cognito. If you use OAuth tokens, API Gateway offers native OIDC and OAuth 2 support. To support custom authorization requirements, you can execute a Lambda authorizer for AWS Lambda. RESTful API options. Create RESTful APIs using HTTP APIs or REST APIs. HTTP APIs are the best way to build APIs for a majority of use cases. They are up to 71% cheaper than REST APIs. If your use case requires API proxy functionality and management features in a single solution, you can use REST APIs. So who makes use of the API Gateway? The API Gateway is basically used by two types of developers, that is, the API developers and the app developers. An API developer is basically someone who creates and deploys APIs to enable the required functionality of an API gateway. To make use of AWS API Gateway, you must be an IAM user in the AWS account that owns the API. On the other hand, an app developer builds a functioning application to call AWS services by invoking a WebSocket or REST API created by an API developer in the AWS API Gateway. This way, the app developer becomes the customer of the API developer. Therefore, the app developer does not require to have an AWS account. However, the API that is created should either not require the IAM permissions or it should support authorization of users through third-party federated identity providers that are supported by Amazon Cognito User Pool Identity Federation. Such identity providers include Amazon, Amazon Cognito User Pools, Facebook, and Google. API Gateway REST API. So if you remember, we've spoken about REST API, WebSocket API, and HTTP API. Now let me just brief you about each of these. API Gateway REST API. It is basically a collection of HTTP resources and methods that are integrated with backend HTTP endpoints, Lambda functions, or other AWS services. You can deploy this collection in one or more stages. Typically, API resources are organized in a resource tree according to the application logic. Each API resource can expose one or more API methods to have unique HTTP verbs supported by the API Gateway. Using AWS API Gateway, you can create RESTful APIs that are HTTP based and can enable stateless client-server communications and also implement standard HTTP methods such as GET, PUSH, POST, PATCH, and DELETE. The AWS API Gateway WebSocket API. It is basically a collection of WebSocket routes and route keys that are integrated with backend HTTP endpoints, Lambda functions, or other AWS services. Just as REST API, you can deploy the collection of WebSocket APIs in one or more stages. API methods are invoked through front-end WebSocket connections that you can associate with a registered custom domain name. The AWS API Gateway will create WebSocket APIs that adhere to the WebSocket protocol, which enables stateful, full duplex communication between the client and the server. Also, you can route incoming messages based on the message content. API Gateway HTTP API. It is nothing but a collection of routes and methods that are integrated with backend HTTP endpoints or Lambda functions. Just as the previous two, you can deploy this collection in one or more stages. Also, each route can expose one or more API methods that have unique HTTP verbs supported by the API Gateway. Now that you have a brief idea about the three types of APIs available, let's take a look at some of the important terms and concepts that you should be aware of when you're working with APIs. First up is API development. It is nothing but a point-in-time snapshot of your API Gateway API. To be available for the client's use, the deployment must be associated with one or more API stages. API developer. This is nothing but your AWS account that owns an API Gateway deployment. For example, a service provider that also supports programmatic access. API endpoint. An API endpoint is a host name for an API in API Gateway that is deployed to a specific region. An API key. An API key is basically an alphanumeric string that API Gateway uses to identify an app developer who uses your REST API or the WebSocket API. API Gateway can generate API keys on your behalf, or you can import them from a CSV file. These API keys can be used along with Lambda authorizers or usage plans to control access of your APIs. API stage. An API stage is a logical reference to a lifecycle state of your API. These API stages are identified by an API ID and the stage name. A callback URL. When a new client is connected through a WebSocket connection, you can call an integration in API Gateway to store the client's callback URL. You can then use that callback URL to send messages to the client from the backend system. Developer Portal. An application that allows your customers to register, discover, and subscribe to your API's products, manage their API keys, and view usage metrics of your APIs. Edge-optimized API endpoint. It is the default host name of an API that is deployed to the specified region while using a CloudFront distribution to facilitate client access typically from across the AWS regions. API requests are routed to the nearest CloudFront point of presence or POP, which typically improves connection time for geographically diverse clients. Integration requests. It is the internal interface of a WebSocket API route or REST API method in an API gateway. An API gateway in which you map the body of a route request or the parameters and the body of a method request to the formats that are required by the backend. Integration response. The internal interface of a WebSocket API route or REST API method in API gateway in which you map the status codes, headers, and payload that are received from the backend to the response format that is returned to a client app. A mapping template. It is a script in Velocity Template Language or VTL that transforms a request body from the front-end data format to the backend data format, or that transforms a response body from the backend data format to the front-end data format. Mapping templates can be specified in the integration request or in the integration response. They can reference data made available at runtime as context and stage variables. The mapping can be as simple as an identity transform that passes the headers or the body through the integration as is from the client to the backend for a request. The same is true for a response in which the payload is passed from the backend to the client. Method request. It is the public interface of an API method in API Gateway that defines the parameters and the body that an app developer must send in requests to access the backend through the API. Method response. It is the public interface of a REST API that defines the status codes, headers, and body models that an app developer should expect in response from the API. Mock integration. In a mock integration, API responses are generated from API Gateway directly without the need for an integration backend. As an API developer, you decide how API Gateway responds to a mock integration request. For this, you configure the method's integration request and integration response to associate a response with a given status code. Model. A model is basically a data schema specifying the data structure of a request or a response payload. A model is required for generating a strongly typed SDK of an API. It is also used to validate payloads. A model is convenient for generating a simple mapping template to initiate creation of a production mapping template. Although useful, a model is not required for creating a mapping template. So those were some of the important terms that you should be knowing in order to move ahead with the session. Don't worry if you haven't understood it completely. We'll be elaborating more over this when we move on to the hands-on session. Before we move on to the hands-on session, let's discuss the pricing of the AWS API Gateway. With the AWS API Gateway, you only pay when your APIs are in use. There are no minimum fees or upfront commitments. For HTTP APIs and REST APIs, you pay only for the API calls you receive and the amount of data transferred out. There are no data transfer out charges for private APIs. However, AWS private link charges apply when you're using private APIs in the API Gateway. API Gateway also provides optional data caching charged at an hourly rate that varies based on the cache size you select. For WebSocket APIs, you only pay when your APIs are in use based on the number of messages sent and received and the connection minutes. The API Gateway free tier includes 1 million HTTP API calls, 1 million REST API calls, 1 million messages, and 750,000 connection minutes per month for up to 12 months. Post-free tier services, you will be charged based on the region, the type of API service that you use, and the number of requests. To know more in detail about the pricing, you can check out the official AWS API Gateway pricing page. Here, you will find all the necessary details based on the region of your choice. Now let's move on towards the most interesting part of the session, which is creating APIs using the AWS API Gateway. Prerequisites. Before using the Amazon API Gateway for the first time, you must have an AWS account. Therefore, you will have to sign up for an AWS account. And once your account has been created, you should also create an AWS Identity and Access Management, that is an IAM user with administrator permissions. To know more about how to create an AWS account, make sure to check out AWS Crash Course video from Edureka. Creating a REST API using Lambda. Now before doing that, I'll just brief you about what is AWS Lambda. AWS Lambda is basically a serverless compute service, meaning the developers don't have to worry about which AWS resource to launch or how they will manage them. All they have to do is just put the code on Lambda and it executes. The AWS Lambda executes your backend code by automatically managing the AWS resources. When we say manage, it includes launching or terminating instances, health checkups, auto-scaling, updating or patching new updates, etc. So in order to create a REST API using AWS Lambda, the first thing that you have to do is create a Lambda function. Now to do that, you will have to open up the AWS console. Now if you already have an AWS account, just log into your account. Else, create a new account before you get started. Please note that AWS will provide free services for an year, and to know more about the free tier services, you can check out Amazon's official page for the same. Now since I already have an account, what I'm going to do is just log into my account and get started. Okay, so once you've logged into your account, you'll be able to see the AWS Management Console, which is just as you can see on the screen. Now, as you can see, there is a huge list of services that are provided by AWS. So if you just scroll down, you will notice that the Lambda service is present under the Compute section. So just click on that to move on to the Functions List page. This page basically shows all the functions that you have created in the current AWS region. Please make a note that recently created functions might not immediately appear. It might take a while for them to show up. Now, as you can see, this page has several options such as create function, filter, actions, etc. Also, if you are a returning user who has already created some Lambda functions, you will see a list of functions that you have created, else the list will be empty. Now, if you want to create a new Lambda function, simply click on the create function option that is present at the top right corner of the page. Please make a note that the action drop-down list is not clickable. This is because the actions are to be performed on Lambda functions that are already created. So if you do not have any function, you will not be able to click on the actions list. However, if you have some function present already, select the function and you will see that the actions list gets enabled and it provides three options, that is view details, test and delete. As the name suggests, these actions will help you view the Lambda function details, test it or delete the functions if it is no longer required. Now, since we are focusing on creating a Lambda function, let me just create on the create function option. So now we've moved on to the create function page. The first option is author from scratch that allows you to create the Lambda function completely on your own. So if you want to create your own Lambda function, just give a suitable name and specify the runtime that you prefer. In our case, the name of the function will be Hello World. The runtime or the language that I want to make use of is Python. So I'll just select Python 3.8. So next up after the runtime, you see something called as permissions, which basically refers to the function permissions. By default, Lambda will create an execution rule with permissions to upload logs to the Amazon CloudWatch logs. Amazon CloudWatch is nothing but a monitoring and management service. It provides data and actionable insights for AWS, hybrid and on-premises applications, and infrastructure resources. When you make use of AWS CloudWatch, you can collect and access all your performance and operational data in form of logs and metrics from a single platform. However, the default role can be customized later when you wish to add triggers. Okay, so now I'll go ahead and click on Create Function option. It will take a few minutes to do so, so let me just wait for the same. Okay, so once the function has been created, you will see the message just as you see on the screen, which says successfully created the function hello world, which is the name of the function that I just created. Now this page basically allows the user to manage the code and the configurations. Once you have provided the required code and its configurations, simply click on test in order to execute the code. Now before doing that, let me walk you through this page. The first element that you see over here is page configuration. This element has something called as the designer. Here, you can add triggers, layers, and destinations to the Lambda function that you have created. A trigger over here refers to an AWS service or a resource that is used to invoke the Lambda function. Now, if you want to connect your function to a trigger, just click on Add Trigger option. And as you can see, there is a drop-down list over here with a huge list of triggers that you can choose from. Choose any service from the list to see the available options. As of now, I will not be using any of these, so I'll just click on Cancel to get back to the previous page. The next thing that you see over here is two options, that is the function that you've just created, which in my case is Hello World, and below that is Layers. By default, the function is selected, and when you scroll down the page, you will be able to see the code editor and a sample code that has been generated automatically for our function. Now this is a very simple function called as the Lambda handler, which simply returns a message saying hello world from Lambda. The code editor in AWS Lambda console enables you to write, test, and view the execution results of your Lambda function code. Okay, so now let me just scroll back up and select the layers option. Layers are basically resources that contain libraries, a custom runtime, or other such dependencies. You can create layers to separate your function code from its dependencies. By default, no layer has been added. To add a layer, all you have to do is choose Layers and then click on the option Add a Layer. To include libraries in a layer, place them in a directory structure that corresponds to your programming language. Now, since we have a very simple function, I will not need any extra layer for it. But just for the sake of showing you guys, let me click on Add a Layer option. As you can see, there's a drop-down list present over here as well. There are two more options that are present over here. One is Custom Layer and the other one is Specify an ARN. In the Custom Layer option, you will see any of the previously used or created layers. Since I've not used any, my list is blank. The next option that I see over here is to use an ARN. ARN basically stands for Amazon Resource Name. Entering an ARN enables you to use the layer that is shared by another account or a layer that does not match your function's runtime. The format in which you should specify an ARN is shown in the text bar itself. Okay, so now let's get back to the previous page. So I'll just click on Cancel. Next up is the Destinations option. Destinations are AWS resources that receive a record of an invocation after success or failure. You can configure Lambda to send invocation records when your function is invoked asynchronously or if your function processes records from a stream. To add a destination, choose Add Destination option. The contents of the invocation record and supported destination services vary by the source. Now the next element that is present over here is permissions. Like I've already mentioned before, the default execution role that we used for this Hello World Lambda function has permission to store logs in Amazon CloudWatch logs. Now this is the only permission it has got for now. The resource permissions can vary depending on the role that you select for the function. Finally, the monitoring element of this page. When you click on this page, you see some graphs which are not showing any data for now. This is because I have not invoked my function as of yet. Once the function is invoked, you will be able to monitor, trace, and debug your Lambda functions. Okay, so coming back towards the Hello World function, let me just scroll down to the code editor. So now, To invoke this function, I will have to test it. Before clicking on test, let me just show you the default test event that is present. Now you can open the test configuration either by clicking on select a test event dialog box or opening the drop-down list that is present next to the test option in the code editor. So let's click on configure test events. Okay, so now as you can see, there are some default test events that are present over here. Also, by default, the create new test event option has been selected. The other option is edit save test events that cannot be selected as I have not created any test event before. So what I'm going to do is just give some name for this event, say event 1, and then I will click on create. Okay, so now our function is ready. To invoke the Lambda function, click on test. As you can see, the message says execution result has succeeded. When you open the details, you will be able to see the summary of the log output. The summary section shows the key information such as the time taken for the execution, build duration, which is 100 milliseconds, request ID, etc., reported in the log output. The log output section will show the logs generated by the Lambda function execution. When you check the monitoring page this time, you can see that the metrics over here have updated. In order to gather some more metrics, all you have to do is just execute or run the Lambda function a few times. Okay, so now our Lambda function is ready. The next thing that we have to do over here is create the API Gateway. So in step 2, you have to get back to the AWS console and from Networking and Content Delivery Service list, select API Gateway. Now in case you have already created APIs earlier, you'll be able to see them just like how you were able to see the Lambda functions list. Now, if you want to create a new API, click on Create API option. If you are using the API Gateway list for the first time, you see a page that introduces you to the features of the API Gateway. Now, since we are constructing on building a REST API, I will click on Build from REST API option. When you do this, you'll be able to see the Create New API page. Under Settings, for API name, you can enter any name and I'll be entering New API. Next, if you wish, you can enter a description in the description field. However, this is optional, so you can leave it empty as well. In my case, I'll just leave it empty. For the endpoint type, I'll keep it regional. Now once that is done, click on Create API. Okay, so as you can see, under resources, there is nothing but just a slash. This basically depicts the root level resource, which corresponds to the base path URL for your API. Next, click on the Actions menu. From the Actions menu, click on Create Method. When you do this, you will see that a new drop-down menu pops up below the root directory. This list basically consists of basic API methods such as get, put, post, delete, etc. For the purpose of this tutorial, I will select the get method and click on the tick mark beside it in order to save the choice that I just made. So as you can see, the get method setup pane has opened and by default, the Lambda function option has been selected. If you remember, prior to creating this API, we created the Lambda function that we wish to use along with this API. So next, select the Use Lambda Proxy Integration option. For Lambda region, choose the region that you created the Lambda function in. In my case, it's Ohio. Now since Ohio is in US East 2, I'll just keep the region as US East 2. Please select the region according to where you have created your Lambda function. In the Lambda function field, enter the name of the Lambda function that you created earlier. Okay, so as you can see, the moment I type H, the function Hello World is displayed in the drop-down menu. In case you forget the name of the function that you have created, just type any character and delete it. Then you will be able to see a drop-down menu that shows the Lambda function that you have created earlier. Leave the Used Default Timeout checked and finally click on the Save button to save your choice. Okay, so as you can see, a pop-up named Add Permission to Lambda function has been displayed that says you are about to give API Gateway permission to invoke your Lambda function. Now this is exactly what we want. So just click on OK. So next up, you will see another pane that is Get Method Execution pane. As you can see, this execution pane consists of a number of items. The client box over here represents the client, which is the browser or the application that calls your API's get method. If you click on the test link and then click on test, This simulates a GET request from a client. The method request box represents the client's GET request as it's received by API Gateway. If you choose method request, you'll see settings for things like authorization and modifying the method request before it's passed through to the backend as an integration request. Now for this demonstration, I leave everything set to the default values. The next box that you see is the integration request box. This box represents the GET request as it's passed to the backend. Here, the settings depends on the integration types that's selected. The URL path parameters, URL query settings parameters, HTTP headers, and mapping template settings are for modifying the method request as needed by the specific backend. The integration type for this demonstration will be set to Lambda function, and I leave the other settings set to the default values itself. So the next box represents the backend Lambda function that you have just created. If you click on this, it opens the Lambda function in the Lambda console. Integration response. The integration response box represents the response from the backend before it's passed to the client as a method response. For Lambda proxy integration, this entire box is grayed out because a proxy integration returns the Lambda function's output as it is. For a Lambda non-proxy integration, you can configure the integration response to transform the Lambda function's output into a form that's appropriate for the client's application. We'll be doing it later on in the other demonstrations, but for now, I'll just leave everything set to the default values as I've mentioned earlier. Method response. The method response box represents the method response that's returned to the client as an HTTP status code, an optional response header, and an optional response body. By default, the response body that's returned to your Lambda function is passed through as it is as a JSON document. So the response body default setting is application/JSON with an empty model indicating that the body is passed through as it is. For this as well, I'll just leave it set to the default values. Okay, so next is step 3. In step 3, you will have to deploy your REST API in the API Gateway console. Now until here, you've created your API, but you cannot actually use it. This is because it needs to be deployed. To deploy this, all you have to do is click on the Actions drop-down menu and choose Deploy API. From the Deployment Stage drop-down menu, click on New Stage. And for stage name, just enter prod. Once that is done, click on Deploy. So as you can see in the prod stage editor, the invoke URL is present right at the top. If you choose to invoke the URL, it will open a new browser tab with that URL. Now when you refresh this, you will see the default message that is hello from Lambda. Now if you wish to test the API that you've just created, you can make use of various tools such as curl or Postman. In this tutorial, I'll be using curl. Therefore, I'll show you guys a quick demonstration of how to install curl for Windows operating system. So what I'm going to do over here is just open the browser and search curl for Windows. Select the option curl for Windows, and then you will see two options, that is 64-bit and 32-bit. Select the appropriate option that suits your system and download the same. Once it has been downloaded, extract the files. So the next thing that you have to do is open the bin directory of this folder, paste its path in the path variable, which is present in your system environment variables. So just open your system environment variables, select path, and click on new. Paste the path that you've just copied, followed by a slash, and then click on OK. Now, to test the API, open the command prompt and type the following command along with the link of the API that you've just created. So curl -x get in caps followed by the link. As you can see, I have the desired output displayed on the screen which says hello from Lambda. So the next part of our demonstration deals with creating another Lambda function. What I'm going to do over here is add a parameter to the Lambda function. So click on the service drop-down list and select Lambda. Just as before, click on create function, and I'll just name my new Lambda function as hello world 2, and the runtime will be Python 3.7. Under Permissions, expand Choose or Create an Execution Role. And from Execution Role drop-down list, choose Use an Existing Role. From Existing Role, choose the role from your previous Lambda function. Also, you can create a new role with basic Lambda permissions. Then choose Create Function. In the function code pane, you'll see the default Hello from Lambda function. Now what I'm going to do is just replace the entire function with the code that I've already kept ready over here. So I'll click on Deploy. And the next thing that I'm going to do over here is add a resource, method, and parameter to the REST API in the API Gateway console. So I'll just click on Services, and then I'll click on API Gateway. From the APIs list, choose New API. And under Resources, click on /. Next, click on the Actions drop-down menu and click on Create Resource. For resource name, I'll just enter my resource. So notice that the resource path field is populated automatically with the resource name. Choose Create Resource. Next, from the Actions drop-down menu, choose Create Method. And under the resource name, that is my resource, you will see a drop-down menu. Choose Get, and then I'll just click on the checkmark icon to save the choice. Now in the My Resource Get Setup pane, for integration type, I'll just keep it as Lambda function. And for Lambda region, just like before, we'll choose the same region where we've created the Lambda function. In my case, it's US East 2. In the Lambda function box, type any character and then choose the Lambda function that you've just created, which is Hello World 2 in my case, from the drop-down menu. Now, in case the drop-down menu doesn't appear, just like I've told you earlier in the first session, type any character and just delete it. So once you've selected the Lambda function that you created, click on Save. So once this is done, you will see the Add Permission to Lambda function pop up. Now this basically says that you're going to give API Gateway permission to invoke your Lambda function. Now since this is what we want, I'll just click on OK. In order to grant the API Gateway the permission that is required. Now once that is done, you will see the My Resource Get Method Execution pane. Unlike the previous session, this time the integration response box is not grayed out. So just click on Integration Request and then expand the Mapping Templates option. Okay, so next, set the Request Body Pass-Through option to when there are no templates defined. So I'll just do that. And then I'll choose Add Mapping Template. For the content type, what I'm going to do is just type application/JSON and choose the checkmark icon. And then I'll click on the checkmark icon. Now in our case, the content type is application/JSON. Now in the template window, I'll just enter the code that I've already kept ready. Now this is the JSON document that will be passed to your Lambda function in the body of the input event object. The right-hand side of this tells the API Gateway what to look for in your input query string. The left-hand side stores it into the parameter that you're about to add to your Lambda function. So once that is done, just click on Save. And from the Actions drop-down menu, I'll choose Deploy API. From the Deployment Stage drop-down menu, click on Prod and then choose Deploy. So as you can see, again, I have the invoke URL present over here. The next thing that I'm going to do is test the API that I've just created. So what I'm going to do is just open the command prompt and I'll enter the curl command, that is curl-x get followed by the invoke URL. Okay, so as you can see, I have the desired output, that is hello from Lambda. In the next part of our demonstration, I'll be showing you guys how to create an API gateway directly through the Lambda service. So get back to the Lambda console and select the Lambda function that you've created. As you can see over here, it shows that a trigger that is an API gateway has already been added. Now click on Add Trigger. From the drop-down list, select API Gateway. So I'll just click on API Gateway and then select the Create New API option from the API drop-down list. And for the API type, I will just select HTTP API. Now the security can be kept open since this is just for demonstration purposes. Please make note that for real-time applications, you cannot keep the security option as open. Then click on Add. Now when I come back to the Lambda function configuration page, you will see that there are two API gateways for this function. When you scroll down, you will see both the APIs that have been created. Open the details of the Hello World API and click on API endpoint link. Okay, so as you can see, the function returns hello from Lambda. Now I'll just click on test a few times and then I'll open the monitoring page to see the metrics. So as you can see over here, I have the corresponding metrics for my Lambda function through the API that I've just created. So till now, we have seen how to create a REST API using the Lambda function through various methods. The next thing that I'm going to show you over here is how to create a REST API with mock integration. A mock integration basically enables your API to return a response for a request directly without sending the request to a backend. This enables you to develop your API independently from your backend. So the first thing that you have to do over here is create the API. Now for the purpose of this demonstration, I will create an API with the get method and a query parameter in the API Gateway console. What I'm going to do over here is get back to the API Gateway pageant, and then I'll click on Create API just like we've done earlier. On the next page, what I'm going to do is click on Build for REST API. So under Create New API, choose API, and for the settings, I'll keep the API name as My API, and just like before, the description is optional, so I'll just leave it blank. Okay, for the endpoint type, set it to regional. The next thing to do is click on Create API. Now, as you can see, the methods page option is empty, just like it was earlier. So from the Actions drop-down menu, click on Create Method. Under the resource name, that is /, you will see a drop-down menu. So from this drop-down menu, I'll just click on Get, and then I'll just click on the checkmark icon to save the choice. So now, as you can see, the Get Setup pane has appeared. Over here, for the integration type, I'll choose Mock, and then I'll just click on Save. Now we move on to the Get Method Execution pane. Okay, so now we've moved on to the Get Method Execution pane. Now the terms that are present over here have already been explained in the previous session. So in case you guys want to know what they are, just get back to the previous session and take a look at it. So for the next thing, what I'm going to do is create the mock integration. In this step, instead of integrating with the backend, I'm going to add a query string parameter to the get method, and then I'll specify the response codes and messages that our API will have to return. So first, create the query string parameter. Now for this, I'll just choose method request. In the get method request pane, I will expand URL query string parameters, and then I'll choose add query string. Over here, I'll just type my string for the name. I'll click on the checkmark icon. Okay. So next, what I'm going to do is create a mapping template that maps the query string parameter values to the HTTP status code values that are to be returned to the client. So I'll just get back to the method execution pane, and then I'll select on integration request. Okay, so from the integration request, I'll expand the mapping templates pane, and for request body pass-through, I'll choose the recommended option, that is when there are no templates defined. Content type again will be application/JSON. So I'm going to replace the contents that are present over here with the code that I've already kept ready. So I'll just paste it, and then I'll just click on Save. So step 3 is to define the successful response. So what I'm going to do over here is create a mapping template that maps the HTTP 200 status code value to a success message that is to be returned to the client. So I'll just click on method execution, and from here, I'll move on to the integration response. Now expand the 200 response, and then expand the mapping template section. Okay, so under content type, I'll just choose application/JSON. And for the template contents, I'll just have a basic message that says hello from Edureka. Okay, so I'll just paste that over here, and then I'll click on Save that is present in the mapping template section. Please make a note over here, guys, that you can see two save options. One is in the mapping template section. From both these options, you will have to select the save option that is present in the mapping template section. Now in step 4, I will add an HTTP 500 status code and an error message. Okay, so in this step, what I'm going to do is add an HTTP 500 status code that the front end can return to the client, and then you map it to an error message. So first, I'll have to add the 500 status code. So I'll just get back to method execution and I'll click on method response. Then just click on add response. For HTTP status, enter 500 and then click on the check mark, and then I'll just click on the check mark icon. Okay, so now create a mapping template that maps the returned 500 status code value to an error message from the front end to the client. So for that, I'll just get back to the method execution pane and I'll get into integration response. Then I'll choose add integration response, and for HTTP status regular expression, enter 5/d and 2 within curly braces. Now for method response status, choose 500 from the drop-down menu and then just click on save. Next up, all you have to do is expand the 500 response and then expand the mapping template section if it isn't already expanded. Under content type, I'll choose add mapping template, and in the box under that, I'll just enter application/JSON and then I'll click on the check mark icon. Now the message over here will be replaced saying that this is an error message. Okay, so I'll just paste that and I'll save the changes. Now for the final step, that is step 5, I'll have to test the mock integration. So I'll just click on method execution and I'll just click on the test option that you see over here. Now under query string, I'll just enter my string equals my value. And then I'll choose test. So as you can see over here, we have our desired output that says hello from Edureka. Now this basically means that we have successfully created the mock API. Now in case you want to check if the error condition is also working, all you have to do is just go back to the query string text box and just delete some item from there. What I'm going to do is just delete whatever value is present for my string and I'll just leave it as an empty string. Okay, and then I'll click on test. So there it is. You can see the desired message that says this is an error message. So this brings us to the end of this AWS API Gateway.
So what is Amazon SES? Amazon SES, or Simple Email Service, as the name describes, is an email service for sending both transactional and mass emails. It is cloud-based and offers a wide list of possible integrations. You have your SMTP interface, which is your Simple Mail Transfer Protocol, which is a communication protocol for email transmission. As an internet standard, your SMTP is an application that is used to send, receive, and relay outgoing emails between senders and receivers. When an email is sent, it's transferred over the internet from one server to another using SMTP. In simpler terms, an SMTP email is just an email sent using the SMTP server. You also have the AWS SDKs with seamless integration with your applications, and even email clients or other types of software. But then you have your regular email service. Why do you want to use AWS? Now, AWS can boast its reliable infrastructure at a very reasonable cost. Amazon prices are very competitive compared to other solutions available in the market for this particular service. If you check its consumer reviews, you will notice it as the most often mentioned advantage, as with other things on the AWS console. But we are going to take a closer look at the Amazon prices as well as its advantages and disadvantages a little bit later in this Amazon SES tutorial. Here we are just going to discuss the main features and the appeal of Amazon SES. First of all, its high deliverability or its deliverability rate. It's one of the main parameters to consider when choosing an email sending service. Amazon
takes reputation and whitelisting extremely seriously by supporting all three authentication mechanisms, which are DKIM or Domain Keys Identified Mail, which is an email security standard designed to make sure your messages aren't altered in transit between sending and recipient servers. It uses public key cryptography to sign email with a private key as it leaves a sending server. There's also SPF, which allows email senders to define which IP address are allowed to send mail from a particular domain, and it's better known as your sender policy framework. You also have DMARC, which is domain-based message authentication, reporting, and conformance, which is an email authentication protocol which basically uses the sender policy framework. So as a sender, you authenticate your email using SPF and DKIM, and you publish a DMARC record in your DNS. In addition, you can track all of your sending activity and manage your reputation as well. So obviously, it's highly deliverable. Next, you get content personalization with replacement tags. Personalized emails are messages tailored to a specific user, notwithstanding the name. Personalized email are a part of automated marketing. They are created with special templates that become individual due to its dynamic content. Your username, date of birth, location, behavior, all in the app. Each of these parameters change from user to user and may affect the type of information included in the message. With dynamic content, you can personalize emails with the user details or even show different information to different users. It's done with variables or placeholders or merge tags. The most common example is sending a newsletter to a list of subscribers and inserting their first names into the welcoming sentence. I'm pretty sure many of you might have gotten emails that way, which seem sort of generic but also personal at the same time. In this case, you use one template and add a first name tag for personalization. And finally, email receiving. Now with Amazon SES, you can not only send emails, but also retrieve them. In this case, you have a set of flexible options as well as usage of the received message as a trigger in AWS Lambda. Now we won't go into details of email receiving in this Amazon SES tutorial. So if you're interested in this feature, you can obviously read up more on it on the official documentation. Now the most obvious use case for the Amazon SES is supplementing a list of other AWS services you already work with. Amazon SES easily integrates with Amazon CloudWatch, Amazon EC2, Amazon Elastic Beanstalk, AWS IAM, AWS Lambda, Amazon Route 53, Amazon S3, Amazon SNS, and Amazon Workmail. So if your app is hosted in Amazon EC and it sends emails with the simple email service or the Amazon SES, the first 62,000 of your monthly emails will be free. This way, if you host your app on Amazon EC2 and need a scalable way of sending emails, Amazon SES is an extremely beneficial choice. So versatile integration is your fourth point. Another point which is extremely important for a service like this is pricing. So let's take a look at Amazon SES's cost. Now, as I already mentioned, if your app is a part of Amazon EC2 or Elastic Beanstalk infrastructure, then you're eligible for a free tier, and the first 62,000 emails are free every month. For all other cases, Amazon's policy of pay for what you actually use applies. For emails over the 62,000 limit, you will pay as much as 10 cents or $0.1 for every 1,000 emails that you send, plus 12 cents or $0.12 for each GB of attachments. If your app is not hosted on Amazon's server, the cost will be the same. You have 10 cents for every 1,000 emails you send and 12 cents for each GB of attachment. The only difference is that you will start paying from the message sent. This means that the 10,000 emails without attachment will cost you only $1. If each of these messages have 1 MB of attachment, you will add $1.18 to your payment. The Amazon SES email size is limited to 10 MB. This means you can pay up to $3 for 10,000 emails without monthly charges. If you need a dedicated IP address for more security, it will cost an additional $24.95, so not even $25 per month. Again, an AWS calculator where you can go ahead and look for specific and detailed pricing for your requirements. This is very, very helpful in cost estimation. Moving on, let's discuss a few pros and cons of Amazon SES. Now, Amazon services definitely have both fans and haters, but in general, the concept and especially the cost of Amazon SES are more than inspiring. However, even the moon has its dark side. So let's sum up the pros and define the cons. In addition to my own experience with Amazon SES, I've also reviewed what users have to say on certain platforms such as TrustRadius, Quora, and Stack Overflow. So that is going to be my point of reference for this particular section. Let's first look at advantages. Now, the pros of Amazon SES obviously include high deliverability, as we discussed before, and reliability, along with high sending rates. Apart from this, you don't need any additional maintenance once you have it all set up. So obviously, it's pretty low maintenance. Third point is something I shouldn't even have to mention, which is best quality to price ratio. And finally, you also get a comprehensive set of tools for both email receiving and further management of your infrastructure. Since we spoke about this extensively in the features section, this was a brief recapitulation of that segment. But the cons or the disadvantages is what I want to speak slightly more in depth about. So first con, it has a quite complicated initial configuration. Well, I would call it rather detailed and lacking exhaustive documentation, which I think is one of the selling points of most AWS services, that it has really great documentation. You can follow it word for word and you will never face any issue. And you obviously need a good set of documentation when you start working with a new service. But we're going to solve that issue for you with this Amazon SES tutorial. So no problems there. The next point is there are a few initial limitations before you get approved and verify your sending domains. You need to correctly configure Amazon SES and expand your limits by submitting requests. The third reason is that Amazon SES is a simple sending service and not a marketing platform. And it has been advertised that way to all the right, which is fair. However, many users find the lack of template building extremely confusing. If you're not a web developer and you need to send responsive emails with Amazon SES, what should you do? It's kind of a pain that needs a solution. And in addition to this point, Amazon SES does not provide you with an email list storage, so that is on you. Now, because we discussed the cons of Amazon SES, it is only fair that we see how SES compares to other services. It is often seen as an alternate to SendGrid or MailChimp, which are email marketing platforms rather than email sending services. Amazon SES offers both SMTP and API integration. On the other hand, it is simply for email sending and doesn't feature any additional options like drag and drop templates, A/B testing, or detailed analytics. But there are several tools similar to SES with varying functionalities. First of all, you have Mailgun. This is an email service for developers, which you can also integrate with your app via API or SMTP. In addition to email sending, it offers an email list management and validation system. However, compared to the Amazon SES, it's only fair to say that Mailgun is a way more expensive tool. Next, you have ClickSend, which is a dedicated email sending service. You can integrate it via API or SMTP, or use its dashboard for marketing emails as well. And finally, you have PeppyPost, which is an email sending service as well, and this can be integrated via API or SMTP Relay and offers extremely competitive pricing to Amazon SES as well. Now, it is worth mentioning that these are several platforms built on top of Amazon SES. They use it as a delivery service and add extra functionalities like email templates. Email Octopus and Sendy are a few tools that they use. Now that you have decided to go with Amazon SES, or at least experiment with it, which is why I'm assuming you are following this tutorial, then this is the section for you. Now, of course, I'm always going to recommend following the official documentation, which you can look at after this Amazon SES tutorial. Indeed, there are many details that you should be paying attention to when you configure your Amazon SES for the first time. But the official guide has dozens of sections which is interlinked, and it's extremely easy to get lost off a linear track if you're trying to dive in deeper. So I've gathered the most important points here, briefly explain them, and then basically I'm going to show you on my management console how to go about this setup. Now, if you're totally new to AWS, what you need to do first is create an Amazon Web Services account first. Yeah, it's your AWS free tier account. You'll be required to enter your credit card information at the registration stage, but you won't be charged until you start using the paid services. So you can go ahead and select the free plan out of the 3 plans to start, and you will get access to all of the Amazon services. Next, you're going to go into your AWS management console. This is what mine looks like, and select simple email service from the list of services. So let's go on search and type SES. You get the simple email service. I'm going to click on this. Okay. Now what we're going to do is we're going to verify email address identities. Yes, it's a little bit annoying, but it's a matter of security and high deliverability. So what you need to do is verify the email identities that you use. So on the left-hand side, I'm going to go and create my SMTP credentials. Now, to send emails through the Amazon SES SMTP interface, which is the one we're going to use right now, we're going to begin by creating the SMTP credentials, which is a username and a password. So in the left navigation bar, I'm going to click on SMTP settings. And here you can see your server name, your port, your TLS configuration, and your authentication. I'm going to go ahead, click on this blue button which says create my SMTP credentials. All right. Now you will get a form which says this form lets you create an IAM user for SMTP authentication with Amazon SES. Enter the name of a new IAM user or accept the default and create to set up your SMTP credentials. So what you're going to do right now is copy your credentials, because this password will not be shown to you again. So I'm going to open So my SMTP security credentials are here. You have your SMTP username and password. So either copy it or you can click on download credentials. So I am just going to copy it because I already have a notepad open. All right. So I'm just going to click on download credentials. And then I'm going to close it. So next what we're going to do is we're going to verify an email address. So we're going to add and verify our own email address using a few steps. So I'm going to go on to my Amazon SES console. So this is our SES home. We are going to go to email addresses and click on verify a new email address. So now we'll be presented with a dialog here. We are going to enter the email address that we wish to send messages from. So I'm going to type my address and I'm going to click on verify this email address. So now we have a verification email sent to my particular ID. You should just about now receive a verification message from Amazon SES asking you to confirm that you are the owner of this email address. I'm quickly going to go and click on the verification link in my mail. And voila, you have successfully verified an email address, and now you can send emails from this address. So I'm going to go back here to this page and refresh it. I'm going to check the status of the email address. And as you can see, the verification status says verified. Now, all of this is a little bit annoying, but it's a matter of security and high deliverability. And that I have mentioned before. You need to verify all the email identities that you use here using the same process. But remember one thing, that your email addresses are case sensitive, and another important thing in using AWS is its regions. So remember that they are the physical locations of Amazon data centers available to any customer. These regions don't limit the usage of AWS services for you, as their purpose is distributing workloads basically. So when getting started, you don't need to worry about this, but if you want to scale your services, you should remember the corresponding limits. In addition, email verification is connected to the region. The easiest way to verify your email addresses is to use the Amazon SES console. It doesn't require any coding skills, and even if you're not a tech savvy, you will be able to walk through this process within seconds. All you will have to do is enter your email address and then press the link in a confirmation message that you will receive in your inbox. So I'm just going to quickly add like 2 more email addresses. Now, domain verification is a standard procedure as well. You need to add a TXT record to your domain's DNS server. Once your email addresses are successfully verified, you can now start sending emails from them. But note that you need to start in a sandbox mode, which basically means that you can send email to verified email addresses and domains, or to the Amazon SES mailbox simulator only, and you can only send up to 200 messages in 24 hours and only 1 message per second. Sounds complicated, right? A bit, but this is the price you pay for security and sender reputation. However, in my opinion, for experimenting with Amazon SES and understanding how it works, just the basic bare minimum, the sandbox mode is enough. But then again, to move forward and start sending messages to your customers without a need to verify recipients, inboxes, domains, you should basically need to submit a request via the AWS Management Console. In your request, you should describe how you or your enterprise is going to use Amazon SES, build your mailing lists, handle bounces, etc. Now, once you have successfully completed verification, reviewed main AWS definitions, and figured out how all of this actually works, you can move to the email sending. As we have already discussed, you can use SMTP or API. In this particular step, you should define exactly how you would like to send your emails. With SMTP, you can send an email from your application if you are using a framework that supports the SMTP authentication. You can also send messages from software packages you already use, such as your blogging platform, your workflow system, etc. You can also send emails right from your email client, and finally integrate it with a server where you host your app. Servers such as your Postfix, Exim, and other such examples. Now, obtaining the Amazon SES SMTP credentials are fairly easy. We saw it a while ago. These are mine in my notepad, as well as integrating your email client or software package. These options might be a good fit for non-developers as well. API integration, however, requires definite technical skills and can be used to make raw query requests and responses, use an AWS SDK, as well as use the CLI or the command line interface. Now, it's time for you to go from theory to practice. Let's review one of the widely used types of integration, sending emails using Amazon SES. Now, I assume you have already obtained your SMTP credentials and switched your Amazon SES instance to the production mode. If you already haven't, you can just, in your left navigation bar, under email sending, go to sending statistics, edit your account details, and enable production access. You can also do this straight out of your sandbox. Yeah? The good news is that the most complicated and time-consuming part is now behind us. All we have to do is integrate our WordPress with Amazon SES for sending notifications or even newsletters. Now for this, you have 2 options. So now what we are going to do is we are going to send a test email using Amazon SES. So I'm going to go to email addresses. I am going to send a test email from one address to another. You can also send it from one address to itself because that address is verified by us. So I'm going to click on this and I'm going to click on send a test email. From this address of mine to this one, I'm going to select formatted and something simple. Maybe this is a test email. And the email has been sent. All you have to do is go ahead and refresh. And now as you can see, we have our test email saying this is a test email. Okay, now we are going to go back here again, send another test email from the same email address and the same recipient, except for now we are going to use the raw email format. Now, one thing you must have directly noticed is that you have no options in your subject line here. In your formatted email, you have a lot of these options, but when you click on raw, you have no such options. So I'm going to go this, put in your recipient address and your sender's address, and this is a little piece of code. So here I'm going to paste some sample formatted text for this particular email. And you can go ahead and put in your body as well. Now the raw message is a JSON data structure saved in a file named message.json in the current directory. And as you can see, the data is one long string that contains an entire raw email content in MIME format, including an attachment called attachment.txt, which is right here. So I'm going to go ahead and send the test email. And here is the email I sent to myself. It has the sender address and it has the address of the recipient and everything that was there in the email. So all right, that was sending a simple email using the Amazon Simple Email service.
Now let's discuss another terminology, that is DevOps, and then we would understand how AWS and DevOps go well together. So what exactly is DevOps? Now I just talked about software development, right? So when you talk about software development, you have to mention DevOps. Now let's try to understand why. To do that, let me give you this basic definition first. So it is nothing but a set of practices intended to reduce the time between committing a change to a system and the change being placed into normal production while ensuring high quality. Yes, very textbookish. And again, for people who do not know what DevOps is, this might seem a little vague. So let me just simplify this definition for you people. Again, you see an image here. What you see is you see a developer, you see an operator, and there is a deployment wall, which none of these two is ready to take responsibility of. They're pushing their responsibility on someone else. So yes, this is what the scenario is when you talk about software development. Again, let me give you a little more idea about this particular term. So let's try to understand how developers work and how operators work. And when you talk about developers, their responsibility is to create code, to update this code whenever required, wait for the next releases, and if there are any changes, commit those changes, submit those changes, and again, move it to the production environment where the operators take care of it. Then wait for the feedback from the operators if there is any, and then again, go through the changes if there are any. Likewise, wait for newer softwares, newer products to work on. So yes, this is what their responsibility is. Create code, create applications, right? So what happens here is when you do create a software, so there are constant releases that you need to focus on. We all know that every now and then you'd be getting a Windows update or your mobile phone update saying that, okay, you have a new operating system, new release, new version, update it. So this is how the technology is working. Everything gets updated every now and then. So the reason this is happening is people want to stay competitive in the market, the software companies at least, and they want to ensure that their product has the latest features. So this puts burden on the developers because they have to constantly update their softwares. Now, once they update a particular software, it has to go and work in the production environment. But at times it does not work in the production environment because the developer environment and the production environment might be a little different. So something that works in the developer environment might not work in the production environment. So again, some changes are thrown back by the operators and developers again get stuck. So they have to wait till they get the response from the operators. And if it takes a longer while, their work is stuck. Now, if you take a look at it from the operator's perspective, their job is to ensure that whatever is working in the developer environment, it has to work in the production environment as well. They deal with the customers, get their feedbacks, and if there are any changes which need to be implemented, at times they implement it themselves. If there are any core or important changes that are required, those have to be forwarded to the developers. So yes, what happens at times is what works, as I've already mentioned, works in the developer environment does not work in the production environment. And operators might feel that this was the responsibility of the developer, which they did not do, and probably they are facing problem because of it. Again, the customer inputs, if those are forwarded back to the developers team, the operator team has to depend on the developers to make those changes, right? So as you can see, these two teams are interdependent on each other. And at times they feel that somebody else's work, the developers' work, is pushed upon the administrators, or the developers feel that the administrators' team's work is pushed upon their side. So there is this constant tussle which the company owners have to take care of. They have to think as in, okay, if this goes on, how can I generate or produce new releases, new softwares every now and then? This could be a problem, right? So this is what DevOps does. As the name suggests, it is Dev plus Ops. That means it combines the operations team and the DevOps team. When I say combine, they bring in this approach where integration and deployment and delivery, it happens continuously. And the fact that these things happen continuously, we do not see the tussle between these two teams. So yes, as you move further, DevOps helps you unite these two teams and they can work happily together. So this is what happens in DevOps. You code, you plan, you release, there's deployment, there's operations, there's monitoring, there's testing, everything happens in a pipeline. And these are some of the popular DevOps tools that let you take care of all these things. But now, again, this is DevOps in general. You have Git, you have Puppet, you have Chef, you have Ansible, SaltStack that help you automate this process of integration and deployment of your software. But the fact that everything is moving to cloud these days, we are thinking about how can we do all these things on cloud? Do I need to move in these many tools? If you want, definitely you can move all these tools. But a platform like AWS, which is a popular cloud service provider, what they have done is they've ensured that all the requirements of DevOps can be taken care on the platform itself, and you have various services that are made available to you that help you in this process. Now, say for example, you have EC2, right? Instances. Now, you can launch servers at your will. You can launch instances at your will. So if your concern is scaling up and down, AWS takes care of it. You have various services which help you monitor your process. So monitoring is something that is taken care of. There's auto scaling. There are various other services which this CloudFront, which actually lets you create content delivery networks. I mean, you can have temporary caches where you can store your data and stuff like that. So there are various AWS services that actually help you carry out the DevOps or the CI/CD process with a lot more ease. And that is why DevOps and AWS, they form a very good combination or a combo. Hence, we are talking about this term today, that is AWS DevOps. Now that we have some idea about what AWS is, what DevOps is, let's try to understand how continuous integration, delivery, and deployment work with AWS and how they incorporate the DevOps approach. To do that, let's try to understand continuous integration and delivery first. So let's take a look at this diagram to understand this process. So these are the 4 steps that are there. You have split the entire chunk of codes into segments. So guys, think of it as more of your MapReduce kind of an action. I mean, what happens is in your continuous integration and delivery, we are trying to bridge in the gap between the developer team and the operations team, right? So we try and automate this process of integration and delivery. So the fact that continuously you have various software updates, which I just mentioned, right? So what if I have like 50 or maybe 100 developers who are working parallelly? Now there are certain resources that need to be used by everyone, right? So what problem it creates is, suppose if I'm working on a particular code, I work on that piece of code. And if somebody else is working on that piece of code, and we have this central system where the data needs to be stored. So I'm working on this piece of code, I make a particular change and I store it there. Now someone else is working on this piece of code and that someone makes a change and he or she stores it there, right? So tomorrow if I come back, probably I need a fresh copy of this piece of code. What if I just start working on the piece of code that I'm working and then I submit that code there? So there would be an ambiguity, right? Whose code to be accepted, whose code's copy should be made. So we need this central system to be so smart that each time I submit a code, it updates, it runs tests on it and sees whether it's the most relevant piece. And if someone else submits that their piece of code, then tests are run on that piece of code. This system should be able to ensure that each of us next time when we go and pick the piece of code, we get the latest piece of code and we get the most updated one or the best piece of code. So this process of committing the code, putting in that piece of code and automating this whole process so that as it moves further, it also gets delivered and deployed to the production in the similar manner with the tests that need to be conducted is called as continuous integration and delivery. Now, integration, as I've mentioned here, the continuous updates in the source code or the code that I'm building, the code is built, compiled. And when I talk about delivery and deployment, the pieces of code, once they're ready to move to the production environment, those are continuously deployed to the end customer. Now, deployment seems a very easy process, right? I mean, picking up the code and giving to the end customer. No, it's not that easy. Deployment actually involves taking care of all the servers and stuff like that. And spawning up these servers is a difficult task. So automating this process becomes very important. And if you do it manually, you're going to suffer a lot. So yes, this is where continuous integration and delivery comes into picture. Code, it is continuously generated, it is compiled, it is built, then compiled again, then tested, again, then delivered, and made sure that it gets deployed to the end customer the way it was supposed to be. So you can see that there are certain steps here. It says split the entire chunk into codes or into segments, keep small segments of codes into manageable form, basically integrate these segments multiple times a day, which I mentioned that there should be a central system, and then adopt a continuous integration methodology to coordinate with your team. So this is what happens. I mean, you have a source code repository where the developers work, they continuously submit their pieces of code. Now repository, think of it as a central place where the changes are constantly committed. Then you have a build server where everything gets compiled, reviewed, tested, integrated, and then packaged as well. Finally, certain final tests are run to go through the final integrities, and then it goes to the production environment where this process, the building, the staging, and the committing process, it gets kind of automated to reduce your efforts. So guys, when you talk about AWS in particular, you have something called as AWS CodePipeline, which lets you simplify this process. It lets you create a channel or a pipeline in which all these processes can be automated. So let's take a look at those processes as well. First, let's get through the definition part. Let's see what it has to say. I would be blankly reading this thing and then probably we'd be having the explanation part that follows. So as the definition says, it is a code pipeline, which is nothing but a continuous delivery service. We talked about continuous delivery already. And you can use this service to model, visualize, and automate certain steps required to release your software. Something that we've already discussed in continuous integration and delivery. So this is basically a continuous delivery service which lets you automate all these processes. So as I mentioned, automating these processes becomes very important. So once you do use this service, these are some of the features it provides you. It lets you monitor your processes in real time, which becomes very important because we are talking about deploying softwares at a greater pace. So if this can happen at real time, I mean, if there is any change and if it is committed right away, probably you're saving a lot of time, right? You ensure consistent release process. Yes, as I've told you, deploying servers is a difficult task and time consuming task. If this can be automated, a lot of effort is saved. Speed up delivery while improving quality. Yes, we've talked about this as well. And view pipeline history details. Monitoring becomes very important, guys. So what CodePipeline does is actually it lets you take a look at all the processes that are happening. I mean, if your application is built, it goes to the source, then it moves to the deployment. All these processes can be tracked in the pipeline. You get constant updates as in, okay, this happened at this stage. If anything failed, you can detect as in, okay, this is the stage where it is failing, maybe stage number 3, stage number 4. And accordingly, you can edit the stuff that has happened at that stage only. So viewing the pipeline history details actually helps a lot. And this is where CodePipeline comes into picture. So this is what the architecture of CodePipeline looks like. It's fairly simple. Guys, so some of this might seem a little repetitive to you people because the concepts are similar. The concepts which we discussed, those can be implemented by using CodePipeline. So yes, I've talked about these things, but let's try to understand how the architecture works. And we'll be using some other terms and discuss some terms in the future slides as well, which we've already talked about. But each of these services, they do this task a little differently or help you automate these processes. Hence the discussion. So let's see to how much level can we keep it unique, and let's go ahead with this discussion as well. So let's see how the code pipeline works. Basically, there are developers, as I've already mentioned, these developers would be working on various pieces of codes. So you have continuous changes and fixes that need to be uploaded. So you have various services. One of them is code commit, which lets you have an initial source management system kind of a thing, which lets you basically take care of repositories and stuff like that. So it lets you directly connect with Git. I would be talking about Git, what Git is, but for people who know what Git is, if you have to manage your Git repositories, you have a service called as code commit. So this is what happens if there are any changes, those go to the source, your developers can commit those changes there, and then it goes into the build stage. This is where all the development happens. Your source code is compiled and it is tested. Then it goes to the staging phase where it is deployed and tested. Now, when I say tested, these are some final tests that have to be implemented before the code gets deployed. Then it has to be approved manually. It has to be checked manually whether everything is in place. And finally, the code is deployed to the public servers where customers can use it. Again, if they have any changes, as I've mentioned, those can be readily taken from them and it goes back again to the developers and the cycle continues so that there is continuous deployment of code. This is another look at it. It is very simple, but this is more from AWS perspective. So if there are any changes that developers commit, those go to the source. Now, your data is stored in a container called as S3, that is simple storage service in the form of objects. So if there is any change that has to happen, the data is either fetched from the storage container, which is S3, and the changes are built. And then again, a copy of it is maintained in the form of zip. As you can see here, there are continuous changes that are happening and those get stored in the S3 bucket. Now, S3 should preferably be on the region or in the place where your pipeline is. That helps you carry out the process of continuous integration and delivery with ease. In case if you are concerned with multiple regions, you need to have a bucket at each region to simplify these processes. So again, here to the code gets to the source. It is probably submitted to the build stage where the changes happen. A copy is maintained at S3 and then it goes to the staging. Again, a copy is maintained and then it gets deployed. So this is how the code pipeline works. And to actually go ahead and implement all the actions of code pipeline, you have a service or these services, that is your code deploy, build, and code commit in AWS. So these services actually help you carry out some or most of these processes that are there. Let's take a look at those services and understand what do they do. So first and foremost, you have your code deploy, code build, and code commit. So this is not the order in which you deal with these things. Now, these things actually help you in automating your continuous delivery and deployment process. They have their individual commitments. Let's talk about them one by one. First, let's talk about code commit, which is last in the slide. So basically, I talked about moving your piece of code to a central place where you can continuously commit your code and get the freshest or the best copy that is there, right? So code commit, what it does is it helps you manage your repositories in a much better way. I mean, think of it as a central repository. So it also lets you connect with Git, which itself is a central storage or a place where you can commit your code. You can push and pull that piece of code from there, work on it, make own copy of it, submit it back to the main server or your main or central operating place where your code gets distributed to everyone. So that is Git. And what code commit does is it lets you integrate with Git in a much better way. So you do not have to worry about working on two different things. It helps you in automatic authorization, pulling in the repositories that are there in your Git account, and a number of other things. So yeah, that is what code commit does. Then you have something called as code build. As the name suggests, it helps you automate the process of building your code where your code gets compiled, tested, certain tests are performed, and again, making sure that artifacts or the copies of your code are maintained in your S3 and stuff like that. So that is what code build does. And then you have code deploy. As I've already mentioned, deployment is not an easy task. I mean, if we are stuck in a situation where we are supposed to manage the repositories, we are supposed to work on quite a few things. In that case, if we are forced to kind of take a look at the servers as well, spawn new instances, spawn new piece of servers, that could be a tedious task. So code deploy helps you automate these processes as well. So this was some basic introduction to these things. Let's just move further and take a look at the demo so that we can talk about some of these terms and the terms that we've discussed previously in a little more detail. Now, in one of my previous sessions, I did give you a demo on continuous integration and delivery. I believe there were certain terms that people felt were taken care of in a speedy way. Hope that I've explained most of the terms with more finesse this time and in more detail. As we go through the demo too, I would try and be as slow as possible so that you understand what is happening here. So let's just jump into the demo part, guys. So guys, what I've done is I've gone ahead and I've switched into my AWS console. For people who are new to AWS, again, you can have a free tier account with AWS. It's very easy. You have to go and sign in, put in your credit card or debit card details. A free verification would happen and probably you'd be given access to these services. Now, most of these services are made available to you for free for one complete year. Now, there is certain limitation on these services. So you have to follow those limitations. If you cross those limitations, maybe you would be charged, but that happens rarely. I mean, if you want to get started, definitely this 1 year free subscription is more than enough to get hands-on on most of the services. So I would suggest that you create this free tier account. If you've taken a look at my previous videos, you would know that how to create a free tier account. If not, it's fairly simple. Just go to your browser and type AWS free tier, and probably you'd be guided as in what details have to be entered. It's not a complex process. It is fairly simple and it happens very easily. So you just have to go ahead and do that. Once you do that, again, you'd be having access to this console, guys. So once you have an access to this console, you have all the services that you can use. So in today's session, we would be working on a similar demo that we worked in our one of the previous sessions. Here we would be creating an application, a PaaS application, platform as a service application, and we would be deploying that application using our code pipeline. So there would be talking about other terms as well, like code commit, code deploy, and code build. So do not worry, we would be discussing those as well. So this is what the demo is for today's session. So guys, let's start by creating our PaaS application. To do that, we would be using Elastic Beanstalk, which lets you have a ready-to-use template and using which you can create a simple application. Now, this being a demo, guys, we would be creating a very simple and a basic application. So just come here and type Elastic Beanstalk. So when I come to this page, guys, if you've created an application, it would show you those applications. But the fact that if you're using it for the first time, this is the console that you'd be getting. That is why I have created this demo account so that probably we get to see how you can start from the scratch. So if you click on get started, guys, creating an application here is very easy, like extremely easy. You have to enter in certain details only. It takes a while to create an application, understandable. I would tell you why it takes the time, but once it happens very quickly. So all you have to do is give your application name. Let's call it, say, deployment app. I'm very bad at naming conventions. Let's assume that this is good. You can choose a platform, guys. You can choose whatever platform you want. Say PHP is what I'm choosing right now. As I've told you, it's a PaaS service. PaaS, that is platform as a service, means that you have a ready to use platform, guys. And that is why you can just choose your platform. And your Elastic Beanstalk would ensure that it takes care of all the background activities. You do not have to set up your infrastructure. It takes care of it. So once I select the platform, I can use the sample application or use the code if I have. In this case, I would be using a sample code that AWS has to offer. And I say create. There you go, guys. This thing is creating my application. So whatever is happening here, it shows that these are the processes. Now it is creating a bucket to store all the data and stuff like that. So it would take care of all these things, guys. It might take a couple of minutes. So meanwhile, let's just go ahead and do something else. Let me just open AWS console again somewhere else. I hope it does not ask me to sign in again. I've already signed in. So meanwhile, that application gets created. Let me just go ahead and create a pipeline, guys. So code pipeline again. It's fairly simple, guys. What happens here is very easy. I just go ahead and put in certain details here as well, and my pipeline would be created. So do you want to use the new environment or want to stick to the old one? You can click on old, right? And you can go back and create it the way it was done, or you can use the previous environment. I'm going to stick with that. I was very comfortable with that. So let's just stick with it. If you want, you can use the new interface. There's not a lot of difference, certain little or minor differences. So you can just come here and add in the name of the pipeline that you want to create, say demo pipeline. I say next. Source provider. Guys, I would be using GitHub here because I want to basically pick up a repository from GitHub that helps me in deployment. So I need to connect to GitHub for that. It would ask me to authorize. If you have an account, you can always do that so that it can basically bring in all the repositories that you have. So just say authorize. If not, you'll have to sign in once. So my account has been added here, guys. Repository, I need to pick a repository. This is the repository that I would be picking. Do not worry, I would be sharing this piece of code. Or else what you can do is you can just go to GitHub and type AWS CodePipeline S3 code deploy Linux. Now it is a repository given to you by AWS. If you take a look at it and if you type it just the way it is named here from AWS, you should get that repository in GitHub. You just have to go ahead and fork it into your GitHub account, and probably you'd be able to import that repository directly. You can see that repository has been forked here into my GitHub account. You just type the name here, this name, search it, and probably there would be an option here, fork. I forked it, so it does not activate this option for me. In your case, it would be activated. You have to just click on it and the repository would be forked into your account. So I'm getting or importing a fork from my GitHub. I've authorized my account, and then I can just go ahead and do the stuff. Branch, master branch, yes, and just do the next step. Build provider, no build here. I don't have anything major to build, so I don't need to go ahead and provide a build provider. You can use code build, right? Guys, if you want to move or basically deploy your code to EC2 instances, you can use code build if you want. In this case, I have an application in which I have an EC2 instance and stuff like that. So I don't need to go ahead and do any building stuff, hence no build for me. So I say next, deployment provider. In this case, my deployment provider would be my EBS. So we have that option. Yes, select EBS, Elastic Beanstalk, not EBS. EBS stands for Elastic Block Storage. That is a different thing, guys. Elastic Beanstalk. Make sure you do that. Application name, deployment app was the name, right? Yep. And the environment. This is the environment. It creates the environment on its own. I believe that it has created the environment. It says it is starting. I hope the environment has been created. So guys, let's just see whether our application is up and running, so that probably I can pass in the details. Yes, the application has been created, guys. So let's just go back and select this. Say next. Now create an IAM role is what it is saying. So let's say sample. Okay guys, so what happens normally is an IAM user gets created each time you create a role. So in this case, it is asking me to create one. It's access, create a new IAM role, AWS CodePipeline, and I say allow. Successful. So a role has been created. Next step. Now it gives me the details, guys. Basically, it would tell me what are the stuff that I've done. So everything is here. I don't think I need to cross check it. You might just cross check the stuff that has happened and say create a pipeline. So guys, the pipeline has been created here. As you can see, these are the stages that have happened. If you want, you can just go ahead and say release a change. Now these things are happening, guys, and let's hope the deployment also happens successfully. We've just created an IAM user. Let's see whether it falls in place. Everything is in place. As far as the source part is concerned, it has succeeded. And now the deployment is in progress, so it might take a while. Meanwhile, just go back and take a look at this application. So if I open this application, guys, it would give me an overview of what has happened with this application, guys. As you can see, these were the steps that were implemented. Now the application is available for deployment. It successfully launched the deployment environment. It started with everything that it was supposed to do, like create or launch an EC2 instance and stuff like that. So everything is mentioned here, what happened at what time. So this is a PaaS service, guys, and it works in the background. I mean, if you actually go ahead and launch an instance on your own, configure IAM users, configure security groups, it takes a longer while. But what the service does is it automates that process. It understands that you need an EC2 instance. It launches that instance. It assigns security groups, VPCs and stuff like that. All you have to do is run your application on top of it, as simple as that. So it has taken care of everything and run a PHP application for me. So yes, this is what has happened here. If I just go back here, meanwhile, let's see whether our code has successfully run. You can see what has happened here. I've released the change as well. And you can view the pipeline history if you want. You can click on this icon and all the details would be given to you, what happened in what stage. So these are the things that have happened till time. Now guys, let's just go back and take a look at something that we could. So I'm going to come here and say service EC2, because my app launched an EC2 instance. So there should be an instance created by Elastic Beanstalk. See, one instance is running. It has a key pair attached to it as well. So these are the details, guys. I have a public IP associated with it. If I copy it, there you go, copy this IP, and I say run this IP. You have successfully created a pipeline that retrieved this source application from an Amazon S3 bucket and deployed it to 3 instances. It did not deploy it to 3 instances using code deploy. It deployed it to only one instance you see this message that it deployed it to 3 instances is because the code or the repository that I used, it was supposed to deploy it to different instances if there are multiple instances, and hence this message would have made more sense then. But the fact that we've deployed it to only one EC2 instance, it should actually display that message. So the message that you're supposed to give, you can actually come back here and make change to the piece of code that you worked on. If you go to the readme md file, I think this is where the piece of code is. There you go. Okay, no, not here. Okay, where is that file that needs to be edited? Let me just take a look at some other files as well. Yeah, this is the file, sorry. So if you go to the index.file, here is the message, guys. So you can probably make a change to this message. Instead of saying 3, you can say 1 here, edit this piece of code, and then you submit the code again. So when you do launch or type in this IP address, probably that change would be reflected. So guys, what we've done is we've actually gone ahead and created a pipeline successfully. And in that process, we've actually gone ahead and moved or deployed our application from here. So guys, in case if I do go ahead and commit changes to the code that I just talked about, those would get reflected right away in my history when I talk about this pipeline. So it does give you continuous integration and deployment. These are the things that have happened till time. Now guys, let's just go back and take a look at something that we could. So I'm going to come here and say service EC2 because my app launched an EC2 instance. So there should be an instance created by Elastic Beanstalk. See, one instance is running. It has a key pair attached to it as well. So these are the details, guys. I have a public IP associated with it. If I copy it, there you go, copy this IP, and I say run this IP, you have successfully created a pipeline that retrieved this source application from an Amazon S3 bucket and deployed it to 3 instances. It did not deploy it to 3 instances using code deploy. It deployed it to only one instance. You see this message that it deployed it to 3 instances is because the code or the repository that I used, it was supposed to deploy it to different instances if there are multiple instances, and hence this message would have made more sense then. But the fact that we've deployed it to only one EC2 instance, it should actually display that message. So the message that you're supposed to give, you can actually come back here and make change to the piece of code that you worked on. If you go to the readme md file, I think this is where the piece of code is. There you go. Okay, no, not here. Okay, where is that file that needs to be edited? Let me just take a look at some other files as well. Yeah, this is the file, sorry. So if you go to the index.file, here is the message, guys. So you can probably make a change to this message. Instead of saying 3, you can say 1 here, edit this piece of code, and then you submit the code again. So when you do launch or type in this IP address, probably that change would be reflected. So guys, what we've done is we've actually gone ahead and created a pipeline successfully. And in that process, we've actually gone ahead and moved or deployed our application from here. So guys, in case if I do go ahead and commit changes to the code that I just talked about, those would get reflected right away in my history when I talk about this pipeline. So it does give you continuous integration and deployment.
Are you ready to crack your next AWS interview or take your cloud skills to the next level? If it's a yes, well, you're in the right place. Whether you're aiming for your dream job or sharpening your skills, let's make sure you're 100% prepared. Ready to dive in? Let's do this. Before we jump in, a quick shout out to our channel Edureka, where we bring you the best resources to ace your tech interviews and upskill with ease. Now let's start with the basic level questions. The first question is, what is AWS? AWS is nothing but Amazon Web Services, is a cloud computing platform offering over 200 services, including infrastructure as a service, platform as a service, and software as a service. It provides scalable, cost-effective solutions, computing power, database storage, and content delivery services. It helps businesses scale and manage their operations efficiently and affordably. Moving on to the next question. What is EC2? Amazon Elastic Compute Cloud is a web service that enables users to create and run virtual machines in the cloud. It aims to simplify web-scale cloud computing for developers by providing secure, resizable compute capacity. This allows developers to easily run applications and scale them as needed. The next question is, what is S3? Amazon Simple Storage Service is a cloud-based, scalable and secure object storage service that enables users to store and retrieve data from anywhere. It offers industry-leading scalability, data availability, security, and performance. With S3, you can easily manage and scale your storage needs, making it perfect for backups, archives, and handling large amounts of data efficiently. The next question is, what is a VPC? A virtual private cloud is a secure, isolated private cloud hosted with a public cloud. It allows customers to run code, store data, and host websites. VPC roles define which peer devices process, bridge protocol data units, and respond to address resolution protocol requests, allowing for seamless integration with public cloud providers. In simpler terms, a VPC provides a private network within the cloud, giving you control over your resources, network configuration, and security settings, while still benefiting from the scalability and flexibility of the public cloud. Here is the next question. Explain AWS Lambda. AWS Lambda is a serverless computing service that allows users to build applications without managing servers. It's ideal for applications that need to scale up rapidly and scale down to zero when not in demand. It allows users to execute code in response to events like data changes. In other words, Lambda automatically handles the infrastructure for you. So, you can focus on writing code and responding to events without worrying about server management, making it cost-effective and flexible solution for modern applications. The next question we have is, what is autoscaling? Autoscaling is a cloud computing feature that automatically adjusts resource allocation based on a user demand, monitoring metrics like CPU usage and incoming traffic. It allows organizations to scale cloud services like server capacities or virtual machines up or down. In other words, autoscaling adjusts resources automatically to match your needs, ensuring efficient performance and cost savings. It helps handle changes in demand without manual intervention. Here is another question. What does ELB stands for? In other words, autoscaling adjusts resources automatically to match your needs, ensuring efficient performance and cost savings. It helps handle changes in demand without manual intervention. In simpler terms, ELB helps evenly distribute traffic to your servers, ensuring no single server gets overwhelmed. It automatically adjusts to handle traffic changes, keeping your applications running smoothly. Here is another question. Define CloudFront. Amazon CloudFront is a self-service, pay-per-use content delivery network service from AWS that securely transfers global content, including static and dynamic files, without long-term commitments or minimum fees, ensuring high performance and security. CloudFront speeds up the delivery of your website content to users worldwide and protects it with strong security measures, all while being cost-effective and easy to use. Moving on to the next question. What is RDS? Amazon Relational Database Service is a cost-effective web service that enables users to set up, operate, and scale relational databases in AWS Cloud. It enables efficient data storage, organization, and access for business purposes like modeling, reporting, and analysis. An easy way we can say, RDS makes it easy for you to manage your databases, handle your data efficiently, and focusing on using that data for your business without worrying about the underlying infrastructure. The other question we have here is, what is DynamoDB? Amazon DynamoDB is a serverless, key-value NoSQL database service optimized for high-performance applications. It delivers single-digit millisecond performance at any scale, improving relational database performance. Or in other words, DynamoDB allows you to quickly and easily manage your data, giving you fast access to information without the hassle of server management. So, you can focus on building great applications. Moving on to the next question. Explain Route 53. Amazon Route 53 is a DNS web service that connects user requests to internet applications on AWS or on-premises. It translates domain names into IP addresses, allowing computers to communicate and verify reachability, availability, and functionality. Route 53 helps you ensure that when someone types your website's address, it gets directed to the right place quickly and reliably, making sure your site is accessible and working properly. The other question we have here is, what are security groups? A security group in AWS acts as a virtual firewall for EC2 instances, controlling incoming and outgoing traffic. It filters traffic based on rules, allowing users to specify protocols, ports, and IP addresses. These security features are crucial in cloud computing to ensure the security of resources and maintain a secure network environment. In easy way, security groups help you protect your EC2 instances by controlling what traffic is allowed in and out, keeping your resources safe and your network secure. Here is another question. Difference between public and private subnets in AWS. The key differences between public and private subnets in AWS are: in public subnet, resources can access the internet directly. But in private subnet, resources cannot access the internet directly. The public subnet is connected to an internet gateway, but the private subnet has no direct route to any internet gateway. Lastly, public subnet used for public-facing applications like web servers, but the private subnet used for sensitive data and internal applications. Let's move on to the next question. What is IAM? AWS Identity and Access Management is a web service that enables users to control access to AWS resources and services securely. It is a cybersecurity discipline that deals with user access to digital resources and their usage. IAM systems prevent hackers and ensure users have the necessary permissions to perform their tasks, ensuring that only authorized users can access AWS resources. Or in other words, IAM helps you manage who can access your AWS resources and what they can do, keeping your data safe and ensuring that only right people have the right permissions. Let's move on to the next question. Define EBS in Amazon. Amazon Elastic Block Store is a scalable, high-performance storage service from AWS that is designed for Amazon Elastic Compute Cloud instances. It allows users to create storage volumes and attach them to EC2 instances, enabling them to create file systems, run databases, or use them in various ways. EBS is easy to use and scalable. Or in other words, EBS provides you with flexible and reliable storage that you can easily connect to your EC2 instances, helping you store and manage your data efficiently as your needs grow. The next question here we have is, what is SQS? Amazon Simple Queue Service is a managed message queuing service in AWS that enables users to send, store, and receive messages between software components. Introduced in 2004, it decouples and scales distributed software systems and components, supporting programmatic message sending through web service applications over the internet. Or, in other words, SQS helps you manage communication between different parts of your application by queuing messages, making it easier to handle data flow and scale your system effectively. Let's see the next question. What is CloudFormation? AWS CloudFormation is a service by AWS that enables developers and businesses to create and manage AWS and third-party resources in an orderly and predictable manner. It provides templates for defining and setting up cloud infrastructure, allowing users to define and deploy applications and services as code, even without technical knowledge. It simplifies management, scaling, and updating of cloud resources. The next question is, explain Cloud Trial. Cloud Trial is a service by AWS that tracks user activity and API usage, aiding in auditing, security monitoring, and operational troubleshooting. It records all modifications and API calls in an AWS account, enabling the identification of potential security issues and compliance requirements. In simpler terms, Cloud Trial helps you keep track of everything happening in your AWS account, making it easier to monitor security, troubleshoot problems, and ensure you're meeting compliance standards. Let's see the next question. What is the shared responsibility model? The shared responsibility model is a framework that outlines the responsibilities of a cloud service provider and a customer in securing cloud services and data. It suggests that two or more parties play a role in ensuring security of distinct elements within the public cloud environment. AWS is responsible for protecting the infrastructure running all services offered in AWS Cloud. The last question in the basic level is, what is the well-architected framework? The AWS well-architected framework is a set of best practices designed by AWS to help businesses build and operate efficient, secure, and reliable cloud-based systems. It guides how well your architecture aligns with cloud best practices, covering aspects such as operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. In simpler terms, this framework helps you design and maintain your cloud systems by providing guidelines to ensure they are effective, secure, and cost efficient, covering all the key areas of the successful cloud setup. Now let's start with the intermediate AWS interview questions. The first question we have here is, what are EC2 spot instances? In AWS, EC2 spot instances is a virtual server that lets you use extra cloud capacity at a big discount, up to 90% cheaper than regular prices. You can place a bid to use it, and as long as your bid is higher than the current price, you can keep running your server. The next question here we have is, what is Elastic Beanstalk? Elastic Beanstalk is a service that helps you easily deploy and manage web applications on AWS. It supports different programming languages like Go, Java, .NET, Node.js, PHP, Python, Ruby, and even Docker. Elastic Beanstalk automatically handles the setup, such as creating a runtime environment, managing servers, and scaling the application as needed. Moving on to the next question, what is a NAT gateway? A NAT gateway is a service in AWS that allows your private servers to connect to the internet. For example, if your servers need to download updates or access external web services, they can do so through the NAT gateway. The next question we have is, what is an Elastic IP? An Elastic IP is a static, public IP address provided by AWS that you can assign to your resources, such as an EC2 instance, unlike a regular IP address that might change when you stop or restart your instance. An Elastic IP remains the same, making it easier to manage your connections and ensure your server is always accessible at a consistent address. Here is another question. What are S3 lifecycle policies? S3 lifecycle policies are rules that you configure in AWS to automate the management of your data stored in S3. These policies allow you to automatically transition objects between different storage classes based on their age or delete them when they are no longer needed. For example, you can set a policy to move files that haven't been accessed in 30 days to a cheaper storage tier like S3 Glacier, or to delete objects after 1 year. The next question we have is, what is RDS Multi-AZ? RDS Multi-AZ is a feature in AWS that enhances the availability and reliability of your relational database. When you enable Multi-AZ, AWS automatically replicates your database to a standby instance in a different availability zone with the same region. Let's move on to the next question. How does Lambda scale? AWS Lambda scales automatically based on the number of incoming requests. When your function is triggered, Lambda runs an instance of it. And as more requests comes in, Lambda creates additional instances to handle the load. This scaling happens in real time, without any need of manual configuration. Lambda can handle thousands of requests per second, and it scales up and down as needed, ensuring that your application remains responsive under varying loads without any extra infrastructure management. Now let's see the next question. What is a network ACL? A network ACL, that is access control list, is a layer of security that acts as a virtual firewall for controlling inbound and outbound traffic at a subnet level within your VPS. Each network ACL has a list of rules that either allow or deny traffic based on IP address, protocol, or port number. These rules are stateless, meaning both inbound and outbound rules must be explicitly defined. Network ACLs help you protect your AWS environment by filtering traffic before it reaches your instances, adding an additional layer of security. Here is another question. How do you secure S3 buckets? Securing S3 buckets involves several best practices. First, set proper permissions, that is, ensure that only authorized users and services can access the buckets by setting appropriate IAM roles and bucket policies. Then is use encryption. Enable server-side encryption to protect your data at rest, and consider using SSL, TLS for data in transit. Then is enable logging. Set up S3 logging to track access requests. which can help you monitor and audit bucket activity. Let's see the last question of the intermediate level. What are CloudWatch alarms? CloudWatch alarms are monitoring tools within AWS that helps you keep track of your resources by sending notifications when specific metrics exceed defined thresholds. For example, you can set up an alarm to notify you if CPU usage on an EC2 instance goes above 80% for a certain period, or if the available disk space drops below a certain level. These alarms can trigger automated actions like scaling your application, rebooting an instance, or simply sending an alert to your email or SMS. Now let's move on to the advanced level, where we will discuss the scenario-based questions. So here we have the first question. How would you design a highly available, fault-tolerant architecture for a web application that requires minimal downtime during maintenance and unexpected failures? The answer here is, to design a highly available and fault-tolerant architecture, use multi-AZ deployments. Deploy your application across multi-availability zone to ensure high availability. For databases, use Amazon RDS with multi-AZ deployments to ensure automatic failover. Then, implement load balancing. Use an application load balancer to distribute traffic across multiple EC2 instances in different AZs. Then, auto-scaling. Set up auto-scaling groups to automatically adjust the number of instances based on demand and health checks. Next, health checks and monitoring. Use Amazon CloudWatch to monitor instance health and also set up alarms for automatic recovery actions. Lastly, we have blue or green deployments. Utilize AWS CodeDeploy or Elastic Beanstalk's deployment policies for blue or green deployments to minimize downtime during updates. The next question is, your application requires low latency access to data stored in S3, but you have users distributed globally. How can you optimize the data access performance? The answer we have is, implement Amazon CloudFront as a content delivery network to cache and deliver S3 data from the edge locations closer to your users. Additionally, use S3 transfer acceleration to speed up uploads and downloads. Moving on to the next question. Describe how you would secure data in Amazon S3, ensuring that access is controlled and data is encrypted at rest and in transit. To secure data in Amazon S3, firstly, enable encryption. Use server-side encryption with AWS Key Management Service to encrypt data at rest. For in-transit encryption, ensure SSL TLS is used when accessing S3. Next is implement bucket policies. Set up bucket policies and IAM roles to restrict access based on user or service requirements. Then, use access control lists. Configure ACLs to grant or deny access to specific users or groups. Here is another scenario-based question. You need to ensure that a critical application can automatically recover from regional outage and continue to serve users with minimal decryption. How would you architect this solution? The answer is, deploy the application across multiple AWS regions using Amazon Route 53 for DNS failover and AWS Global Accelerator for global traffic management. Implement cross-region replication for databases and use auto-scaling groups across regions. Here we have the last scenario-based question. How would you architect a scalable, fault-tolerant data processing pipeline using AWS services? To architect a scalable, fault-tolerant data processing pipeline, first point is data ingestion. Use Amazon Kinesis data streams or AWS Glue to inject and process data in real time. Next is data storage. Store raw data in Amazon S3 for durability and cost-effective storage. Then we have the data processing. Use AWS Lambda for serverless processing or Amazon EMR for large-scale data processing tasks. Then we have the data transformation. Utilize AWS Glue for ETL operations to prepare data for analysis. Next, data analytics. Use Amazon Redshift or Amazon Athena for data acquiring and analysis. Last we have is the fault tolerance. Implement retries and error handling in Lambda functions and use S3 versioning to recover from data corruption. In summary, preparing for an AWS interview requires a solid understanding of core AWS services, architecture best practices, and hands-on experience with cloud solutions. As focused on key topics like EC2, S3, Lambda, IAM, and VPC, as well as concepts like scalability, security, and cost optimization. Practice explaining your real-world experiences and stay updated on new AWS features. With clear, concise answers and confidence in your knowledge, you'll be well equipped to tackle any AWS-related interview questions.
And with this, we come to an end with our cloud computing full course. If you have enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. Do look up for more videos and playlists and subscribe to the Edureka's YouTube channel to learn more. Thank you for watching and happy learning.